Hey, it's Andrew Brown, your favorite cloud instructor, bringing you another cloud certification course, and this time it's the Databricks Data Engineer Associate. Excited to get this course out to you. I wanted to learn it because I wanted to get better at working with data pipelines, and Databricks is one of the easiest ways to work with data pipelines and learn about data lakehouses, and Apache Spark is used a lot in the industry. So I recommend that you take this course and fill that gap of knowledge that you don't have. If you want to support more courses like this one, the best way to do that is to purchase the additional paid study materials, which will get you access to practice exams, cheat sheets, downloadable lecture slides, and more. You can get that over on the exampro.co website. Look out for the course code or the link to this course, wherever it is. But if you don't know me, I've taught a lot of courses here, AWS, Azure, GCP, Terraform, Kubernetes, DevOps, AI, and more. And so now we're adding Databricks to the list of it. So I hope you are excited as I am to learn about Databricks, and I will see you soon in the course. Ciao, ciao. Hey, this is Andrew Brown, and we're taking a look at the Databricks Certified Data Engineer Associate. So this is a certification if you want general knowledge of Databricks, managing Databricks with data, creating ETL workflows and jobs with Databricks, governance, security, quality of data, and Databricks Apache Spark SQL knowledge. There isn't exactly a course code for this. There's an exam code of PR00054, but it's not something that's marketed to help you know what it is. And that number could have changed, or that could be the newest one. So it's not a really good indicator of freshness or staleness of courses. But we're going to call it the DBDEA just to make our lives easy. That's ExamPro's course code for this. This certification does focus on practical knowledge over conceptual. You do see a lot of code examples during the exam. We made sure that we did a really good job giving a lot of those in the practice exams, and I do my best to do as many labs as I can. This is the first time I'm doing a Databricks course, so anytime I do a new course for the first time, they can be a little bit light on labs and lectures, but my perspective is that there is no study course out there, so I'm going to ship what I have here to you. And if there's interest, I will iterate on this and do more with Databricks. But hopefully this is a good start for some folks here. You should take this course if you need to learn Databricks for work, because it'll give you an idea of the full offering of Databricks. You want to learn more about data pipelines and management. And if you've never worked with a data lakehouse, this is one of the easiest ways to do it. I really didn't understand the ins and outs of lakehouses until I used Databricks. Not because other providers don't have them like AWS, Azure, GCP, but they're so painful to set up and work with, where this is just a breeze. And so it's definitely a great stepping stone if you want to become a data engineer. And yeah, if you want to become a data engineer, this is the reason why you would want to take the certification. Databricks is very, very popular. A good pairing might be with Snowflake. So if I have a Snowflake course, I'd probably package these together. In terms of certifications, they have too many. I don't feel like they should have this many certifications. They really should just have the Data Engineer Associate. This is like a problem with GitHub, where GitHub has too many certifications and they only need to have one or two. But that's fine. They have this many here. And I'm going to recommend that you do the Data Engineer Associate to the Data Engineer Professional. I don't care about the rest. I don't think they're worth your time. There are fundamental accreditations. They're not certifications, which are just basically short courses the Databricks has. You can use them as supplementary to this course. I didn't find the quality to be very good, but they are there, and you can use it to kind of polyfill if there's anything that I have missed in this course. I do want to have a general disclaimer that certifications do not validate programming, technical diagramming, code management. Learning Databricks does not make you a data engineer, but it will give you the knowledge of Databricks paired with these other things. You'll have to get that knowledge elsewhere, which we'll talk about later. How long for this one? I'd probably say 20 hours or 10 hours if you're already experienced. You could probably, average time would be 15 hours. You're going to need 60% lecture labs because you need to spend time doing hands-on, learning lots of SQL and knowing how to work with PySpark. 1 to 2 hours, 14 days is probably a good pace. That's generally what I recommend for most of my courses. Watch the video lectures and memorize the key information so you can pass it. Do the hands-on labs for the ones that I have. I don't have many, so please do the ones that I do here. And I found out that as I was doing the labs, a lot of the things that they said that you could do, you couldn't do. And so I left them in, and we ended up learning other things that were valuable at different times. But just understand that I wanted to give you an accurate representation of what it is to work with a service. And so even though we're supposed to learn something, there are just cases where we can't access stuff. There was a time, like I was trying to show you transactions, and they're like, you got to contact a rep to be able to have that feature. I'm like, really? You have to contact for that? So, I'm going to give you a real view of what it is to work with Databricks. Do the paid online practice exams, because I think this is where we did our best job here. I'd say I did okay with this this course. It's not my favorite, but like in terms of the production that I did on this one. But the practice exam questions are absolutely stellar. So anything that is missing in the video course, it will be filled in via these practice exams, and they'll have detailed explanations for all the cases. Please, please, please make use of these, because they're super, super good. You get them on exampro.co/DBDEA, okay? So it turns out that Databricks uses the same provider as Google, which is Criterion Online, and that is through Web Accessor. It is a proctored exam, and actually Criterion uses AI-assisted proctors as well, so there can be human, but also AI monitoring you as well. Just because it's AI doesn't mean you should cheat. It just means that they have more data points to collect on you. I didn't find the check-in experience to be stressful with Criterion. They're actually really flexible. So like I have a broken laptop right now, and so I have to work on my big desk, and it's very hard to book an exam and do it. But they were very accommodating, and it was very easy. So Criterion's been actually okay these days. Some people like it, some people don't. I'm indifferent, okay? I just don't like PSI Online. They're not very good. Pearson VUE is okay. So let's look at the content outline breakdown. So we have for Databricks, for 10% for the Databricks Intelligence Platform, that's just knowing about the general offerings and things that they have. We have development and ingestion, so working with pipelines, doing jobs, things like that. We have data processing transformation, so maybe working with PySpark, knowing how to use RDD. Just knowing how to do general transformations, knowing about the medallion architecture and the three layers of data moving through your lake house, productionizing data pipelines. So how do you take those into production? I guess data governance and quality. So some of the security features that are in Databricks, and how you should work with your data, and how you can mask and stuff like that. Each domain has its own weighting, determines how many questions each domain, et cetera, et cetera. We've said this many times before. The passing grade is 70%. So I believe it's scored out of 1,000 points, but I don't think it says that. But we'll figure that out as we go. I have GCP here. I do apologize. And so this is supposed to say Databricks. Okay. Sometimes I save time by copying my slides over and adjusting them, and this one did not get adjusted. I apologize. There are 45 questions on the exam, which is really, really low, by the way. This is not a good thing. You think less questions would be better, but because there's less questions, if you get a few wrong, you can be really, really wrong. Okay, so you really don't want to get any questions wrong here. You can only afford to get 13 questions wrong. There's no penalty for wrong questions. The format is only multiple choice. There's no multiple select. So from that regard, it's really easy. But this is why I say you need to go do the practice exams, free and paid, because the pool is smaller. So it's kind of not fair that they did this. They really should have 55 to 60 questions, but that's what they did. So it is what it is. The exam is 1.5 hours, so 2 minutes per question. You have lots of time for 5-minute questions. I did this exam really fast, like incredibly fast. So I wouldn't say that it was hard, but I did feel that they should have had more questions. In the exam. The exam time is 90 minutes. The seat time is 120 minutes. And so seat time refers to the additional time you need to prepare, accept the NDA, show your workspace, review. So make sure you pad your time before and after the exam so you are not stressed out on the exam day. This one's valid for 24 months, for 2 years. I don't know why it's only 2 years and not 3, but that's totally fine. Let's do a little bit of real talk. I do these disclaimers just because people get certifications. They think they can go get a job right away. Understand there are additional skills you need to have in order to get a job. That could be programming, SQL, IT networking, Linux, project management, developer tools, application development skills, comp sci algorithms, and more. You fill these gaps on freeCodeCamp.org, or you get a subscription to Exam Pro. You do my boot camps because those are very comprehensive. They take you through everything. And that's all I wanted to tell you. So we're going to jump into it, and I'll see you soon, okay? Hey folks, it's Andrew Brown. I'm your, instructor. I got to tell you something, because when I was making this course, I ran into a little issue with my screen capturing software. I use OBS. I can actually show it to you here. It's right here, see? And for whatever reason, it decided to clip the last second of audio. And this isn't a problem for labs. And it isn't really a problem. It's just kind of annoying. But when a video gets to the end, or like a lecture one, it'll just make it sound like I didn't finish my sentence. But most of the times for my lecture content, I always have a thing I'll say at the end of it, just out of a habit, like, there you go, and the next thing. So it's not clipping any valuable information, but it's kind of annoying. And I'm going to be honest with you, I really don't want to re-record just because we were missing like useless data. So I do apologize. I'm going to fix my OBS now, but I've recorded 75% of the course. And yeah, I just apologize for that, and just be aware that it's not going to impact. It's just going to be a little bit annoying. Yeah, I'm sorry about it. But anyway, I'll see you through this course and hopefully you enjoy it despite that one little hiccup, okay? Hey, this is Andrew Brown from Exam Pro, and we are looking at the data overview. So the idea here is that we're going to be covering a lot of fundamental, not necessarily Azure-specific data-related knowledge that you need to know to really understand how to use Azure data-related services. So I'll just give you a quick overview here, and then we'll dive deeper into all these things. So the first thing is data. So that's units of information. You have data documents. These are types of abstract groupings of data. You have data sets. These are unstructured logical grouping of data. When you structure your data, now it's called structured data. And then you have data types. These are single units of data that are intended to be used in a particular way. Then you have a bunch of loose concepts. So you have batch and streaming. So this is how do we move our data around. We have relational, non-relational databases or data. So how do we access, query, and search our data? You have data modeling. How do we prepare and design our data? Schema versus schemaless. How do we structure our data for search? Data integrity and data corruption. How do we trust our data? Normalization and denormalization. How do we trade? Quality versus speed. And I'm sure we cover a lot more than just this list. I just didn't feel like being exhaustive here and put every little thing here, because there's so many things that have the word data in it. But let's jump into it. So the first question we should be asking ourselves is, what is data? So data is units of information that could be in the form of numbers, text, machine code, images, videos, audio, or even in a physical form like handwriting. Maybe if you're in the future, it's crystals, I don't know. And so just some images here, or examples of graphics. So here we have an image. Here is a bunch of binary code or machine code. We have a book. Here we have like audio. So we have like audio spectrum here. And then you have mathematical formulas. So I'm sure at this point you know what data is, but just in case you need to just broaden your thoughts of what data is, it really could be everything, including physical stuff. So what is a data type? It's a single unit of data that tells the compiler or interpreter, so a computer program, how data is intended to be used. And the variety of data types will greatly vary based on the computer program. A better way of thinking of it, instead of saying computer program, just say programming language, because that's where you're going to be encountering data types. So let's take a look at the most common data types. The first being numeric data types. These are data types involving mathematical numbers. The most common being integer, which is a whole number, could be negative or positive. A lot of programming languages will have a variety of these that have different ranges, like int 32, int 64, what have you. Then you have floats, or sometimes also known as decimals. This is a number that has a decimal, so 1.5, 0.0, can be a negative number as well. Here it is an example of an int and a float in Python. We'll take a look at text data types. This is a data type that contains a readable or non-readable letters. So there are characters. So characters is a single letter. So it could be A to Z. It could be a digit. It could be a blank space, punctuation, special characters. Then you have a string. And a string is a sequence of characters that can be words, sentences, or paragraphs. They don't necessarily have to be words, but that's usually what you're using them for. So here's an example of a character and a string. Then you have composite data types, and these contain cells of data that can be accessed via an index or a key. So for example, we have an array. So that is a group of elements that contains the same data type that can be accessed via the index and position. You have a hash, commonly known as the dictionary. And if you're using Python, you probably know it as the dictionary. I know it as a hash because I like Ruby, so that's how I know it. And it's a group of elements where a key can be used to retrieve a value. And the thing is that composites they overlap with data structures. So when we talk about data structures, you might say, hey, isn't an array and a hash a data structure? And yes, it is. But yes, it's also a data type. It just depends on the programming language and the constraints around those. Okay, so I know those get a little bit confusing. I just wanted to point that out. But here's an example of, again, this is Python. So we have an array, and then down below we have a Python dictionary. And if you use JSON or JavaScript, yes, a JSON object basically is a hash. We got one more here. So we have binary data types. These are represented by a series of bits or bytes, which either are 0 or 1, so off and on. So here's an example in Python how to set up a byte. For Boolean values, we have true or false. Some languages represent Booleans as a 0 or 1. So a lot of times when you're using like MySQL, a true and false, I think it's 0 and 1 in there. Sometimes it's a T or an F. When you're using PostgreSQL, it's going to be a T or an F. And sometimes it's just true or false. So in Python, it's just capital T true. And actually, I think they have a lowercase true, which is a different kind of object. It's a bit confusing, but I'm just saying there's some variance there. Then you have enumeration data types, or sometimes known as enums. And these are a group of constants, unchangeable variables. So for example, diamond, spade, hearts, and clubs, they're all related because it's card groups. So the idea here is the data type it could be also a data structure. Again, it varies on the language, just like composite types. But here on the right-hand side, we have a shake, and it's wrapped in a class. And below, this is Python. This is how you do it in Python. And so the shake could be vanilla, chocolate, cookies, and mint. A lot of times, enums will map to an integer value or something. So, but not always the case. But yeah, that's that type there. And there you go. That's the common data types. Okay, so let's take a look at schema versus schemaless. So what is a schema? A schema in terms of a database is a formal language which describes the structure of data, a blueprint of a database. And a schema can define many different data structures that serve different purposes of a database. So different data structures in a relational database could be things like tables, fields, relationships, views, indexes, packages, procedures, functions, MXL, schemas, queues, triggers, types, sequences, materialized views, synonyms, can't say that word, database links, and directories. Going to highly vary based on the database that you're using. And I'm just going to show you an example of a schema. So here is actually part of my schema for the Exam Pro app. And so this is a Ruby on Rails schema that defines the structure for a relational database, and it's written in a DSL called Ruby. But the thing is that this is going to highly vary based on, again, what you're using. But just notice that you can see things like creating a table, creating indexes, creating columns for the database, things like that, adding extensions. Schemaless is just it's still a schema, but the idea here is the primary cell of a database can accept many types. So just going back here for a moment, notice here that we have very particular data types like integer, string, and stuff like that. The idea here is with schemaless that data type is a lot more flexible, and the idea there is it allows you to forego the upfront data modeling that you normally would have to do, which is a lot of work. And so that's one of the advantages of schemaless. Common schemaless databases would be key value, document, columns, and then the subcategory of wide columns and graph. And not a lot of information here, but we will describe it in more detail when we talk about NoSQL databases, okay? So what is a data document? A data document defines the collective form in which data exists. So common types of data documents would be data sets, which is a logical grouping of data, databases, which is structured data that can be quickly accessed and searched, data stores, this is unstructured or semi-structured data for housing data, Data warehouses, structured or semi-structured data for creating reports and analytics. Notebooks, data that is arranged in pages and designed for easy consumption. So just to give you some examples, if we're looking at data sets, we might talk about the MNIST data set. For Azure SQL, that would be a database. For a data store, such as a data lake, we have Azure Data Lake. For a data warehouse, we have Azure Synapse Analytics. And for notebooks, we might talk about Jupyter Notebooks, but this could also include, an actual handwritten notebook. So there you go. All right, so what is a data set? Well, a data set is a logical grouping of units of data that are generally closely related or share the same data structure. And so I say data structure there, but I just want you to know that just because something has a data structure doesn't mean it's structured data. It can be semi-structured, like JSON objects or XML files, but generally data sets are unstructured or structured. There are publicly available data sets that are used for learning, statistics, data analytics, and machine learning, the most popular one being the MSNIST database. I can't tell you how many times I've seen this data set, but it's images of handwritten digits used to test classification, clustering, and image processing algorithms commonly used when learning how to build computer vision ML models to translate handwritten text into digital text. And here's an example of that data set there. Another very popular data set is the Commons Objects in Context, the COCO data set. I believe Microsoft had a hand in this one. And it's a data set which contains many common images in a JSON file, a COCO format, that identify objects or segments within an image. So there again, it has JSON files. That means that it's semi-structured, not necessarily structured data. Here is an example of the data set. You can see that there are images and they have borders drawn around things that are trying to identify in the images, such as object segmentation, recognizing context, super pixel stuff segmentation. No idea what that means. 329,000 images, and it has a lot of labels and a bunch of other things in this data set. Another interesting one would be the IMDb review data set, where it has 25,000 highly polar movie reviews, meaning people really like the movie or they really dislike them. I pulled out an example here of Pluto Nash, which at the time was highly liked and disliked. There was a huge split between this movie. Mostly, I think people disliked it, but apparently it's kind of split. This is great for customer sentiment analysis. Again, you'd probably be using ML for this, but the idea is to say, did people like the movies? Or did they like it, hate it, were sad about it? That's kind of like customer sentiment, right? How did they feel? Some other data sets, we have the Free Music Archive. This is a data set of music tracks. So you have 100,000 tracks across 163 genres. You have the, I guess this is library, but LibRe speech, a data set of 1,000 hours of English speech. You'd think they'd use an English word to describe that, but no. There are many more data sets online. Some are paid. Some you have to extract via an API. Some you have to scrape the data yourself. But just taking a big look here of the full list, we got Crunchbase, Glassdoor, FBI, Google Trends, Data Hub, World Health Organization. It's across the board, right? So there's a lot of things that you can get data online, but a lot of times you are just creating your own data sets, but it's good to know that there's a lot of stuff out there. All right, let's talk about query and querying, because those are terms that you're going to need to know because you're going to be doing quite a bit of it if you are going to have a career as anything in data, right? Like a data analyst. So what is a query? A query is a request for data results, also known as reads, or to perform operations such as inserting, updating, or deleting, also known as writes. And so a query can perform maintenance operations on the data and is not always restricted to just working with the data that resides within the database. And you'll see this where there's commands to do analysis on your database and other things like that. But here's an example of a query. So what is a data result? Well, data results is the results of the data returned from a query. So here you generally will see tabular data. That's usually what people want back, but you can get back JSON or XML. It really just depends on the database. What is querying? So this is the act of performing a query. So the idea is that you write your query above and it's being sent as a request. Could be through an SDK, CLI, the shell, an API, lots of ways for it to get there. And then the idea is that the query is going to return the the data results. So what is a query language? That is a scripting language or programming language designed as the format to submit a request or actions to the database. Notable query languages is SQL, GraphSQL, Custo, XPath, Gremlin, and there's a lot of them, but those are ones that stand out to me right now. And just to note up here, this is SQL. Okay, so I just didn't want to make a big old line this way here, but this is SQL here. Okay. All right, so let's compare batch and stream processing. So batch processing is when you send batches, a collection of data to be processed, and batches are generally scheduled. So you might say every day at 1 p.m., but you could also just queue up a batch whenever you feel like it. Batches are not real time, meaning that all the data is sent and then you wait until the batch is back to see the results. Batch processing is ideal for very large processing workloads. Batch processing is generally more cost efficient than stream processing. And so here we just kind of have a representation. So here we have our data. We broke it into batches or collections. We pass it to something like an ETL engine, and it will transform the data, and then we'll insert it into our database, data warehouse, data store, data lakehouse, wherever you want to put it. Then we have stream processing. So this is when you process data as soon as it arrives. You'll have producers, which will send data to a stream, and consumers, which will pull data from a stream. A lot of times a stream will look like a pipeline, and data can be held in that stream for a period of time. So you have a better reusability of data if you need it for multiple consumers. Stream processing is good for real-time analytics, real-time processing, like streaming videos, anything that has to do with real time. If you need it right away, for that purpose, it is much more expensive than batch processing. And here's a visual representation where we have bits of our data. They go into our stream pipeline. They can be held there for a while. And sometimes minor operations will be performed on it, but consumers will pull the data and do what they want with that data. If we want to contextualize these things in terms of services on Azure, the idea is you'd have your data sources and you'd ingest them into something like Azure Stream Analytics, and I didn't really make this graphic very good, but the idea is that you go into Stream Analytics, or maybe you go into HD Insights, or maybe you go into Azure Synapse Analytics, or one of these intermediate steps, and then eventually you go to Power BI to make your visualization reports. For stream processing, you could use Event Hub. So Event Hub is a single topic streaming service, and you could ingest that into Azure Stream Analytics. It's funny because this is the Stream Analytics icon. This is actually the Hadoop icon up here. I just got it mixed up. But anyway, you go into Stream Analytics, and then you could insert that into CosmoDB, and then maybe pull CosmoDB into Power BI. But yeah, that is the difference between the two, okay? A pivot table is a table of statistics that summarizes the data of more extensive tables from a database, spreadsheet, or business intelligence tool. And pivot tables are a technique in data processing. They arrange or rearrange, so pivot, statistics in order to draw attention to useful information. And this leads to finding figures and facts quickly, making them integral to data analysis. So when you're looking at Microsoft Excel, it's very easy to create pivot tables. Think of a pivot table as an interactive report where you can quickly aggregate or group your data based on various factors. So maybe you're grouping it by year, month, week, or day, some average, min, or max. And so over here, I have an example of a pivot table in Excel. I got this from ExcelJet, which they actually have really good information about pivot tables and examples. So if you think that you want to learn more about this, I would go check out that resource. But here, what you can see is that we have a table, and notice that it has these little filters at the top, right? And so the idea is you can drop that down and say sort by date and other stuff. And what that you can do is create, here is another pivot table here where we said, okay, let's sum the sales based on blue and green. So this is a pivot table, and then created another pivot table, okay? And so, it becomes a very useful tool in Excel, all right? And just one more thing, pivot tables used to be a trademarked word owned by Microsoft. So a lot of times pivot tables were specifically just in Excel or their Microsoft Access database. But now pivot tables is a unique term or a general term that everybody uses just for this kind of operations. All right, let's talk about relational data, and this has to do with tables and relationships between other tables. So let's talk about what a table is. It's a logical grouping of rows and columns. So an Excel spreadsheet is actually tabular data. Tabular data just means the data that makes use of table data structures, okay? Then you have views, which look a lot like tables, except they are the result set. So a table, when you do a query, you're returning back data, and you're storing that query's data in memory, and basically it's a temporary or virtual table. Then you have materialized views, and it's the same thing as a view, except the difference here, instead of being stored in memory, it's stored on disk. But again, it's the results of a table, so it's a virtual table. Then you have indexes, and this is a copy of your data sorted by one or more multiple columns for faster reads at the cost of storage. So think of it kind of like a virtual table, but it doesn't include all the columns, and it's just to help you understand what order to retrieve data. You have constraints. These are rules applied to writes that can ensure data integrity. So like if you have a database and you want to make sure that there are no duplicate records, you put a constraint for no duplicates, things like that. You have triggers. This is a function that is a trigger on a specific database event. This is really useful. Let's say after you insert a column in your database, you want to have a UUID. You would have a function that would generate out the UUID. Then you have primary keys. So one or more multiple columns that uniquely identify a table in the row. The most common primary key is ID. A foreign key, so a column which holds the value of a primary key from another key to establish a relationship. Very commonly, it's just the name of the other table with underscore ID. So a relationship is when two tables have a reference to one another to join the data together. I know this text is really boring, but we're just going to cover so much about relational database tables, so I didn't feel that we needed a visual here. But let's keep moving forward here with relational data. So for relational data, we have tables and then the relationship between the tables. Let's talk about those relationships. So relational databases establish relationships to other tables via foreign keys, referencing another's table's primary key. So looking at the example here, this is the primary. There's a little icon here that shows you that it's the primary key. So this is the primary key. And over here in another table, it's referencing a foreign key. So that's the foreign key, that's the primary key, okay? And there are four types of relationships between relational databases and their tables. The first is one-to-one. So imagine a monkey has a banana, or here we have a table called country, and it has a capital. It's one-to-one. Then you have one-to-many. So a store has many customers, or you could say a book has many pages. Notice that this denotes the many here. Then you have many-to-many, so a project that has many tasks, and tasks can belong to many projects, or here a book can have many authors, and an author can have many books, so there's many-to-many. And then last is a variant on the many-to-many, and it's via a join or junction table. I just call them join tables. So a student has many classes through enrollments, and a class has many students through enrollments. So here it's the same thing. A book can have many authors, an author can have many books, but it's all through a library. So you could say a book has many authors through a library, and an author has many books through a library. Okay, so there you go. Okay, so we know that relational databases store tabular data, but the thing is that data can also be stored either in a row-oriented way or a column-oriented way. And let's just talk about the differences there and why we would do that. So the first case, we have row store. The data is organized in rows. This is great for traditional relational databases, which are row stores. Good for general purpose databases, suited for online transaction processing, OLTP. We are going to come back to that term later on. Great when needing all possible columns in a row, which is important during a query. Not the best at analytics or massive amounts of data, all right? When we're looking at column store, data is organized into columns. It's faster at aggregating values for analytics. So the idea is, imagine that you want to count how many cities there are for millions of records. If it's organized by column, like querying based on column, or data is stored together as columns, a lot faster. Generally, these are NoSQL stores or SQL-like databases. It's a bit confusing because like you would think tabular data is just relational databases, but when you want to do column store, they're basically NoSQL stores. So that term's a bit fuzzy there. It's great for vast amounts of data. When we're talking about massive amounts, we're talking millions and millions of records, terabytes worth of data, okay? Suited for online analytical processing, OLTP. Great when you only need a few columns, so you don't need to get data from all the columns. And there you go. Let's talk about database indexes, which is a data structure that improves the speed of reads from the database table by storing the same or partially redundant data organized in a more efficient logical order. And the logical ordering is commonly determined by one or more columns, such as sort keys. They're not always called that. A common data structure for an index is a balance tree, and it's short for B tree, not to be confused with binary tree, which is something else. So you might see B tree and be like, oh, okay, that's how it's doing that. So here we just have kind of a visual. Imagine you have a table or like that's for a phone book, and you want to quickly find people based on the phone number because maybe you're trying to find them based on the starting number being 344 or something. So the idea is you make an index and you say, I want this to index by the phone number. And so what it's going to do is change the order there. So it might just pull the ID or the number and reorder it. And so now what you'll do is you'll use that index, and that index will use as a reference to determine. So it's not storing all the data, but it will use that as a reference to the original table to quickly return you data. And so here's a very easy way to create an index in Postgres. So we'd say create index, and then we give it a unique name, and we'd say, let's make an index on the for our addresses, but just on the phone number. So there you go. Hey, this is Andrew Brown from Exam Pro, and we are looking at non-relational data, and this is where we store data in a non-tabular form and will be optimized for different kinds of data structures. So what kind of data structures? Well, we're looking at key value store. So each value has a key designed to scale, only simple lookups. Then you have a document store. So primary entity is JSON-like data structure called a document. You have column store. Sometimes this falls under relational databases, but it is a non-relational data type or database. So it has a table-like structure, but data is stored around columns instead of rows. Then you have the graph database, where data is represented with nodes and structures where relationships really do matter. And so sometimes non-relational databases can be both a key value and document store, like Azure CosmoDB or Amazon DynamoDB. And the reason for that is that documents are actually a subset of key values, which we'll talk about later when we get to that point. Let's take a look here at data integrity versus data corruption. So data integrity is the maintenance insurance of data accuracy and consistency over its entire life cycle, and it's often used as a proxy term for data quality. Now, you might think it's data validation, but it's just a prerequisite of data integrity because, again, data integrity is all about the entire life cycle, making sure overall that it's going to stay consistent. So validation is just one part of it. The goal of data integrity is to ensure data is recorded exactly as intended. Data integrity is the opposite of data corruption. So data corruption is the act or state of data not being in the intended state and result in data loss or misinformation. And data corruption occurs when unintended changes result when reading and writing. And so in the case when you're doing reads and writes, maybe you have a hardware failure, somebody just inputs the wrong data, or someone intentionally is being malicious to corrupt your data, or there's unforeseen side effects for operator operations via computer code. So you wrote code and you didn't know that it was doing something that it wasn't supposed to be doing. So how do we ensure data integrity? Well, we have a well-defined and documented data modeling. So data modeling, if you know exactly how your data is supposed to be and it doesn't match the model, then you'll know. Logical constraints on your database items. So we talked about that when we talked about all the types of relational data. So constraints will keep that data integrity in place. Redundant inversions of your data to compare and restore. So you have to be able to not just validate your data, but be able to bring it back to the state that it's supposed to be. Human analysis of the data. So, that's where data analysis will just check periodically. Hash functions to determine if changes have been tampered with. You see this quite often when you're downloading open source software or software off like Softpedia, where you can have an MD5 hash to say, did the thing I download match the thing that it was expected? Principle of least privileges. So limiting access to specific actions for specific user roles will mitigate problems that are unexpected with your data. So all that stuff makes up data integrity, okay? Okay, it's time to compare normalized versus denormalized data. So normalized is a schema designed to store non-redundant and consistent data, whereas denormalized is a schema that combines data so that accessing data or querying it is very, very fast. So when we see tables and relationships, like a relational table where everything is very discretely organized, this is normalized data. And then on the right-hand side, where you could take all those tables on the right-hand side and make them one table, this would be extremely efficient. So on the left-hand side for normalized, data integrity is maintained, little to no redundant data, many tables optimized for storage of data. And on the right-hand side, we have data integrity is not necessarily maintained, or there's not good controls in place. You have to do extra work to make sure it is in good shape. Redundant data is common, fewer tables, excessive data storage is less optimal. Now, when you're using relational databases, you can use both normalized and denormalized schemas. And when you are using NoSQL, it's a little bit harder, but like there's cases where you can kind of model things like tables, but generally data is denormalized in NoSQL. So there's a bit more challenge with data integrity, but the upside is you get a lot more performance, right? So it's just way, way faster at scale. Let's talk about data consistency, and this is when data is being kept in two different places and whether the data exactly matches or does not match. So when you have to duplicate data in many places and you need to keep them up to date to be exactly matching based on how the data is transmitted and service level, the service levels of your cloud service provider, they'll use these two terms and we'll hear strongly consistent and eventually consistent. So strongly consistent means every time you request data, so you query data, you can expect consistent data be returned within X time. So they might say within 10 milliseconds, 100 milliseconds, 1 second. So the thing is, we will never return to you old data, but you'll have to wait at least X amount of seconds for the query to return, whatever that defined time is. We talk about eventual consistency. When you request data, you may get back inconsistent data within X amount of periods, so 2 seconds. We are giving you whatever data is currently in the database. You may get new data or old data, but if you wait a little bit longer, it will generally be up to date. Why would we have these two methods? It just depends on your use case. Maybe you can tolerate some data to be inconsistent. It's more important to get whatever data is available now. And sometimes you need an absolute guarantee that the data is one-to-one. Okay, so those are the two different ones. So synchronous and asynchronous can refer to mechanisms of data transformation and data replication. So let's break these two down. So synchronous is continuous streams. I'm just going to mark that there. Continuous stream of data that is synchronized by a timer clock, so you get a guarantee of time of when the data will be synced. You can only access data once the transfer is complete. You get guaranteed consistency of data returned at the time of access, slower access times. So here is the data. And if you're thinking about strongly consistent, that is what this is. This is going to be when things are strongly consistent. Then we have asynchronous, so continuous stream of data separated by a start and stop bits, no guarantee of time, can access data anytime, but may return older versions or empty placeholder. Faster access times, no guarantee of consistency. Here it is. So you see it's moving in bits, right? And so the idea is that we can access any time in between here to get maybe up-to-date data or not up-to-date data. To solidify this, let's put in some scenarios. So a company has a primary database, but they need to have a backup database in case their primary database fails. The company cannot lose any data, so everything must be in sync. The database is not going to be accessed while it is standing by to act as a replacement. So the reason why this works is that, if you have a backup database, you have to make sure all your data is one-to-one. Then on the other side here, a company has a primary database, but they want a read replica, a copy of the database, so their data analytics person can create computational intensive reports that do not impact the primary database. It does not matter if the data is exactly one-to-one at the time of access, because in this scenario, it's like any time the database goes down, you want it up to date to the second. And on this side, it's like they might run reports once a day, whatever. So, there's always new data coming in. It'd be too burdensome to make sure that the data is always up to the second. So there you go. Hey, it's Andrew Brown from Exam Pro, and we were taking a look at data sources. So a data source is where the data originates from. So an analytics tool may be connected to various data sources to create a visualization or report. And a data source could be a data lake, a data warehouse, a data store, a database, a data requested on demand via an API endpoint from a web app, and flat files such as Excel or spreadsheet. And so the example here is that we have a data source and somehow there has to be a connector between them, and it's going to be consumed by either a warehouse, an ETL engine, a data lake, or a BI tool. Those are common ones that need data sources. So extracting data from data sources. So a data tool like business intelligence software would establish a connection to multiple data sources, and a BI would extract data which could be pulled data at the time of report, or it could be pulled data on schedule, or data could be streamed. The mechanism for extracting data will vary per data source. I just want you to know that because when you're using these services, it does really vary on how it pulls the data. So I just want you to understand there are a few different ways, okay? So a data store is a repository for persistently storing and managing collections of unstructured or semi-structured data. So here I have kind of a visual where we have files going into some kind of store. And a data store is a very, very broad term. So it's interchangeably used with databases, though databases is technically a subset of a data store. But generally, a data store indicates working with unstructured or even semi-structured data. So if somebody said a data store, I'm thinking that it's either unstructured or semi-structured, okay? A data store can be specialized in storing flat files, emails, maybe a database, as we said, it was a subset, or designed to be distributed across many, many machines, or it could be a directory service, okay? So that's a data store. So what is a database? A database is a data store that stores semi-structured and structured data. But a better term I would say would be a database is more complex data store because it requires using formal design and modeling techniques. Databases can be generally categorized as either relational databases, so this is structured data that strongly represents tabular data, so tables, rows, and columns. They're generally either row-oriented or columnar-oriented. And when we talk about non-relational databases, we're looking at semi-structured data that may or may not distantly resemble tabular data. And I know that I put this one over on the relational side. Sometimes it ends up here or there. Just understand that that one kind of floats in between the two. It really depends on the technology underneath. And so here is a pretty common way. You get your SQL, you hit the database, you get a table back, right? So databases have a rich set of functionality, specialized language to query, so that is our SQL here, right? We have specialized modeling strategies to optimize retrieval for different use cases, more fine-tuned control over the transformations of the data into useful data structures or reports, the thing here on the end. Normally, a database infers someone is using a relational row-oriented data store. So that's when someone says a database, you're usually thinking like MySQL, SQL, Postgres, MariaDB, things like that, okay? So what is a data warehouse? It's a relational data store designed for analytic workloads, which is generally column-oriented data store. And again, I'm going to make an emphasis here. Sometimes it's non-relational, sometimes it's relational. Don't get too worried about that part, okay? Companies will have terabytes and millions of rows of data, and they need a fast way to be able to produce analytic reports. That's how you know you need a data warehouse, okay? Data warehouses are generally perform aggregations. So aggregations is a grouping of data to find a total or average. Data warehouses are optimized around columns since they need to quickly aggregate column data. And so here is an example where we have our warehouse, and the idea is that we're taking data in from like an unstructured source through an ETL. And then here we have an SQL. These are two different data sources. We use SQL to then get our results, okay? So data warehouses are generally designed to be hot. Hot meaning that the data will be returned very, very fast, even though they have vast amounts of data. Data warehouses are infrequently accessed, meaning they aren't intended for real-time reporting, but maybe once or twice a day or once a week to generate businesses and user reports. Now, can report extremely fast, of course, but it's not like at a per millisecond, running it all day and keeping it all up to date. That's more for a stream, right? A data warehouse needs to consume data from a relational database on a regular basis, or through an ETL, data gets transformed and put in there. Okay. Generally, data warehouses are read only, so you insert data and then you read it. You're not using it for transactional data. Okay. What is a data mart? A data mart is a subset of a data warehouse. A data mart will store generally under 100 gigabytes and has a single business focus. And so a data mart allows different teams or departments to have control over their own data set for specific use cases. So here we have a data warehouse, and we are running queries to then put them in their own little data warehouses. But the idea is that, there are, just smaller data sets that are more focused. Data marts are generally designed to be read-only because you're going to always have to pull data from the main data warehouse. Data marts also increase the frequency at which data can be accessed because they're just smaller data sets. And you don't have to worry about, a huge cost, because the larger the data set you have to query over, the more expensive it gets, right? The cost of query is much, much lower. And so you might even see people accessing these a lot more frequently than they would a data warehouse. So there you go. So what is a data lake? It is a centralized storage repository that holds vast amounts of raw data, so big data, in either semi-structured or unstructured format. A data lake lets you store all your data without careful design or having to answer questions on the future use of the data. So basically, it's hoarding for data scientists. Here is kind of a visualization where you have a bunch of different data sources dropping into the data lake. Maybe you want to perform ETLs and put data back into the data lake, and then you can extract out for reports, ML, all sorts of things. We'll definitely cover data lakes when we get to the data lake section, but this is the general overview here. A data lake is commonly accessed for data workloads such as visualizations for BIs tools, real-time analytics, machine learning, on-premise data. Data lakes are great for data scientists, but it's very hard to use data lakes for BI reporting. So it's not that you can't do it, it's just that there's additional steps, and so there might be a different solution that might be a bit easier, such as a data warehouse. If data lakes are not well maintained, they can become data swamps, which is basically like data corruption, right? So yeah, there you go. What is a data lakehouse? Well, a data lakehouse combines the best elements of a data lake and data warehouse. And this isn't something that Azure has an offering for right off the bat right now, but you can definitely believe that the cloud service providers will have this in the future. So I want you to know about this today, even if it's not on your exam. So data lakehouses compared to data warehouse can support video, audio, and text files, support data science ML workloads, have support for both streaming and ETL, work with many open source formats. Data will generally reside in a data lake or blob store. So the thing with data lake or data warehouses is usually use proprietary formats. So this is a lot more flexible. Data lakehouses compared to data lakes can perform BI tasks very well, which is something data lakes cannot do. Much easier to set up and maintain, has management features to avoid a data lake becoming a data swamp, right? Because data warehouses are very well data modeled and data lakes aren't. So data lakes are kind of in between. And data lakes, and with a data lakehouse, it's going to be more performant than a data lake. So where would you find a solution right now? Probably with Delta Lake, which is a Databricks solution. So it's Apache Data Lake, I believe, is open source. And so if you wanted a managed version of it, Databricks has an offering for that. And so they have this nice little graphic here where they show you that, you combine the two and you get the best of both worlds. So, you'll see more data lakes in the future. So there you go. Hey, it's Andrew Brown from Exam Pro. We are looking at data structure. So what is a data structure? This is data that is organized in a specific storage format that enables easy access and modification. And a data structure can store various data types. So data can be abstractly described to have a degree of structure. So we have unstructured, a bunch of loose data that has no organization or possibly any relation. Semi-structured data that can be browsed or searched with limitations. Structured data that can be easily browsed or searched. So when we look at unstructured data, think of a bunch of loose files. And this is just a screenshot from one of my folders here. So a bunch of stuff. Or semi-structured data, we have XML, or structured data where it's like we're using a relational database. So yeah, there we go. Let's go drill down into these three types of abstractions. So Databricks is a software company specializing in providing fully managed Apache Spark clusters, and the company founders were the creators of the Apache Spark, Delta Lake, and MLflow open source projects. And Databricks has two main offerings, the Databricks platform, and so Databricks cloud-based Spark platform with an easy-to-use web UI, where you can launch fully managed Spark clusters, launch notebooks to write code and interact with Spark, create workspaces to collaborate with team members, and role-based access controls, create jobs for ETL or data analysis tasks that run immediately or on schedule, create ML workflows, and is available on all main cloud service providers, AWS, Azure, and GCP. They also have the Databricks Community Edition, which is a free version of the Databricks platform for educational use. Create a free cluster that terminates after 2 hours when idle, no workspace, jobs, or RBAC. So really it's just a subset of the one above. So Azure Databricks is a partnership between Microsoft and Databricks to offer the Databricks platform within the Azure portal running on Azure Compute Services. And it offers two environments, workspaces. And so basically this is just the Azure Databricks platform with integrations to Azure data-related services for building big pipelines. So if you need to do batching, you can use Azure Data Factory, streaming, Apache Kafka, Event Hub, IoT, storage, Azure Blob Storage, Azure Data Lake Storage. The other side of it is Azure Databricks SQL Analytics. Run SQL queries on your data lake, create multiple visualization types to explore your query results, build and share your dashboards. Now, if you want to launch a Databricks workspace, it's really easy. All you got to do is create a workspace and choose your plan, launch a workspace, use SSO to connect to it, and start your Databricks platform. So if you go up here, and this is in the Azure portal with Azure Databricks, we'll just choose which one we want, and then we launch the workspace, it'll SSO in, and then you're in there. Okay, so basically if you launch, it's not going to cost you any money. So if you want to play around with it, you can do that. Or if you're really antsy, you can just go to the Databricks website and try the community edition, because there's no risk of spending any money when using that. Okay. Hey, this is Andrew Brown, and what we're going to do in this video is sign up for the Databricks Intelligence Platform. So here I'm on the Databricks.com website. We'll go ahead and try this. Now, I've made an account here before, but it's been a while. So we're going to just go ahead and get set up again and see what the experience is like now. So it says, start your free trial. Use the Express setup. So quickly get hands-on. Databricks will manage your account and cloud infrastructure. Use an existing cloud account. So if you have significant data volume in your cloud account or want to manage compute storage, continue with a cloud setup, because there are different cloud service providers. And I think if you're over in AWS, I'm going to log my AWS account, and this goes for maybe GCP and Azure as well, that Databricks will be embedded in there. And so you'll get a similar experience with direct integrations into your services. But before we jump into this, I'm going to log into an AWS account and let's see if we can find it. Okay. All right, so I'm in my AWS account here. And again, GCP, Azure, we can look there as well. I am right now in Japanese. I do apologize, but I'm not going to switch it over because it'll still work. And so I'm going to go over here and type Databricks. Okay, we'll switch languages. This isn't going to work for most people, but we'll go over to here, back to English. And let's see if we can find Databricks. Because I do remember at one point I could access it through here and see here it says Databricks Data Intelligence Platform, deploy on AWS, free trial. So if we go over to here, we can deploy it and utilize it here. Okay. I think for Google Cloud, we can take a look as well at Google Cloud and see if we can find it there as well. So we'll go here and we'll see if it is here, Databricks. And we see Databricks product. So again, looks like we can enable it. Here they're not calling it intelligence platform, but we can enable Databricks. Let's go over to Azure, okay, and look over there as well. We'll give it a moment. Okay, they want me to do this. I'm going to postpone it. Okay, and I will get MFA. Do not worry, I will get it, but today I'm not going to. Oh, they really just will not let me through here. Well, again, MFA is really good, but today I do not want it. Just give me a moment, okay? Oh my goodness, they made that really hard. I think they just purposely made that slow so that next time you do it, then you'll implement it. But if we go type in Databricks, you can see we have Azure Databricks. So I would imagine that even this would launch the intelligence platform. And so I think that there is a difference between this one and this one, whereas there's some best-in-class offerings that are only in this one. But I'm going to go with this one here because I know they have a generous free tier, or they did when I used it last year. Use your work email for the best experience. I'm going to go ahead and Google Cloud. I might already have an account. We'll see what happens here. We'll continue. And we'll get in here. And so, yep, account name is typically the name of your organization. So we'll just say Exam Pro Training Inc. And I guess if anybody joins here, they're going to be the same place. I am in Canada. No, I don't want marketing information. Solve the puzzle. Okay. Match the number of rocks you see in the photo. That's a rock, right? 1, 2, 3. Okay, that's 4. Is that 5? I don't know. Let's go ahead and try that. You got to love these little tests, eh? I already told you I'm in Canada. I think it's just loading here. We'll give it a moment to get in here, getting the account set up. Yeah, we'll just give it a moment here to launch. I don't know if we'll try out the cloud service providers unless it's in the exam guide. I don't think it's necessary. But yeah, whole totally new user interface, a lot more stuff over here. If we're over to trial, we have $40 out of 40 remaining. So we see that we have stuff here, and we got a lot of stuff. So we will work through this here together. But that's how you create an account. I'll see you in the next one. Okay, ciao. Hey, this is Andrew Brown. I'm in my Azure account, and you can do this in AWS and other providers, but I'm going to use Azure for whatever reason. And I'm going to create an Azure Databricks account because I want to see what it looks like. And one thing I want to see is if the compute is different, because this is the Databricks account that I have a premium account attached to, but all I can make is an SQL warehouse, but I can only have one of them. And so they're like, if you go to compute, you can create clusters. Where's that cluster button? I can't find it. And the docs... So like we were say, create a cluster, Databricks, and we're just to go to images here quickly, just so we can see what it used to look like. And this is the old UI. I can tell this is the old UI, but we have here, and it looks like new cluster, create cluster. So it's confusing because on the exam, it's suggesting you're supposed to know these cluster types, and you have these options, but all I can see is the serverless one. I only have one. So even though I already have an account, and I plan to mostly use this one, unless... for some reason we find other stuff, I'm going to create my Databricks account here as well so that we have 2 of them. So you can just watch and see what the result is, or you can do this if you have an Azure account. But I'm only going to show it for Azure here. So I'm going to make a new one here and just say Databricks example. I'm going to go ahead and say OK. It wants a workspace name, so I'll just say my workspace. It might matter what region we launch in. Some things will affect what is accessible and what's not. Notice here we have premium with a role-based access. We have a trial for 14 days, free DBUs. I don't care about that. We have standard Apache Spark Secure with Microsoft Entra ID. I don't fully understand the difference here, but because I know what premium is and we know what it looks like over there, I'm going to go with that. Here it says, enter the name for the managed resource group name. Managed resource group, I don't know. Databricks. Databricks. Okay, so we'll give it a name here. We'll go ahead and hit next. That looks fine to me. This looks fine to me. This is fine. This is fine. And we'll go ahead and give it a moment. We'll create that. And so we'll let that create. I'm not sure how fast it takes to create. We'll give it a moment. We'll come back here when it's deployed. Okay. All right. I think I waited about 5 minutes. And so our resource is complete. Let's go ahead and click through. I'm wondering how it's going to compete with the other one. If it's the same address, maybe it's not. It's been a while. So because I definitely used this when it was the old UI. That's how I remember Databricks. So we will see what is, because to me, it's really different from what it was before. But what I'm interested in is going over to compute. And now we have a create compute button. Okay, so there is clearly a difference between the premium Databricks one and the one that's attached to this. So I guess I will have to intermix these if we want to get the full scope of things. But let's go ahead here and say create. And so, oh, wow, we have a lot of options now. Okay, so here we can drop down. We can choose the version. Notice that we're not seeing any DBUs. Okay, so I guess if we want a serverless one, we'd use that. Can we have a serverless computer? This is all-purpose compute, SQL warehouses. So we have one that's defaulted that says Pro. Okay, so we have one. So that's going to use that. And then I guess if we want other kinds of compute, create personal compute. I'm not sure what create with power user compute. What is that? What is that? I'm not really sure, but I mean, like the regular one here makes more sense. Okay, so, yep, okay, so we have our drop down. That makes sense. All right, so that's all I really wanted to answer in this is if we need our own compute, what is that going to look like and where do we get it? So there it is. We can do a lot in the SQL warehouse. So unless there becomes a reason as to why I would need to spin up individualized compute, I think I'm going to stick with the SQL warehouse within the regular Databricks account, but just understand that those other options that we see are over here, and we will use them when we need them, okay? Let's take a look here at DBUs and DSUs. So DBUs is Databricks unit and is a unit of compute in Databricks Lakehouse. So here's an example of something that you could use in Databricks that is using DBUs. On the marketing pages, they tell you everywhere like /DBUs. It doesn't really help to fully understand usage, but I think that, if you start running workloads and start paying attention, it'll make more sense. But I can't really gauge the cost spend when using Databricks, but that just comes with a lack of practice. Let's take a look at Databricks storage unit. So this is a unit of compute for Databricks managed storage services. So same thing, just a different letter for different stuff. If you want to track your DBUs and DSUs in the consumption cost management service, which is considered legacy at this point, they show you like total DBUs and stuff like that. I don't see DSUs anywhere here, but we have DBUs. There is a new Databricks dashboard. I would show it, but I created it and I don't have any data in it. So I have to wait maybe to the end of the course or when I have some usage to show you. But within Databricks, they have Databricks dashboards, and they want you to use that instead of this because it's more robust. Kind of like if you use Datadog, if you ever use Datadog, they want you to use the tools to then get reporting for the stuff. It's whatever, but it's fine. So that's how you track it. And, in the platform itself, sometimes you will see the amount. So you have the ability to make an SQL warehouse, and there's one that comes by default with you, which is the serverless starter warehouse. And if you go into there, into the edit, you can go see that it's set as 12 DBUs per hour. I don't know why medium to 4x large is commented out. I cannot find any service limit controls or whatever. There is a premium and an enterprise account, so it's possible that what I want to do is in the enterprise account, or it's possible that maybe some of these are locked behind partnerships like through the AWS one. But as far as I'm aware, this stuff is usually managed. So I'm not sure why I don't have access to those other ones. I could do a test to find out, but it doesn't really matter for the certification. Yeah, I mean, there it is. And now you know what DBUs and DSUs are. And when we can, we'll try to pay attention to them and see what the usage is, okay? Hey, this is Andy Brown. Let's take a look at budgets within Databricks. It's a cost management feature that allows you to set an amount threshold and receive an email when that budget has exceeded. So here's an example of me setting a $100 limit across all my workspaces, across all tags. You can see it's still saying the budget and there's no spend yet because I made this and I haven't really had any spend. Here's the formula on the right-hand side. So what can we set? The name of the budget, the scope of workspaces, all or some, tags. So there should be a space between on and tags. I do apologize there, but on tags, right? You can set a threshold amount in USD over here. You can't set the percentage threshold. It's always 100%. So when it hits exactly $100, then it will fire off the alerts. And the alerts right now can only go to emails, but at least they have this feature. If you've used any cloud service provider, you've seen budgets before. It's kind of similar, but I don't think it shows any additional information. I don't think I clicked into this, so maybe there's more information, but at the very least, this will keep you safe on the platform when you are using spend on a paid account, okay? All right, so now that I'm upgraded, one other thing I want to know is how are we going to keep track of our usage so we do not overspend? I feel like the course should have that part of it. Most courses, especially the entry-level ones, will tell you that, but they don't test you on that for some reason. But here I just went to manage, right, to manage my account. And on the left-hand side, I have usage. And so here we have consumption. So improve usage dashboard. I don't have a dashboard yet. We have budgets preview. So I might want to create that. That might be a good idea. And then we have this consumption legacy, usage and cost information from a newer Databricks product. I'm not sure why they're getting rid of this, but maybe they're replacing that. Oh, that's the new one. Okay, so this is the old way. And so we can see here, it's weird that they said I had $40 in the free one, and I didn't run out of it, because you can see down below, we have it. So we have DPUs and the dollars here, okay. So we do get some trackage there, which is nice. But it'd probably be a good idea for us to set a budget. So I'm going to go ahead here and just say $100 limit, because that is a good budget limit that, will be good. So I'll say across all workspaces. I don't need to restrict, but we'll just say 100 USD, okay? Because Baco will be okay if I do that. So here we'll send alerts. So I'll go here and say Andrew@exampro.co, Baco at exampro.co, and I'll do accounts at exampro.co. And that way, we'll just make sure that we're not going over our limit here. So I'll go ahead and create that. And it says separated by commas. Okay, so we'll put a comma there. It's a little bit, this is a little bit hard for me to read. I apologize for not making that larger. And so we'll do this, hit create. And so we now have ourselves a budget. Well, I guess we'll just see it as it updates. We'll go ahead and set up a dashboard. I'm going to set it for the main workspace. Actually, it's account usage, single workspace usage, no account. Why do we have single if it's only single here, but we'll go ahead and do that, I guess. We'll hit, setup usage dashboard. Oh, so we say, okay, we have a workspace and then we import the data. Okay. I mean, I haven't really done a whole lot, so I'm not really sure what we would get here. Oh, I see. So instead of having that fixed consumption page, they want you to use dashboards. So they're trying to get you to use that dashboard feature. Is this useful? Not really, because I can't see anything, but I mean, I was using this prior, so I don't know if it would track data from here to now, but maybe since I've made it here, as far as I'm aware, this doesn't cost anything. So we'll leave this alone, and maybe we'll come back later at the end of the course, and then we'll take a look and see if there's anything interesting here. But I think we're set up to make sure we can keep track of our usage under those pages. Right, and I'll see you next one, okay? Ciao. Hey, this is Andrew Brown. In order for me to show you the full feature set of Databricks, I'm going to have to upgrade from my free tier to subscription. So some videos, very few videos, I'm doing the free tier, but I really have to go to the paid tier early on in order to show you stuff. If you are unable to follow along with a paid tier version, then just watch the videos. But let's see what this upgrade process looks like. So I should be able to go to settings here, and we should be able to find a way to upgrade our subscription. So where could it be? They sure don't make it easy. But if we go here, unlock account. Okay, here. So all we got to do is add our credit card. And it looks like we have you're out of credits. How did I run out of credits? I don't remember even using them. Okay, so I guess I ran out of my credits already. I'm actually surprised at that. Okay, which is fine. But what I'm going to do is I'm going to hook up my credit card and get connected here, and then we will continue on, okay? There we go. So I filled out my credit card information. It says, welcome to Databricks Premium, optimize performance, capacity, increase throughput, etc. Now, could you also do this through a cloud service provider? I think I've done this before, and I do believe then your billing would be through AWS, Azure, or GCP. But because I want this to be Databricks focused, I'm going to use the Databricks platform, but it wouldn't be very hard for us to use those other ones, and we can take a look at those ones if we want. But I'm going to go ahead and hit done here. And so we are upgraded, okay? And so now, one way we would know if we were upgraded or not is if we went to manage our workspaces, which I was going to do in the next video. If we go here and we manage our account, we should be able to make multiple workspaces now. And the button's available. So that's how you upgrade to premium, and I'll see you in the next one, okay? Hey, this is Andrew Brown, and we're going to take a look at the medallion architecture, also known as the multi-hop architecture, Or you could just think of this as an architecture for lake houses. So you can think of it as lake house architecture. So it's a design pattern to logically organize data in a lake house, and it's organized into layers. And you'll notice that the layers, bronze, silver, gold, sound like medallions, badges that you would earn. So that's why it's called medallion architecture. So here we have a diagram. And as you can see on the left-hand side, we have batch and streaming data. So raw data coming into here. And then the idea is that we have our bronze area where we have raw integration. Then we have silver, which is our filtered, clean, augmented data. And then gold, our business level aggregates. So the data is being transformed as it goes along this pipeline. Okay, so each representing increases of data quality and refinement for analytics, reporting, and machine learning. So that should be pretty clear, as if you look at the bottom there, it says landing zone for raw data, no schema needed. Silver, define structure, enforce schema, evolve schema as needed. And gold, deliver continuous update, clean data to downstream users and apps. So pretty straightforward. But let's look at these layers closer and just make sure that we fully understand them, okay? So bronze table data is raw ingested directly from source systems in its original form. And so here on the right-hand side, you can see we have a bunch of sources, and the idea is that it's coming in as raw ingested data. Pretty straightforward, but just in case we don't know, let's keep going here. So ingests raw, often semi-structured or unclean data, typically loaded via autoloader. And when we're talking about autoloader, we're talking about Databricks autoloader, Kafka, or file formats. Used for archiving, reprocessing, and validation, often includes metadata like ingest timestamps. Okay? So then we have silver table data is transformed, filtered, and standardized for analytics or modeling. So here on the right-hand side, the idea we're cleaning, deduping, joining, and then putting it there into that silver table. So data is cleaned, deduped, and joined. Business rules or filtering logic are applied, easier to query and more performant than bronze. Often used by analysts, dashboards, or ML pipelines. Silver table improves quality and performance, preparing data for analytics and ML. Let's take a look at gold table. So this is aggregated or modeled for consumption by business users. Okay, so the idea is that we are bringing in that aggregate data. And then from silver table, that aggregate data is brought in the gold table, which will contain things. It's more refined data like KPI, summaries, or metrics, for dashboards, reports, or stakeholders. Often has dimensions and fact tables for BI tools, optimized for performance and clarity. So gold tables deliver trust-type performance data for business decisions. One thing I just want to reiterate is that all these tables exist. We don't just take the data and move it to the next step. We literally are storing 3 variants of that data so that we can work with that data in those 3 representations. So just make sure you consider that when you're thinking about medallion architecture, not just the fact that it's going through a pipeline to an end source, but stored in 3 different ways at 3 different levels of refinement, okay? Obviously, the lowest being unrefined and the third being the most refined for specific use cases, and the middle giving you the most flexibility. All right, so I want to make sure we clearly understand the difference between control planes and data planes when we're talking about Databricks, as Databricks will separate into these 2. To improve security, scalability, and isolation. And so the idea here is that you interact via the control plane while data processing runs in your cloud's data plane. So let's look in more detail here. So the control plane has a web UI and workspace, job scheduling logic, notebooks and APIs, orchestrates workflows and configurations, where the data plane will have clusters, so that's your actual compute, Spark jobs, code execution, S3, ADLS, GCS. That's so AWS S3, Azure Data Lake Storage, or Google Cloud Storage. Okay, it executes actual data operations privately, and so between these 2, this is where we're getting management and data execution. Like that's the relationship between them. The control plane is managed by Databricks, and the data plane runs in your cloud account. Now, when we signed up really early, right, for the Databricks Intelligence Platform, they had a fully managed one, but underneath it's still using some kind of provider, maybe AWS, maybe GCP, I'm not sure. But one thing you'll notice is that Databricks you can bring to every single cloud service provider. And if you use it, it's going to spin up the same interface, but it's just going to be more specific of what is being backed and where your data is being stored. Okay. So the control plane manages orchestration and UI. The data plane runs computational securely in the cloud. Databricks can't access your data. Well, I mean, it can, because obviously you can see it, but I think what they're trying to say here is that, like, Databricks, the company's not trying to access it, but it's accessing in a secure way that only you are seeing the data, the end data, and they're not seeing the end data, okay? So just to keep reiterating, the control plane runs the interface, the data plane runs your data. So here we have a nice big interface, big graphic here. And so you can see on the left-hand side, users and applications, which will then interface with your Databricks account. Within there, you see the control plane. I'll get my pen out here just so it's easier to follow along. The control plane, so we have that web app, the compute orchestration, so not necessarily computing your app, but orchestrating what to compute. The Unity catalog, which I don't know why they're listed in here, but I guess it's part of it, right? I guess it is it's its own workload that they run on Databricks. So yes, I guess it's separate. Queries and code. Then down below, you have service compute plane. So I think for this, because when you sign up for a Databricks account, they do have service compute. And so this is probably just managed compute that I was just talking about that is somewhere, AWS, Azure, GCP, we don't know. So, but the idea here is that you also have your cloud account, and this is where you can connect your data, generally coming through the Unity catalog, as we will find out in this course, where we have your storage and your compute. And then here, I think this is just to say this is an intermediate way of interacting with it, because you can interact this way or you can interact that way. So it should be pretty clear. So again, control planes manage jobs, UI orchestration, and it's Databricks managed, and data plane executes Spark workloads in your cloud for the data that you control. So there you go. Well, let's take a look at what clusters are pertaining to the Databricks platform. So a cluster is a collection of virtual machines that run Spark. It distributes workload across multiple machines using one driver and multiple workers. So it's used to power notebooks, jobs, pipelines, and there are two main types. We have the all-purpose cluster for interactive development, and then you have job for running automated tasks. Clusters auto-scale and can shut down when idle. Let's take a look at the all-purpose cluster. So an all-purpose cluster provides a shared always-on environment where users can collaboratively develop, test, and explore data interactively. It supports multiple users at the same time. It's used for your notebooks, SQL editor, your data exploration. It stays running to reduce latency between commands. It's ideal for iterative workloads and testing. So on the right-hand side, you got your users. You can see your cluster, you can see the driver, you can see shared interactive session and how it would interact with a VM instance, okay? Then we have job clusters. So a job cluster is a temporary cluster created to run automated tasks like production jobs, ETL pipelines, or scheduled notebooks. It's created for specific workloads. It's used for production jobs or ETL pipelines, provisions and runs during the jobs only. It's shut down automatically once the job is complete. Let's talk about the Databricks runtime. So the Databricks runtime is a versioned environment that defines the core Spark engine, libraries, and ML stack used by the cluster. So see, when you make a new cluster, it's a little bit hard to see there, but you're actually choosing your runtime. So you select your runtime when you're creating a cluster. It includes Spark, Scala, Python versions, and optimized libraries. So there are some variants there. There are some special runtimes available for like machine learning or genomics. It can affect performance, compatibility, and features. It's going to ensure reproducibility across jobs and cluster if you choose the same one. We're seeing technologies like Spark, Scala, and Python, generally what's being utilized here. And you'll see that often, those three here, okay? Let's talk about cluster visibility. So in the clusters tab of the Databricks workspace, not all clusters are visible to all users. Clusters visibility depends on permissions and ownerships. You can filter clusters by all clusters, the clusters that you created, or what running and terminated. Visibility depends on your workspace role or group membership, cluster access settings, so whether it's single user or shared, whether the cluster is set to be visible or all users are restricted. Let's take a look at restarting or terminating clusters. So based on whether you need to reset the environment or stop it, right? So you can restart a cluster, of course. So this will reset the environment without deleting the cluster. It clears cached variables in memory. It fixes broken libraries or runtime errors, and it keeps cluster config intact and reboots drivers and workers. For terminating cluster, it fully stops the cluster to full resources and stops billing. It ends all active sessions and computations. It's used when work is complete or cluster is idle. It must restart or recreate to use. It must be restarted or recreated to use again, okay? And one thing to just note there is that modifying the path incorrectly may break commands, okay? So just consider that last one there. But there you go. All right, so let's take a look at the types of compute that we have. And this is specific to all-purpose compute. So when you go there, you'll see this drop down here. I'm gonna get my pen tool out here. But you'll notice here we have a drop down and we have personal, power, and shared. Now I wrote 2 options. I'm actually wrong. It's 3, but that's actually wrong as well because there's actually more than these options, and I'll explain here in a moment. But for the definitions that I have here, let's just read and understand at least these 2. So personal compute, single node resource for individual use with minimal configuration, ideal for personal development, testing, small data tasks. So personal makes sense. Shared, multi-node, larger resources designed for multiple users within a workspace to share, offering scalable processing for collaborative workloads and complex jobs that require distributed computing. So the reason this doesn't matter is because these are actually just compute policies. So you can create your own compute policies, but when you click on the generic create compute, you can just choose between these options and you can create your own. So we have unrestricted, personal, power user, shared, and legacy shared compute. And the definitions over here determine what you can launch in terms of instance sizes or what Spark versions you're allowed to use or runtime or how many workers you can have and additional things like that. So these are like, if you know AWS IAM policies, this is kind of like the IAM policy for your compute. It would be the best way to equate it, but there you go, okay? Hey, this is Andrew Brown. We want to take a look at creating ourselves our own cluster, compute. I'm going to try to stay again within the main Databricks one with the serverless compute with the premium account. But for compute, the only way we can see it is with one that's connected to a cloud service provider like Azure or AWS. So I'm going to just go into my Azure one here. If you don't want to hook this up or don't do it, just watch and learn. But over here on the right-hand side, we're under compute. So we're under all-purpose compute. And if you notice, we have create with personal compute, but notice this is personal, power user, and shared. So we have a drop-down that's going to help us, but we don't even need to press that because if we go to create, all it's doing is selecting a policy. Well, let's back out here for a second so we can understand what these policies do. So we can create our own policy, okay, and define it. And we can say what libraries we want to have in here and things like that. And what permissions. But let's go take a look at some of the pre-made ones. So here under personal, we'll go to personal. It says use with small to medium data or libraries like Pandas and scikit-learn. Okay, cool. So let's see what we have. So we have the node type. We're allowed to run these. If you know standard DS3, those are Azure instance types or whatever they call them, machine types. I'm in all the cloud providers, so I can't remember the name, but these are the SKUs, the SKUs, that you can launch in Azure. So if we used AWS, I'd imagine that they would have the AWS ones here. If you use Google, the Google ones. Notice we can limit the Spark version. We can say what runtime we use, the number of workers we're allowed to have, which is fixed, and we have a value of 0. The security mode, the pool ID, whether it's allowed, says it's forbidden here, the cluster type, the pool ID, et cetera, et cetera. So I don't know all the settings, but we know enough here. And we can add libraries, or there could be libraries here, or there could be additional permissions. Or there could be, if we had compute that we're running under this, it would show us under here. Same thing with jobs. So it's just not showing us those because there's nothing there right now. So that's fine. We're going to go back over to compute. And I guess what we'll do is launch personal. So I'll go ahead and compute, and I'll drop this down to personal. This is Andrew Brown's cluster, which is fine. We'll drop this down. 17.1 is fine. I don't know much about the difference between the versions. And then we can choose what we want our compute to be. So you might need to look this up separately for the cost. I'm going to go over here to virtual machines because I really don't know what this costs. And if we just pretend to launch a virtual machine here, we can find out the cost, at least in Azure, because they show the pricing right in line. Not all providers do that. So if we go here and drop this like this, this is a standard D3S. So we say standard D3S, I believe it was. Is that what it was? D3S. DS3. DS3. Okay, so we have the series here. So we have version 2. That's a version 2. What is this going to cost us? $200 a month, right? So you have to look at that and say, okay, what am I willing to spend here? But that's the general purpose ones. So we don't have anything that is very cost effective. Now that's based on what the policy allows you to do, but there's probably a bare minimum that we want to have. Now this is per month, so I'm not sure what the per cost hourly is. We'll go ahead and do that. So it's 28 cents per here. So I'm going to spin this up and just see what it's like to spin it up and shut it down. Notice up here, we see a DBU hourly cost. So it says 0.75 DBUs. So which is it? Is it this one or is it that one, right? So because per hour, this thing is only 28 cents, but over here it's saying it's 75 cents. So I would imagine that's going to be its actual price. Notice up here that we do have the toggles on. This is like a new preview thing that I keep seeing all over the place. So if we just change this over, I guess this is the older form. I'm not sure, like it's a simple form. It just looks a little bit different. It's not really much simpler. But we'll go over to here and we'll go back to personal compute. Right, and that automatically affects what we can have. Let's go unrestricted. That means we can access whatever we want. And so now if we go to here, compute, we should have a lot of options. Do we have something cheaper than that? I don't think so. I don't know. I would have to do some work, but I'm pretty sure that the D3 is going to be our cheapest option here. So we'll go back to personal and compute, and that is fine. Also notice that the options change. Let's go back to unrestricted for a second. Yeah, notice we have now the worker type. Well, we had that before. We have min and max, whether it's single node or not. So that's, I guess, that's what it's doing when it's in personal, but it's hard-coded for that. We can enable auto-scaling. We can say to terminate after X amount of minutes. That's actually not a bad idea. So I think what I will do, yeah, I'll just go on unrestricted because who cares? And I'll just say single node because I don't want to spin up more than one. If this is not active for, let's say, 30 minutes, I wanted to shut down just in case I forget. Anything else here? No, that's fine. We'll expand that. Access mode, auto sounds good to me. Logging, I guess we can change our log paths. We can set up an initialization script. So this seems fine to me. Okay, so if we go to JSON, that'll probably be what it would produce. Okay, so here we can see data security mode is data security mode auto. That's our cluster name. Kind is classic preview, whatever that means. It's going to use the Photon engine. There's no case where you wouldn't want to use Photon. It's just, we have a slide on that where I explain what Photon is. It just accelerates the stuff so that it's very efficient to use. Spark or whatever it is, or maybe whatever it is. But we'll go ahead and we'll go create that compute. So we'll wait here and see how long it takes to spin up, okay? All right, so as we're spinning this up, notice here it says the VM size you're specifying is not available. What do you mean it's not available? Operation could not be completed as a result expedient approval of the DDS5 course. It's saying I don't have access to that type. I don't see why I wouldn't. It's right here. Okay, let's go ahead and just select it. I just want to see if I can launch it. So I'm going to go ahead and just launch it here because I want to see if I have availability or if I don't have availability. I have a hard time believing I don't. Yeah, this is the things I run into where I want to show you stuff and then it just doesn't work. And there's no way around it, and there's no way to ask anybody to work through it. But again, we're more focused on passing exam. I'm not sure what's going on here with Azure today. It's really crying. Okay, we'll try this again. I'm not sure, is it spinning one up or? No, so we'll try this again because I just want to see, like, do I have it available? Because if I don't, it wouldn't work here as well, right? So I don't care. We'll put this under Databricks. And I just want to go here and select I don't need this. I'll just make it Linux. It doesn't matter. Ubuntu. And we'll switch this over to all sizes. So we'll say D3, DS3, version 2. Okay, I'm going to select that. And let's go ahead and review and create. Because I just want to see, do I have capacity, right? Because there's service limit stuff. We'll go back to basics. Sure, doesn't matter. We'll go ahead and just give it a name. There we go. Is missing or not valid? What do you want? Just what is missing? Hello world Databricks. I gave it everything it wants. Review create. There we go. Now it's passing for whatever reason. So I don't think I can't launch this, but let's see what happens, right? No, I don't need download and create the resource. Okay, sure, I don't care, yeah. I'm not going to use the key, but I'm just trying to get it to create. So now it's initializing deployment. I just want to see if it fails. Because why would this happen, right? There could be resource limits within here, but I guess I could check. There's nothing to manage, so we go to settings here. And yeah, I wouldn't even know what to load. Let's go take a look at compute. Because we're launching the most generic compute, right? So we'll go back to this. Let's see if our compute even exists here. We have a problem. Quote exceeded operation could not be completed. Minimum new limit required. So current usage is 0. Additional required 4. Learn more here about quota monitoring. I don't know how I would increase it because I clearly can deploy here, but let's see what happens. If this doesn't work, I'll make an account in AWS and then maybe that one will work, okay? So this compute finished deploying, right? Again, this has nothing to do with Databricks. It's just me checking for it, and it works here. So I have the compute. So I have no idea how we're going to get that to work. So what I'll do is I have an AWS account, so I'm going to switch over to AWS. Let's see if we can launch Databricks there. So give me just a moment, okay? So now I'm in my AWS account. I'm going to see if we can launch Databricks from here. So there's the intelligence platform. It says deploy on here. It's totally fine. We'll give it a moment. Request private offer. Just let me launch it. So deploy in AWS, view purchase options. We'll take a look here, see what we have. Hopefully it's not expensive. I always do it through Azure, so I really don't know here. So here, public offer available for purchase. It says Databricks consumption units, $1 per unit. That sounds a lot higher than the 75 cents that we saw in the other place. So here we're just confirming what it is that we want, and that's in USD dollars. I don't need a purchase order number. We'll go ahead and we'll subscribe. And hopefully that is instantaneous. If it's not, maybe I can spin down that compute again and try again. But again, I can only show you what I can do, and I can't spend hours and hours of support here when we just need to learn general stuff, and I don't think we're going to be doing lots of compute. But let's see what we can learn through this debugging experience. But anyway, we'll see if I can get subscribed here, and then we'll try to, if I can get into Databricks on this side of it, we'll then see what we can launch it for compute here, okay? All right, so it's been a while. It says we should be subscribed. So it says you successfully purchased. Now I didn't buy anything. There was no cost up front. It was just what it would cost later on. So let's go ahead and set up our account. So I'm just clicking through here to set up account. Obviously the process is a little bit different. We'll say enable and continue. Choosing create account will open Databricks site in a new tab. You must create a new link to a new Databricks account. So it sounds like here we're linking. Review the required permissions. Required to create an account, and I enroll for deployment if you don't have permissions. I do have permissions. Choosing create account will open a site in a new tab. Can I just configure this way? You must link. Okay, so that's interesting. So with Azure, we didn't have to link one, but I guess with this one, we'll link it. So I guess I'll link my other account here. And I have to sign up manually. So the other one, like the original one, I use Google to connect. So I literally have to type an account here. So I guess what I'll do is I will make a new account. I'll send it to accounts.com. That way Bako will get it as well. That's my co-founder. We'll say Exam Pro Training Inc. Yeah, again, I usually don't do Databricks this way. And so it says we are now linked. That's it. Okay. Next. We'll do North Virginia just so we get everything we want. So it's creating some resources for us. Connect an existing Amazon S3 bucket to your account. No. Everything else will be fine. We'll say I acknowledge. We'll go ahead and hit next. We'll launch the product. And we'll give it a moment there to provision all the things it needs. I think mostly just creating buckets, right? So it says it's creating 27 resources. I'd love to see what those are. It's not really telling us what they are. It's kind of annoying. It's probably just creating a VPC, and a VPC will have a lot of resources in it. So we'll see how this goes. Worst case, we'll at the very least learn how to set the AWS side. I wasn't planning on doing that in this course, but you know, we'll learn what we learn, okay? All right, so it looks like it was attempting to provision. So you'll be redirected to a new tab. It says it failed to open it, but we'll just open the tab anyway, manually. It might have a conflict with this one because they are separate, but I'm going to go ahead and put that email in here, accounts@exampro.co. So it looks like we can't be in both at the same time. And we'll say continue with email, and I guess it just sends us a code. That kind of explains why we didn't see one earlier here. So I'm going to just do this off screen by going to portal.office.com as we use Outlook. If you folks that like Outlook or don't like Outlook, it doesn't really matter, but that's what we use for our company here. And so I'm just navigating to my email, seeing if I get that confirmation here, trying to get past Copilot. Nobody wants to use Copilot. But yeah, once I get logged in here with the thing, it's taking me longer than I thought, but give me a second, okay? All right, so I just pasted that in there, and so we're getting into this account. I think this other one's still open, but yeah, we got a lot of Databricks going on here. And so we'll wait for this to provision. So we'll wait for this to finish, and then we'll continue, okay? All right, looks like we're in. And so let's go into the default workspace. And we'll say open the workspace over here. Sometimes it's a bit hard to get to the workspace, but we'll get there. And hopefully we're in. Okay, great. So let's go take a look at compute. And do we have more options? Looks like we have more options here. I could be mistaken, but we'll go ahead and we'll go to create compute. One thing we'll notice that will be different will be the instance size. I know my AWS instance is a lot better than my Azure ones, but let's go back to single node here. And so my question is like, okay, which one can we utilize? It's going to be the most cost effective, because right now it's going to RD X large fleet. RD fleet X large. And we are not launching a fleet one. Let's go back for just a moment. So we leave this here. If we choose personal compute, will it select for us a more reasonable compute? So here it says an i3X large, which sounds, yeah, so that sounds a lot more reasonable than the other ones. Let's go look up what i3X large costs. i3X large. AWS does not provide you the cost within the platform. You have to look it up separately. And so we'll go over to here and see if we can find pricing. And then we'll go to on-demand pricing. And we will, I mean, the region does matter a little bit, but I'm just curious what it is. And we'll see if that DBU thing shows up again. So we'll say i3X large. I mean, we're not seeing that here. Let's go back here for a moment. Sometimes the compute doesn't show up under, because like there's EC2 compute and then there's other types of compute in AWS, so it might not show up in the same place. Got so many tabs, I can't see what's going on anymore. So we'll close out some of these tabs. This is the Azure one. This is the one that we're on. So this is saying i3X large. Okay, so where is it? i3X large. So it's not showing us it there. So we'll say i3X large pricing AWS. The other thing is we can say AWS Databricks pricing, because they might have their own pricing page just for it. And so we'll go here, learn more. Yeah, so it's a little bit hard to find. I can't find it. That's interesting. But anyway, I'm not afraid of launching up an i3X large. But again, if you are not comfortable, do not do this. It says 30 gigabytes, 4 cores. I noticed this one's like minutes. This looks a lot. Why is it so much higher than the other one? We're going to give it like, I'll say like 20 minutes. I really don't want this up for long. Let's go take a look at advanced. And so the question is, can I launch this? Or do I even have access to launch this? We might run up with the same problem. Over here it says 1 DBUs per price. So we can see the cost over here. If I drop this down and change it, will we see other costs here? Yeah, we do. 1, 2. So you have 1 DBU per cost here. So we'll go ahead and create it. But the thing is, like, what does the DBU equate? Because per sense, it's different per resource here. And so this is provisioning. So let's see if this provisions, okay? And hopefully I don't need to do a service limit increase to get it. I can't find what an i3X large is. If I can't, then we'll call it quits. But at the very least, I did make my best attempt here to show you. But Databus, I know how to increase service limits. In Azure, if we can spin it up in other places, I'm not sure. Say quotas. I don't do this very often, so I always kind of like stumble through this. But like we're in here, while we're waiting, we might as well just take a look. We can find one for Databricks. And I mean, I don't see anything else here. This is an overview. Is there another way we can search for this? I guess we go compute here. Provider, say Databricks. Oops. Technically it is compute. So Databricks. I don't expect Databricks to show up. We'll say D3 here, DS3. So that doesn't show up. So we'll go into virtual machines here. Sorry, virtual machines. New quota request. We're just seeing if we can figure it out. Azure services. Quota type. Man, this is too complicated. I'm getting out of that. I don't even want to do any more of that. That's ridiculous. So we'll go back over to here. This is, yeah, this one's still creating. Okay, so the AWS one is still creating. And did this one ever create? Compute. It looks like it never did. So I'm going to go ahead and delete that one. While we're waiting on that, I'm going to try this one more time. So we'll say unrestricted. We'll go personal use, personal case. D3, we'll say 30 minutes. And we'll go ahead and try that. So if that doesn't work, and that doesn't work, that's totally fine. So now we've got an AWS one spinning up and an Azure spinning one up. I'm going to go get some lunch. I'll come back here. We'll see if any of these actually take, okay? All right, so we are back. And look, the Azure one works. So I guess it was just the luck of a draw, but we're seeing 75 DBUs. I'm not sure if we can get down to 1 DBU for that. The question is like, what is this cost? Which I'm not really sure. So we'll go Databricks pricing, DBUs, and we'll see if we can kind of narrow it down. They do have a pricing calculator here. So I didn't know they even had one till now. So we'll go here and we have all purpose. So let's go over to Azure as an example. Instance type. This is not helpful whatsoever. Like one instance. I guess it depends on what we're on, right? But like, yeah, this is not very useful. We're under the D type, but that's storage. Yeah, no, maybe it is storage optimized, but it's DS3. Is it not a, or are we in AWS right now? That's Azure. Yeah, I don't know. Do we have anything beside? No, we're just fine tuning on demand. And we're not in Asia. We'll say US West. Why do we get models? So this thing, well, I guess that makes sense if it's fine tuning, but this is not helping whatsoever. So we'll go back over to pricing overview. And we are using compute. So I guess that's a data warehouse, right? So we have Azure, AWS, whatever. Yeah, I'm not really sure. So it's kind of hard to figure out what the cost is, but hey, we know what the cost is in here. I just want to know percents. Like even if it's a 75 DPU, what does that equate to? So over here, we have our instance running. We could be launching notebooks on this, which we don't have. Other stuff, it doesn't really tell us a whole lot, but I imagine like, let's say we want to use this compute now. So just trying to think here. How are we gonna touch this compute? Like there is Databricks Connect. So technically, like we could use Visual Studio Code to attempt to connect this. But I'm just kind of wondering, if we go over to here into our workspace, what do we see under here? That's not very useful. If we go to SQL editor, let's see, SQL editor. Can we choose what compute we're using? No. Okay, so my question really is like, okay, I have this compute now. How do I actually use it? All right, just give me a second, okay? One thing I was thinking is maybe we just need to create a notebook. So if we go up to our workspace here, we'll just go ahead and make a notebook really quickly. Okay, this is my notebook. And we're not looking to do anything actually serious here, but we'll just say like print hello world. And what I want to see is if we drop this down, can we select our compute? Yeah, that's the cluster I have. Okay, so then we hit print. We'll just say allow, it's fine. And so then I guess that's how we're going to interact with it. Oh, okay, so yeah, it's straightforward. I was just expecting in the SQL editor, I would have thought that we could choose that as well, just because I'm so used to being able to, I thought we could choose compute here as well. Like see here, but I guess this only gets the starter the SQL warehouse. But for our notebooks, that's fine. Let's go over to our, back to our compute here. We obviously didn't do anything very impressive, but that's fine. But now we can see the notebook attached to it. So libraries, I'm guessing because it's compute, there's probably something we'd want to install. Let's take a look here and see what we can do. So I didn't really cover this in my course because in the exam, they never asked for it. So workspace, volumes, PyPy. So there might be a specific PyPy package or Maven package. So I guess if we wanted to install something very specific, let's try to find a Python library here. Python library for Python Faker library. So we'll go over here. Now we're on PyPy. And so Faker is a library that allows you to fake stuff. And it looks like there's a version 4.0.0. So I'm going to assume that we don't have this, right? So if I go like this and copy this code here, and we go back over to our compute, not here, not there, somewhere here, where is it? Here, we'll go back to our workspace. Okay, into my notebook. And I'm just going to go ahead and copy in this here. And this shouldn't work because Faker is not installed, right? So what I want to do is go back over to here. Let's see if we can install a library from PyPy. So I'm going to say, actually, we just type in Faker. We don't have to put anything else in there. We'll go ahead and install. Now let's see if it installs it. Okay. Now, while we're here, let's go over and see if the AWS one is set up. This is Andrew Brown's cluster with an i3 large. So this one is it running? It is created, but it's not running. The cluster was automatically terminated after 20 minutes of inactivity. Okay, so it was running at some point. I'm assuming when it's not running, it doesn't cost you any money. So you can kind of have these clusters ready to go. And so we'd have to start it back up. And so, yeah, I went for lunch, right? So I thought it would take forever to launch up. Okay, but here we have an event log. We can see when it started, when it was healthy, when it terminated because we didn't use it. Let's see if we can see the Spark UI here. Okay, so a little bit of information about if we had Spark jobs. We're not running those right now, so it doesn't really matter. I guess if we created an app, maybe we could run against it. Oh, we get metrics. Nice. So we can see our CPU, our memory utilization, other additional information. So nothing super exciting. Let's go back over to here. Faker is now installed. So we go back to our notebook. Let's run it again, see if it works. And now it works. So that was as easy as we needed to install stuff. So I'll go over here. And I think like, we'll just, one second. Let's take a look here. Like stopped compute. Does it cost money? Databricks? I don't think it does. So even if it's idle, because you're charged for the allocation of the virtual machine and the DBUs. To avoid costs for idle compute, you should terminate. Is that true, though? If it's not left running? No matter how long you keep the cluster idle? VM cost and DB not based on runtime for Spark applications. So in your case, you'll be charged better to enable auto termination. I mean, I like how this is Andrew. It's not, this is not me. It's just... But we didn't set up for auto termination, did we? If we go down here, it is. It's terminating. So, yeah, I believe that it's terminating, and then this is not costing us anything. So I'm just going to go ahead and stop this. Yeah, I'm going to terminate it. So it is terminated. So these clusters are not going to cost me any money. I'm going to go over to this one. And, you know, if you are not confident with this, if you're concerned that this is going to cost you money, what you can do is you can fully delete it out of here, or just watch. But I'm going to leave them alone. I'm going to see if I accumulate any money. If I spend money, Baker will get mad at me, but that'll be whatever. But whatever, that's fine. So I'm going to go ahead and call this done for now. I've made sure that I spun down. It should be spun down, both these clusters. We'll go over here, compute. I'm not sure why pipelines is showing us stuff. Is there something that happened that it wants to? Nope. So we'll go over here and they'll both stop. So we are in good shape, and I'll see you in the next one, okay? So Workspace is where users interact with Databricks web apps, and it's the central UI environment where data engineers can access tools to build, test, and manage their data pipelines in collaborative analytics workflow. The Databricks web app includes clusters, notebooks, jobs, and repos. If you'll notice there, under there, our workspace, and on the right of it, we actually are in a workspace, and it's very hard to see, but there actually is the notebook here. It's not exactly a Jupyter notebook. It's Jupyter-like, but if you've used Jupyter notebooks, you'll get an idea of that experience here. But the point here is just the workspace collects a bunch of stuff, right? Clusters, notebooks, jobs, repos. The use case for the workspace is developing and running the ETL pipelines, performing data exploration and ad hoc analysis, scheduling production jobs, collaborating on version-controlled code. So again, the workspace is just where you're going to be working with things like your clusters, notebooks, jobs, and repos, and like writing code and interacting with things, okay? Hey, this is Andrew Brown, and in this video, we're going to take a look at setting up another workspace. So here we are already in a workspace, and right now I'm in the Databricks Cloud Platform or Data Intelligence Platform, not the Azure or the AWS hooked up one. But let's go to the top right corner here to Workspace and go Manage Account. On the left-hand side, we'll have Workspaces, and here we can create ourselves a new workspace. So we'll rename our workspace name. So we'll just call this Production. I'm not sure what the best naming convention would be, but whatever you want. Here you can see we can actually change region. So let's say we want to run this in Tokyo. And I guess maybe that'd probably be one major reason as to why you'd want to change your workspace, because maybe you just say like Japan workload. We'll change this actually to Japan prod. So we have a reason for that. So maybe data sovereignty or other reasons, but then we have two options down below. So use an existing cloud account where we could link something, or use service compute with default storage. So because I'm doing that with this account, I'll go ahead and do that. That's again, a major reason as to why you might want to have multiple accounts. And so it looks like it is creating. So while that's creating, let's make our way over to our Azure account. Okay, so if I just go back to Databricks here and log in, I should be able to log into Azure. You can do this with AWS, but I just want to observe. I don't want the book. I want to just observe Databricks.com, what it says under our workspace information. Okay, so we'll go log in here and we'll choose Azure. Right, if you don't have this, just observe and see what I do. Okay, and we're going to go up to My Workspace. We'll go to Manage Workspace, and we'll go to Workspaces. And so we're just observing what is different here. So it says Canada East. The status is running. We have our metastore over here. I'm pretty sure it looks a bit different. We go back over to this one here. We'll open another tab. Here's where it said serverless here. So it says credential name, serverless only. So there's a little bit of a difference. See, it says pricing tier premium. Okay, and so those other fields don't show up there because this is linked directly to our account. So just understand that there's going to be some variation there. But let's go back over to here. And it looks like our workspace is ready. So we obviously have some additional options like setting up permissions. And I guess we can toggle that on for security compliance. But let's go ahead and click on Open Workspace. I'm not sure why there's an update workspace, but let's go ahead and just click into that. Okay, I don't think Workspaces cost any money, as long as you're not running any compute in it. And then now what we can do is we can drop this down and switch between our two workspaces, okay? So that's all I really wanted to show you at this point. But I'm going to go back to my default ones. We're going to close out these other tabs. And if for some reason we need to go to the other one, we'll go to the other one, but I don't think we will. But yeah, that's how you create multiple workspaces, okay? So Databricks notebooks combine code, documentation, visualizations in an interactive environment. So on the right-hand side, you can see something that looks like a Jupyter notebook. I don't believe it's actually Jupyter notebook because it worked a little bit different, but for the most part, if you've ever used a notebook before, you're going to know how to use it. It supports Python, SQL, Scala. I'm not sure if it supported anything outside of that. Maybe R. R might be the one that's missing there, but generally that's all you get here. Supports both Markdown and table chart output. Ideal for ETL workflows, experiments, and analysis. Good integrations for version control development. Notebooks support multi-language and outputs, enabling end-to-end workflows. Pretty straightforward. So there you go. Hey everyone, it's Andrew Brown. In this video, we're going to take a look at notebooks. I believe we've already done notebooks in the setup video, but we're just going to repeat it one more time just to make sure that we absolutely know where they are. Right now, I'm currently in my default workspace, which is in US West 2, in my Databricks Intelligence Platform account, not in AWS or Azure. And under workspace, we can create a notebook from here. I believe we can also do it from here. Let's go ahead and make ourselves a new notebook. Okay, we're going to keep this nice and short. It's not going to be super exciting because we're going to be doing this a lot in the course. And so we're waiting for that notebook to be created. At the top here, we can name it. So I'll just say my first notebook, even though it's probably not our first notebook. And we have options here to change the language. So if we want to change it to Python, we can. Okay, I'm going to just say confirm. So now it's the default language. And here we're going to go ahead and write print. Again, we've already done this, but we'll just do it again just to make sure we know it. Hello world, we'll go ahead and run it. Notice that it's attaching to its compute over here. If we were on our AWS account or Azure account, let's go log in for 2 seconds. Actually, I don't have compute spun up on there, but maybe, no, it's okay. We don't have to do it because I think we did this before, but my point is that there would be other compute options if there were servers here. And so that's fine. I don't think I've ever used the schedule button yet, but it looks like we could run jobs from here. So that's fine. Environment 3 is now the default. Got it, sure. I don't know what environment 2 or 1 is, so that's totally fine. We do have some options here on the left-hand side, which, again, I never, ever touch these, but they are there. The environment tab might be useful to know, just so that you know how much memory you're using, or whether you are attached to an accelerator, or if you have a custom environment, or there's other dependencies you specifically want to put in here. But we did add dependencies. I'm not sure what video it is, but we did add dependencies somewhere else. I don't really remember where, but there is a video for that later on. So we will learn how to do that. Maybe take a look at developer settings. Nothing that interesting. So yeah, I mean, that's pretty much it. So yeah, again, we're going to just keep this light because we'll get a lot of experience as we work through this stuff. So I just don't feel that we need to really focus on notebooks as we'll acquire it as we go. Okay. Ciao, ciao. Hey folks, this is Andrew Brown. What I want to do here is to show you how to create a notebook and how we can run that against our serverless cluster, which I believe is right here. I didn't create it, just came with it. So that's probably our default one here. So if we go to the top left corner, you can see we have a bunch of options, even more options. But what I'm interested in is going ahead and creating ourselves a notebook. Obviously, we can use this using Databricks Visual Studio Code locally, but you know, we should also know how to do things here. Looks like we can generate things with AI, but we do have, we used it in a prior video, maybe the last video here. Let me go find that example for the VS Code extension tutorial, where it just had a little bit of code, right? So here, this one is we're not using Visual Studio Code, we're just going to utilize the same code, but run Python on a cluster, et cetera, et cetera. That's the name of it if you're looking for it. What I'm looking for is just this little code piece here. So we're going to grab that code piece, okay? And I'm just going to dump it in here, right? And so all I want to show you is that there's notebooks here. You can run stuff here. Notice over here it says connect, and so we can see that we are connected to the serverless. I'm clicking to say connect to the serverless compute. So we'll give that just a moment to connect. Okay, there we go. Just took 30 seconds, and now we're now connected. You probably would want to put your imports in a separate cell here. And you can see down below here, we did Shift Enter. We can make another cell. We'll say allow for this. But what I would do is I would take this part here and paste this in down below here. I didn't mean to execute that. I just meant to make a new cell. So I think I'm going to interrupt that because I don't want that to finish. One thing you have to understand is that things are a bit delayed. And again, because I'm using serverless, maybe if we spun up other compute, it will have a better experience. But for now, I'm sticking with that. But notice I'm saying interrupt. I'll give it a moment here to interrupt. There we go. It's interrupted. So now all I want to do is require these. Okay. And that cell's been ran, and then we will run the next cell. There we go. And so we are utilizing our serverless compute. If we go over to here and take a look, you can see 0 to 1, so totally fine. I'm going to see what happens if I click that really fast. I don't think we're going to be able to see it, but I was hoping that that would increment. But anyway, there's notebooks. And when we need to use them, we can use them later. You can see we can change the language. Yeah, nothing super exciting here. Pretty straightforward. But that is fine. And yeah, that's all I wanted to show you, okay? Databricks jobs are used to automate and schedule workloads like notebooks, workflows, or scripts. So there on the right-hand side, you can see that we have a job, and you can see a representation of tasks that are going to happen and things that will be, whether it will trigger or schedule a job. So it supports task orchestration with dependencies, which you can see there on the right-hand side. Can run on job or all-purpose clusters, triggered manually, or on a schedule cron or via API, supports retry policies and email alerts on failure, tracks jobs, job runs, statuses, and execution history. So there you go. Hey, this is Andrew Brown. This video, we're going to set up a jobs so that we can run it. So this shouldn't be too hard to do. Let's make our way over to jobs and pipelines. And if you go to jobs here, we're just going to create a simple job. So this is not going through an entire pipeline. We have a separate video for pipelines, but we just want to do an individual task. It'll just be like hello world as our task. Notice if we go here, we have quite a few options. So we could execute a notebook, a Python script, etc. So we do have a notebook that we made earlier in our workspace. So I'm going to go ahead and select that notebook. It should be my first notebook here. And all it does is print hello world. We have serverless compute here down below. Notice that we can add parameters, but again, that doesn't, I don't know if that really makes sense when we are working with a notebook. I'm not sure exactly how that would work. Apparently we can add notifications if we want to say when this is complete. We might want to go ahead and do that. So let's go ahead and add an email address. I'm going to say andrew@exampro.co. I'm going to set it for success and start just so we can see it. You might get an exam question about these notifications and whether they're integrated, so it wouldn't be a bad idea here. It looks like we do have other integrations here at the top, email, Microsoft Teams, etc., etc. How they set up, I do not know. Maybe you just add it here and yeah, system destination, and probably have to configure something. Yep, this is where we would have to manage our destinations and then add a destination. Okay, and so then there are our additional options. But this should be fine enough. We'll go ahead and hit save. Okay, so that looks good to me. We can adjust our retry attempts and, you know, so no retries and then wait and then etc. So we'll leave it alone here. We have metric threshold. So we have those options there. I don't know what those do. I've never had to use them, so it doesn't really matter. So that is good. So our task is now defined. Over here, we can also set schedules and triggers. But let's see if we can just run this manually first. I just bumped into my microphone. I've never done that before. But we'll see if we can run it manually, and then we can play around with these parameters. Okay, so we'll go ahead and create that task. Okay, so our task is now created. And let's go ahead and run now. Okay, we'll go ahead and view the run. Okay. And we'll give it a moment to run. Okay, I'm just going to pause there. It shouldn't take too long, but I'm going to pause just to save us some time. And while that's going there, I just want to show you that we got a started email. So here we can see the job was started manually and the information that happened there. And I believe it is still running. We can give it a hard refresh, see how it's going. It shouldn't take that long. But yeah, with that dedicated compute, it'd be a lot faster if it was hot, so to speak. So yeah, we're just going to wait for this to finish. We can also turn on the flow, but again, there's only one item, so there's nothing for it to flow to. But we'll just wait for that to complete, okay? All right, so I've been waiting a considerable time here. The duration's been 5 minutes. I'm not sure why the execution is taking so long. Waiting for cluster. Is the cluster not available? So let's take a look at our compute. Maybe there's more than one task running. So 0 out of 1. Serverless starter warehouse. So we're going to go back over to here. Manually, okay. Compute. We can go to query history. Let's take a look here. Nothing. Oh, there we go. It ran. So yeah, it was unusual that it took that long. Again, it's serverless compute, so it's shared compute, so I guess you're waiting for it. But I think that it should have executed a lot faster. But here we're seeing the output of the hello world, so nothing super complicated. But we'll give it a moment there to finish executing. But yeah, I was just like, why are we 5 minutes in and it's not done? But we'll give it a moment, okay? Okay, so we ran hello world, and it took 6 minutes and 50 seconds, so that is great. There's nothing to repair on the run. The run is fine, but let's go ahead and see if we can edit this and just change the way it performs. Because we obviously have other modes like scheduling and triggers. So we're going to edit this task. And let's go ahead and add a trigger. So we have scheduled, file arrival, continuous. So if we were to drop a file in here, that would happen. Schedule would run on schedule. Continuous would just keep happening. So we'll go ahead to schedule. We have simple and advanced. Okay, so I mean, we could set it for the day now. So right now my time is, 11:57. So what I'm going to do is I'm going to set this to noon. Hopefully, is it 24 hours? It is. Okay, so that will execute shortly here. I like that it actually has it in this other mode, so I wasn't sure if we would have that, but we'll go ahead. It says UTC. We'll do this Eastern. Otherwise, I'll be here all day. So Toronto, maybe. Eastern time zone. There we go. We'll go ahead and hit save. And if I check my time, it's still 11:57. So we're going to have to chill here for a little bit and come back and see if this executes. If we go to job and pipelines, maybe we can see that it's scheduled. So there it is on the schedule. And we had a recent run because we ran that ourselves manually. But we want to come back and see if that actually occurs, okay? So I'll just pause and we'll be back in a bit. All right, we are back and we can see that there is another run. So that was successful. It'd be interesting to see if we can get the trigger to happen when a file is placed in here. Also, just notice here, I wasn't really paying attention to what I clicked through here. Did I click on that? Oh, I did. Okay. No. Click here. Yeah. Okay, great. And so here we can see our previous runs. All right. So what was initialized and the time it took. So you can see for the most part, we're looking at 6 minute at a time execution down below here. So both are the same. So I guess it wasn't unusual. Still seems really, really slow though. But that's going to happen every day. Let's go ahead and see if we can add another trigger. I guess we can only have one trigger at a time. Okay. So let's go ahead and then I guess edit the trigger. I was hoping that we could have multiple triggers, but I guess we can only have one. I'm not sure. Let's go back here and see if we can edit it at this top level. And then we can add, because I could have swore we could have multiple triggers. Yeah, we have the one trigger here. Edit trigger. Active paused. Okay, let's go ahead and pause that. Can we then add the other trigger? Nope. Okay, so let's go ahead and delete that trigger. We'll add a trigger. All right, so I guess we can only have one trigger at a time. So let's go back here for a moment. File. Oh, that's for file archival. Well, I don't really want to do that. I was thinking that maybe when we put it in a file, we could trigger it. So that's not exactly what I want to do. But we did show the schedule, so I think that is good enough. So, yep. I mean, at this point, if we're adding other tasks, we're basically making a pipeline, and that's not what we want to do here. But I would say that I think we achieved what we wanted to achieve here, and that's a simple example for jobs, and we'll leave it at that. I'm going to go ahead and delete this job as I do not need it anymore. I'll see you in the next one, okay? Ciao, ciao. Databricks repos integrate with Git for version control, enabling collaboration directly in their workspace. So there on the right-hand side, you can see that we are creating a repo right under our workspace, though as of recent, I've been having a bit hard time finding them. And so in the bottom, you can actually see, which looks like a Git repo. You are committing things there, but the idea is that it's integrating with an existing version control system. So it supports Git providers like GitHub, GitLab, Azure DevOps, syncs notebook scripts and tracks changes, performs Git operations, clone, commit, push, and pull, views diffs, commit history, resolve conflicts, works with multiple branches directly in the UI, supports CI/CD workflows. And so there, obviously, there are workflows that GitHub has and other ones like that. But yeah, basically Databricks repos integrate Git for version control, right? That's what it's doing. And it's utilizing support for other providers underneath. Hey, this is Andrew Brown, and I just wanted to call out the difference between repos versus Git folder. So it's been renamed from repo to Git folder, even though the exams, at least at the time that I'm recording this, the exam guide still says repo. They've renamed it, so I'm not sure if they renamed it while I was in the middle of making this course, but it's been renamed. So just when you hear repos, think Git folder, which is whatever. It's fine either way. Okay, so Git folder is repos. And in the labs, you'll see me using Git folder. Hey, this is Andrew Brown, and we're going to take a look at creating a repo now known as Git folder. So if we go to the top here, we're going to notice if we go to more, we can get Git folder here. If we go to workspace, we can also find it over here. Right there is a Git folder. So we'll go ahead and create a new Git folder. And the idea is that we can tie ourselves a repository. So I'm going to make my way over to GitHub. We have multiple providers here, so we can use whatever we want. But we're going to use GitHub as it's the easiest for me to use. I'm going to go ahead to GitHub here, and we're going to go ahead and create ourselves a new repository. I'm going to make this under Exam Pro. This will be a Databricks example GitHub folder. This is an example repo to connect connect to Databricks Intelligence Platform. We'll just say platform. And we'll make it private because I feel like that would be probably the most common use case. We don't have anything in this repository. I'm going to hit period on my keyboard. I'm logged into GitHub so we can go ahead and do this. Probably should have done this sooner. But we'll give that a moment to start up here. Get that web editor going. There we go. And so I'm just going to go ahead and add a couple files. File new. We'll save this as README. Oops. This is file save as. This is acting kind of funny. Normally, what it would do is it would save it to here, but it's not giving us the folder area here. So open remote repository. This is unusual, to be honest. I think it's because I don't have any files in here, so we'll just back out for a moment. Okay. And I'll just manually add a file. There's a few other ways we can do it. We can just write README here. It's not a big deal. Say README.md. README. Hello world. Okay, we'll commit those changes. Yep. Not exactly how I wanted to do it, but it's totally fine. We'll go back over to here. I'll just add another file. Say hello world.py, and we'll just print that out. Print hello world. Okay, we'll go ahead and commit those changes. Good. And we'll click out of that here, and let's see. Well, actually, I still need that open. We'll have to go back over there because we need to go grab the URL. So that's in our Exam Pro. Exam Pro, Exam Pro. Where are you, Exam Pro? There we go. And from here, we'll click into this. And we'll go to code. We'll go to local, and we want that Git address. So I think we want HTTPS. Let's see what it wants. Yeah, it wants HTTPS. That's what I thought. So we'll go ahead and copy that. Remember, this is a private repo, so we'll see what happens when we try this. That has its folder name, sparse checkout mode, only to clone a specific subdirectory. We don't want to do that. Let's go ahead and hit create. And so now we need authentication. So simple setup in a few clicks. Let's try that out and see if it works. That'd be nice if it does. Okay, so now that it's successfully linked. Okay, so we'll clone it. And we have a little bit of problem. So the GitHub account does not have access. I know the GitHub organization should be here. So this might be because Exam Pro, I didn't do this in my personal, I did this in my organizational account, right? And so this is probably why it's not working. And so I'd have to go to additional settings and fix that. And we could follow that stuff through. I'd rather just keep it simple. So what I'm going to do is I'm going to transfer this over to my personal account, my Omen King account. And we'll go all the way down here. We'll transfer ownership. And I will say select a username. Type Omen period King. I believe that's what it is. Double check, make sure. Maybe it's just Omen King. That was Omen period King. Let's make sure that that's what it is. Omen King. Couldn't get Andrew Brown. I was early on GitHub, but I just couldn't get the name I wanted to. I'm not going to lose anything, so that's fine. We'll go ahead and paste this in here. I understand. I'll try to use GitHub Mobile. The last time I used it, it was giving me trouble. Maybe because I'm not logged in or something. But now I'm just on my phone here. You can't see me, but I'm off screen. I'm just, yeah, I got to log into GitHub. Just give me a moment on my phone. I have to log in. Because it took so long to log in, I'll have to retry this. But now I have GitHub open on my phone. It wants me to enter the code in. I'm going to type 50. We'll hit approve. And we are going to transfer that. That's now in my personal account. So we'll go ahead and just go over to Omen King now. I want to be in my personal, so we'll go over to here. That's not the one that we want, but that's fine. Clicking around till we find it here. There is the repo. We'll go get the HTTPS address. We might have to do that whole authentication thing again, which is totally fine. As long as it works, that's all that matters. We'll hit cancel. I'm going to go ahead and we'll try to create the Git folder again. And we'll hit create Git folder. And admin of the repository must go here and install the GitHub app. That's what we're missing, right? Because I did it in a different order. So you might not be having any of these problems because you just got it right the first time. But this is what it is for me. So we'll go ahead and select that exact folder, install. I'll go back over to here. We will, I just clicked it again to see if it takes effect. There we go. And so now we have our code here, which is really, really good. So the idea is that if we modify this code here, we'll say print goodbye moon. We should be able to sync it back. So we'll save that file. Okay, so let's see where we can sync it. We have version history over here. So how do we go ahead and sync this, right? We've made changes. Okay, just give me a second to find it. Oh, you know what? I believe here we just hit save now. Okay, so updated code. We'll save it. Okay, I think I would prefer if we were using a notebook to sync it another way. Sometimes with notebooks you can pull in a Git repo. So let's click here and take a look. This is my first notebook that we had earlier. And so what I'm looking for is a Git connection here. So environment, I know we saw it earlier, so I'm just curious. I mean, this one's not part of a repo. If I hit save now, what happens? Hello. Because this is not part of my, my Git repo. It's not in my Git folder. But it just committed it. So did it actually go over there even though it's not necessarily part of it? Just nice refresh here. So we'll go into this one. That says there, it said save now, but it's not committed. Go back over to this one. Save now. Hello. Okay, so we have versions, but that's not really helping us. Okay, so just give me a second to find it. One thing I'm really confused about here is like, this is where it used to be repos and you'd go create a repo, but now it's a folder, which is totally fine, but it's not listing any repos under here, which makes me think that the repo is not attached, but it's right here. We can see it there. So I guess it's just not under here anymore. Okay. And if we go here, create, import, etc. Main. Okay, so we can click on that and then push it this way. Hello, hello world. Commit and push. Okay, not the nicest interface, to be honest. But we can pull, we get history. So I think that's fine. What I'm curious about here, I could have swore in my first notebook, there's a way to connect Git, but I could just be thinking of how like other notebooks work, because often notebooks will have a tab here and you can connect to it directly. But it would make more sense for it to be in the repo and then sync it that way. So I'm just going to carefully check here, because I could have swore I saw a Git option here, but I'm not seeing here today, so I guess not. Okay, so I guess we would just want to put this repo in here. I wonder if we could drag this into this folder. Okay, and then if we go, whoops, can we sync up here? We'll click on Git. Add my first notebook. All right, that's fine. But yeah, I'm, again, not sure why in our workspaces it just doesn't go under repos anymore, but I guess they're just keeping it nice and loose for us, which is, I guess, fine. But yeah, there you go. There is Git folders, or also known as repos, or only to be known as Git folders going forward here, okay? When you're using notebooks, there's a thing called magic commands, which will change the way a cell will interpret its information. Generally, this could be for changing languages, but you can do other things with them. You see these in Jupyter notebooks, and they're also present in Databricks notebooks. And so I just wanted to highlight the ones that you should know that are going to be useful for you. And I'm not sure if it'll appear on an exam, but it's definitely things that you should know. So let's take a look. So you have file systems where you can do %fs to interact with the file system. You can do %run to run a notebook. You can use %sh to run shell commands. Then for SQL, we got that will change the cell to interpret it as SQL. Same thing for Python, same thing for Scala. So there you go. Hey, this is Andrew Brown. In this video, I want to take a look at the magic commands and see if we can get them all to execute. I don't think it should be too hard. But the one I'm kind of curious about is like notebook, running a notebook within a notebook, but maybe it'll be pretty easy to do. Let's go ahead into our workspace, and you can create a new notebook if you want. I already have one. I mean, this old one we'll get rid of. I don't want this one anymore. Well, actually, I don't know. I don't know what's in there, so actually I'll leave it alone for now. But in here, I have this notebook. If you want to make a new one, you absolutely can. So we obviously have cells, and right now everything's defaulted to Python. This one obviously works. We don't need to change it. But let's go ahead and add another cell. So it's not Shift-Enter. Yeah, let's hit code here. And so we'll drop down our code. Now we can toggle it this way, but let's go ahead and run it this way. So let's say we want an SQL command this way. So we're not, actually it looks like it changed automatically when we did that. So do Scala. Oh yeah, it automatically changes. Does that mean if I change these other ones, it'll just change it? Okay, so that's what it's doing. Interesting. All right, interesting. And then we have our Markdown. But let's take a look at first at Markdown, which is just comments. Everyone knows what Markdown is. Actually, we don't even have it on the list here, the Markdown one. But it's in here, and that's pretty common. So we'll just say like, hello world. And it wasn't done there. We will go and how do we edit this? Double click. There we go. Hello world, enter. This is Markdown. Okay, I think everybody here knows Markdown, or, you know, they know enough of it. So we'll put that up there. But I guess we don't really have to learn to hit those, but we can go ahead and select something. Let's go over to the SQL editor. I'm not sure if I have any serious data in here right now. I've been doing labs out of order, so there technically is data here. But maybe there's something that we can query that we already have. So I do have this workspace songs in here. I'm going to just go to the default here, and maybe the catalog, and just see if there's any like generic data that we can query, that we can all query, so we don't have to set up a bunch of stuff in this lab. So go into workspaces. We got default. No data in here. No data. Okay, what about information schema? Here we have data. So maybe schema tags. Do we have any data in here? Or is it just empty? So Just trying to find any data, any kind of data that we have here, tables. Sample data. Well, I guess we can find out. So what I'll do is I'm just going to make a new tab here, just so we can be the SQL editor and flip back and forth and just see if we can get any data, assuming there's any data there. I don't know if this, I would expect the schema information to have some default data. So that's kind of my expectation and this is workspace dot information schema. I'm going to switch this over to information schema dot schema tags. Let's see if we get anything back. So we'll just run this. Would you like to start it? Yes, of course. I don't need you to tell me that. So I'll just hit enter there. And let's see if we get any data back. If we don't, I'll create some data and we'll work from there. It's not that hard to make data, but okay. So I guess we'll have to make some data for this one. So I'm going to go over to our catalog. And from here, we're going to add we already have a catalog here. Workspace is fine. I think I made one earlier called Playground. So I suppose we can make another catalog. It's not a big deal. So we'll go ahead and create ourselves a catalog. This should be simple. Here we have standard foreign shared database. I want this to be stored, the data on Databricks. So to make my life easier, we're just going to call it standard. Here we have the use default storage. I mean, that's what I want to do, but it's in preview, so I'm not that familiar with it. This is optional if you want to select an external location. Metadata storage, you are not, default storage is enabled in your account. Okay, so let's checkbox that. And then here it says catalogs will use the default storage only accessible by this workspace. That's perfect. So if we don't have that, I guess we have to do an external one. The reason I'm confused is because sometimes they have this interface here where they're saying choose an external storage and it's optional. And that it would assume that you go to the default, but for whatever reason, they've changed it here. So go ahead and we'll select that and that should get us into storage. It's not that I don't know Databricks. I made a Databricks course before, not with certification, but we used it because you learn it with Azure, AWS, and other stuff. But again, they've changed things on me, so I'm learning again with you here. So we'll go ahead and configure the catalog. So I only need it for this workspace. So we'll go ahead and checkbox that one. Oh, okay, it's the default one, so that's totally fine. Permissions are fine. I have permissions to browse, which is fine. Go ahead and hit next. I don't need any tags. That's fine. We'll go ahead and hit save. And so now we have ourselves a simple table with default in it. So what we need to do is create ourselves a new table. So the catalog will contain the stuff, and then the schema will actually be the database. We'll go ahead here and we'll just say, we'll just call it to-dos. Okay, this will store to-dos data. Nothing super crazy here. But yeah, see how we have this storage external? So this is optional. So it should pick up the default storage here. And so now we have tables. And so I'm going to want to create a table. So we'll go ahead and do that there. So here we can drop in files. We should also be able to populate this table with data. Create a master table based on a file upload. It's not really how I'd like to do it. So go back here. I'm just trying to think here, different ways that we can create the tables, because we can create a table over here. Oh, we have a sample table down below, but I don't want sample data. So go over to the SQL editor. I guess we're doing more than I thought we were going to do, but that's totally okay. And we'll drop this down to simple. We're going to go to to-dos, and we want to create ourselves a new table. So we do have generate AI, so we'll go ahead and do that. I just don't want to look up the reference information right now. I'm just trying to make it easy. So create me a simple table for to-dos, for tasks. Just, name and timestamp with ID integer, I guess, or whatever it wants to do there. Let's go ahead and generate that and see if it can do that for us. I'm really good at SQL, so it's not like that hard, but we're not using Postgres. It's their own flavor. It's Apache Spark. So I'm just trying to get it to do that. Is that going to auto increment? The ID should auto increment. Okay, let's try that again. Okay, big Nick generate always is identity, so string task. And so that looks better to me. Let's go see if it'll accept that, assuming that it generated out this correctly. We will run this task. I don't think it was executed, so we'll go ahead and run all. And so that should create our table. Okay, so now we have a table. Let's go ahead and copy this here. I'm going to just take this out, and we'll just go here and say, this is my table. This is my table. Create me 20 sample records to insert. Okay, we'll generate that out. And kind of in an indirect way, we're able to learn the SQL. Like if you don't know how to write it, at least you can see it. I can write SQL by hand. It's not a big deal. Use task names that are real world for a tech company. Okay, because I don't really like those names. If we're going to make sample data, let's try to make it real. There we go. That's a lot better. Okay, so I don't need the, we already have the table created, so I'm going to just take that part out. And that looks fine to me. We'll go ahead and accept that. I think that should be fine. Insert into tasks. Yep, that's exactly how it works. We'll go ahead and hit run all. And so that should work. We'll give it a moment here to insert that data. I'll just pause so we're not waiting forever. And it finished basically instantly. So now that data should be there. Let's make sure that we can select that data. So, we'll go ahead and use our notebook with the magic command, because that's why we were doing this all to begin with. So we'll go to our workspace here. Nope, we'll go to home. Not the easiest to navigate, I apologize. And we'll go to my first notebook, and in here we now have SQL. So we should be able to select data. So we'll say select all from, and the scope is workspace. It should be simple. Maybe it's simple. Oh, simple dot to-dos dot tasks, and we do want all data. So we usually should put a limiter on that, especially since we're working with big data. Obviously, we're not really working with big data, but I mean, like, this is intended for big data. So we probably want to scope to say, like, limit 1,000. But so when we use the SQL editor, it was already doing that for us. It was setting a limit to it. But here we have our data. So SQL works pretty well. So that is pretty straightforward. I am not very good at Scala. So let's go ahead and see if we can generate this out. So, can we generate out a Scala example? Okay, generate one. Okay, so what do we have? I mean, that looks fine to me, but let's read it for a second here. So we're creating a Spark session. We have a data frame. We create the data frame. We want to show the data and display it. So that seems fine to me. Let's go ahead and accept it. I don't see any issues with that code. Invalid syntax line 4. What's the problem? Okay, so again, I don't know Scala syntax that well. Scala is like functional programming. I believe it's functional programming, but it's a layer on top of SQL. Very popular in the data space. We'll go ahead here and copy this, and let's just go ask Claude to help us out. So we'll go here and just say line 4 is invalid when defining the object. We are simply trying to run this in Databricks notebook. Okay, so again, I'd have to do a course on Scala. You don't need the object. Okay, so it's just going to take it out of there. Fair enough. So what we'll do is we'll go ahead and copy this. We probably can just cut it out of there. I don't think it was using any specific reference stuff here, but I guess we just don't need a main function. Okay, it looks like it changed quite a bit. I don't like the comments. Are those comments even valid? But we'll try to run and see what happens. Now it doesn't like line 27. I don't like all these comments, so let's just take all these comments so we can see what we're doing. Okay. Let's try to run this again. Oof. Okay, let's go back over to here. Let's take a look at the code block we gave it initially. Invalid syntax. So I'm not exactly sure what's wrong, but we'll go ahead and just, again, we're not trying to learn Scala here. We just want to make sure that we can get it running, right? So we'll drop it down here, Spark, line 3. So there's obviously something I don't know about the Scala language. I don't know how to define variables in Scala, so I couldn't tell you. Oh, let's go take a look here. Yep. Okay, so let's drop that down. And that actually kind of makes sense because when we saw the comments, they weren't commenting correctly. But let's go ahead and try that again. It's not supported by service compute. Of course it's not. So what I'll do, we'll go over to our Azure one. That's fine. This is why we got multiple accounts, folks. So say Databricks here, and we'll go log in. And this time we will choose Azure. I think I deleted the compute, so in order for us to use it, we will have to spin up some kind of compute. If you're not comfortable with Azure compute because it's expensive, you don't want to run it, I totally understand. You just watch me do this. But we just want to try to accomplish these commands here. So I'm going to go here and I'm going to have it unrestricted. It's obviously not the most secure, but it's totally fine. We'll choose this cluster here, 16.4 LTS with Scala. So it's telling us what specific version we have with it. This is cheap enough, so it's fine. I want this to terminate after, I don't know, 30 minutes. And we'll go ahead and create that. So we'll need to wait for that compute to become available. I'm not sure why I'm getting this message, which is fine, but it seems like there was some kind of reduction. What that is, I don't know, but it's obviously on the Azure side. So we'll wait for this compute to be ready, and then we will try this out. While we're waiting, we might as well just go ahead and create a notebook. We actually already have a notebook here. If you don't have one, just make one real quickly. So we have the Faker example. Yeah, so when we set up Azure, right, I think when we set up Azure, we configured, no, it was a compute, when we ran compute. Yeah, so we already did that earlier where we configured under a compute the imports, right? So I'm going to get rid of this cell because I'm not going to bring in those options there. So, or we'll just change it. So I'll just change it to Scala. And I'm going to copy this code here. We'll go back over to here. And so we're just really waiting for that compute to become ready wherever that is. I'm not even sure where it is. I've got to close out some of these tabs so we can see what we're doing. So I'll just open another tab here. And we'll go to our compute. And we'll wait for it to become available, okay? All right, so our compute is ready and running. Let's make sure we start using it before it spins down, as I can sometimes forget that is going there. So we'll go to my notebook, and here it is. Notice it is connecting to our only compute that we have. So I'm going to give that a moment there to connect. Even if it doesn't, I'm just going to hit play just so that we make sure. Oh, nope, it's not attached. Okay. I'm trying to attach you. Let's go attach and run. There we go. So yeah, it was spinning forever, not really connecting to anything. I'm not sure as to why, but now it's going to execute against our compute. So we will wait for this to complete, hopefully, and see what happens. All right, so here we've ran our Scala code, which is creating a data frame and displaying some information. Down below, we get our results. No issues there, so we can use Scala. We know we can run Python. We've done SQL. There's a couple more that we might want to try out here, like the file system and run, or like file system, run, and shell. So let's go ahead and see if we can execute those. So let's go and make a new cell. So for shell, I'll just do ls, which is to list things. Let's see if that works. So list out the contents. We can also do pwd, so print working directory. These are bash commands, so yeah, you can see where the files are stored. So that one's pretty straightforward. We'll go ahead and add another one. We have file system. I'm not really sure what we do with the FS. Let's go find out. Just give me 1 second, okay? Actually, no. Why don't we just ask it to generate? Because apparently that's an option. So where is our where's our generate option? They had it everywhere else. Now they don't see it. Okay, so let's delete that and try this again. Code. No, we don't get any AI here. Okay, that's fine. So I'll go over here. I want to use FS. Can you give me an example for Databricks Notebook? Okay, let's see if we can get a simple example. Oh, okay, so file system stuff. All right, pretty straightforward. So go down below here to our next cell. Oh, nice, and we get a table. I want to look up the reference for this. Just give me a second, okay? Oh, okay, so the FS is actually shortcut to the DB utils file system. So in here, I don't even have that there. I'm just gonna update that slide so folks know. Okay, so we'll go here and just say shortcut to the DB utils FS. So I guess anything we can do with DB utils is going to be a shortcut. So let's go take a look up DB utils commands. Okay. It's not the clearest. Oh, I guess it's a shortcut specifically for FS. Okay, so any commands here we'll be able to use. So let's see, returns, the utmost, etc. ls for contents. We can copy a file, move a file, remove a file. We can mount, unmount stuff. We can make a directory. Let's try making a directory for fun. Okay. So here we have that. Okay, so what I'm going to do is I'm going to go back over to here, and I'm going to add another code block. We'll say #fs make directories. It looked like it was like a plural for some reason. Go back over to that for a second. Yeah, it is plural. And then we need to provide it the address. So this is ls. It shows us our current volumes. We'll just try to create one in place. So my new folder. Let's just see if that works. So I'm not exactly sure what the full directory is. We can do print working directory. So unable to do root. So it's actually trying to create it at the root. Okay. And so I suppose we could do volumes. But I still don't think that's correct either. No, I don't think it is. So I'm going to go ahead here and add a new code block. And I'm going to do this with shell and just do pwd. Okay, so what I'm trying to do is figure out, okay, what is that directory that we can put it in? Because over here we have these, but this is not very useful for us, right? I mean, what if we just take out the /? Because then it would just print the current location up here, right? Reload the page. I'm not sure why we're having networking issues. Maybe it's my internet. Just give me a second, okay? Yeah, it looks like my internet's out. I'll be back in just a moment and fiddle with my internet, okay? All right, folks, my internet is back. I did the old plug in, plug out. And so we'll go ahead here. Well, we changed this one up here to just, well, let's see if we take that / out there and hit run. Okay, and so what I'm hoping is we just get the default volumes. I was thinking that it would show us something like the working directory, but we'll go ahead and do pwd. And so this is our actual folder. Am I in the right place? Yeah, this is not even the right, we're not even the right place. We need to be over here. Yeah, so this is our pwd, right? And so I'm gonna go ahead and copy that, and we'll go back to fs. We'll say mkdirs. We'll do parentheses. I think we're supposed to do parentheses here, and then we'll just say my new folder. And so let's see if that works. Okay, again, I'm just guessing. Boolean does not take a parameter. Okay, so let's go back over to the documentation because clearly I'm not using this correctly. Volumes main default my volume my data. I mean, another thing we could do is that we could just copy this. I would assume that it would just work as the default here. Let's go back over to here. Let's try this. Run. Now, maybe it doesn't like the parentheses. Let's go back here. Because this is like a shorthand thing, right? So it might not want the parentheses there. Like notice that it does this underneath and then executes it, which you think that wouldn't be a problem. Okay, there we go. So now it made it. So I guess it doesn't want the parentheses there, which is fine. Let's go take a look at our workspace and see if that folder exists. I don't see it. I mean, it clearly made it. Okay, so we'll go back over to our notebook here, and let's do an ls here. Okay, let's try this again here. pwd workspace users Andrew Brown. So I mean, it said that it created it, but we don't see it. We have workspace users Andrew Brown. If we go over to here, to workspaces, users, Andrew Brown, we don't have the folder there. Okay. So I'm just trying to figure out, go back to home. There's home. I wonder if we can get home. Let's go back here for a second. So I'm just kind of looking at that file structure as we work with it. And I'm trying to take some educated guesses here. But if we go back here and let's say ls, we have some of this. Try this again here. What do we get? Is there actually a home directory? No, but let's do like ls / like that. Now what do we get? Okay. And then if we go into home, it's not really helping. pwd. Okay, ls. Yeah, you'd think this would be right, but it doesn't work. So I'm not sure what. We could play with this all day and try to figure it out. The last thing we want to do is run a notebook. So let's see if we can get that syntax to work. So go ahead and write run. And I would think we need another notebook. So I'll go ahead here and we'll just make a new one. Call this my other notebook. Print my other notebook. I'm going to go ahead and save that. We're going to go over to here. We'll go all the way down here. I'm going to just try to give it the name my other notebook. There it is. It auto-completed. It has to be relative path. Okay, we'll try that. Let's do ls. It looks like it doubled up the name a few times here, so let's just fix that. There we go. Not having too much luck with these. My other notebook, okay, that's fine. What if we take off this part of it? There we go. And it ran it. Okay, great. So we'll go ahead and make sure, whoops, make sure we can do that. But yeah, obviously, like the file system commands are working, but just in some cases it's not. Oh, I didn't mean to run this one. I don't know why I did that. I actually wanted to run it from here, which is fine. Okay, and so it works perfectly fine. I'm not sure why that one takes forever. And so I'm done here. I'm going to stop this compute, terminate it, which keeps the configuration around, but I don't have to continually configure and start it up. But I would say that covers our magic commands, and I'll see you in the next one. Okay, ciao. Hey, this is Andrew Brown, and we are taking a look at Git. So Git is a distributed version control system, a DVCS. That's going to be hard to remember. And it's created by Linus Torvald. If you've ever seen that name before, you might know that Linus is the creator of the Linux kernel, but he is also the creator of Git. And Git right now resides with the Linux Foundation, which I believe is a nonprofit set up by Linus as well, or has some part to do with it, where a lot of open source projects reside. But I don't really want to focus on that. I want to focus on the practicalities of Git. So the idea with Git is that each change of your code, a Git commit, can be captured and tracked through the history of your project, a Git tree. So I'm going to get my pen tool out here for just a second. And so I just want to make this very clear. So we have over here a file, and a Git commit a commit can be made up of multiple files with multiple changes in them, and then they're represented over with a message. Okay, so here this is a single Git commit, and it can have multiple files and changes in that single one, and then that's your tree. Okay, so hopefully that is clear. If it's not, don't worry, we'll get hands-on skills, and we'll definitely be able to remember them later. I want to take a look at a bunch of common Git terms, and it doesn't matter if you remember these now, but you will know what they are, hopefully by the end of this course. And so there is this nice graphic here that is provided by Wikipedia that gives an idea of how all of these terms work together. But let's go quickly through them and see what we can make sense of. So the first term is a repository. This represents the logical container holding the code base. In fact, you could interchange the word code base and repository and mostly mean the same thing. We have a commit. This represents a change of data in the local repository. And so that's pretty clear. Then we have the tree. This represents the entire history of a repo. So when you see tree, just think of that graph. We have remote. This is a version of your project hosted elsewhere, used for exchanging commits. Some people might be a bit picky about this because they might say remote is actually a remote reference to a repository. So it's pointing. It's a pointer. But I'm just going to make it think that it's a remote repo. It's just somewhere else. And there are branches. So these are divergent paths of development, allowing isolated changes. You're absolutely going to know what branches are. You're absolutely going to have to work with them quite a bit. There is a branch known as main. It was formerly known as master. The word was changed because it was not a popular term anymore. And so now main is the new name. And this is usually the default branch or the base branch, if that makes sense there too. So we have clone. This creates a complete local copy of a repository, including its history. So this will create like a little .git folder. So it's not just the contents of the files, but some configuration around the Git repo. We have checkout. So this switches between different branches or commits in your repo. We have pull. So this downloads changes from a remote repository and merges them into your branch. We have push. This uploads your local repository changes to a remote repository. We have fetch. This downloads data from a remote repo without integrating it into your work. We have reset, so undoes local changes without options to unstage revert commits. We have merge. This combines multiple commit histories into one. We have staging files. This prepares and organizes changes for commits. It's not a command, but it's just where you would work with your files. In the example here, I'm just going to get my pen tool out again. It's kind of over here. It has to relate with this up here as well. And so within staging files, we're going to have commits, which we already talked about prior. And then there's that add command, so adding things that will get committed. So hopefully that makes sense, and we'll see you in the next one, okay? All right, let's compare Databricks repos with native notebook versioning. And I definitely remember getting exam question, at least one, about this comparison. So this is something you're going to want to pay attention to. So on the left-hand side, we have interface, accessibility, repo management, basic Git operations, collaboration, advanced Git features, integration with tools. So for Databricks repos, it's a web-based interface that's accessed via the browser, whereas a native notebook is going to be a standalone desktop application. For accessibility, it's accessible anywhere with the internet. With a native notebook, it's accessible only on an installed computer. For Databricks repos, it directly manages repositories online, where a native one is going to manage local copies of repos. Databricks repos perform operations like fork, star, and watch, whereas a native notebook versioning is simplified interface for commit, pull, and push. For Databricks repos, we have direct collaboration tools like issues and PRs. For native notebook versioning, we have focus on local repo management. For Databricks repos, we have support advanced features via commands. And for native notebooks, we have simplified experience for basic features. For Databricks repos, it integrates with various online CI/CD tools. And for native notebook versioning, it's limited to Git local tools. So if you understand the things that you can do with Git, with Databricks repos, you're going to be in good shape. So you're mostly just focused on, I'm going to get my pen tool out, these things here, right? So if you remember these facts, then you don't really have to remember these, but there you go. Hey folks, this is Andrew Brown. In this video, I just want to make it really clear about what we're talking about native notebook versioning versus Databricks repos, or now known as GitHub folders or Git folders, sorry. And the best way to explain it is by launching up a notebook. Now they say like native notebook versioning, but they're usually talking specifically about Jupyter notebooks. So let's make sure that we understand what we're talking about by launching up a notebook. You're just watching this to see where it is. It doesn't really matter what provider we use. It's all going to look the same. And I just went into Azure because it's probably one of the easiest places where I can create a notebook. So what I'm going to do is just launch up my Azure Studio workspace and see if I can create a notebook just to show you what I'm talking about. Assuming that these notebooks even look the same. If they don't, I'll have to use another provider. But if I go into here, what I'm looking for is some Git versioning. So normally with these, I should be able to drop this down and open this up in Jupyter notebooks. And I'm not seeing it here. Well, we do see the serverless Spark compute, which is from, I believe that's coming from Databricks, right? But what I'm looking for is the ability to open this up in Jupyter notebooks. And we should be able to do it here. Okay, I guess we can't. So this example is a bus. I'm going to make my way over to AWS and show you in SageMaker, okay? So I'm going to log into my AWS account, and I'll show you what I mean when I'm talking about this native stuff, okay? All right, so what I'm going to do is make my way over to SageMaker, as that is a place where we can launch our traditional notebooks. On the left-hand side, they used to have a place where we could, oh, they've changed it again. SageMaker AI, formerly named Amazon SageMaker, is still the place to build. Go to SageMaker AI. Of course, they've changed it for no reason. For no reason. It hasn't even been that long. Same interface, looks the same, but they just keep changing names on us for no reason. So go over to your notebooks, and this is just an example of how we can do this. I thought they were going to get rid of it, notebooks through here, but maybe they're still around. But let's go ahead and just say my new notebook. Because I really just want to launch this to show you. We have a compute type attached to it. Everything else is fine. Notice we have Git repositories. I'm going to leave that alone, blank for just a moment. Okay, and we're going to create that notebook. And we'll give it a moment here to get ready, okay? All right, our notebook instance is ready. Let's go ahead and open it in Jupyter Lab. Jupyter Lab is the newer version. I don't even remember what Jupyter notebooks do anymore, but everyone launches things in Jupyter Lab. So again, coming back over to here, you'll notice we have a Git symbol, and the idea is that we can open a repo or clone a repo into here, so I can go ahead and grab one. It might not be easy to grab the other one because it requires authentication. We can try for fun, but if it becomes too hard, we can just give up as well. So we don't fully need to work. I have public repos that we can pull that are going to be less of an issue. But we'll go over to here. Okay, and we will grab, I believe, the HTTPS here like this. I can't imagine this will work, but we will try. Because it needs authentication, right? So we'll say, we don't need submodules. We'll clone it. Because it would need authentication, so I'm not sure. Oh, there we go. So here I can put my username and my personal access token to temporarily download it. Let's go ahead and do that real quick. And I'm going to go over to here. We'll go to settings, personal access tokens, developer settings, and personal access tokens. We'll go to classic. Classic's been around for quite a long time. Okay, so I'm just going to generate out a new one here. Nope, I want to generate out classic token. You'd think because classic is classic, you wouldn't want to use it, but it keeps working. Keeps working fine here. So just going to authenticate here off screen with GitHub. Okay, so just say notebook example Azure. Okay, and I don't know what access I need, so I'm just going to give it all access here, just so my life is a lot easier. This is way too permissive. We're going to delete it in a moment. You're never going to get this key, so I'm not really worried about it. but this way does work. Again, I don't think we need all of it, but that's fine. We'll go ahead and generate that token. There is that token. I'm going to copy it, go back over to here. We're going to paste that in. We're going to say, okay. I don't even think you were able to even see the token. And so now we have Databricks here cloned, right? And so we can work with it pretty much similar. So let's go back to our list, see what the difference is. So web-based standalone desktop, this native interface, because we can run Jupyter locally. I just don't want to do that. It's a lot of work, but it would be the exact same thing. And so it'd be standalone as well. This is accessible anywhere. Technically, if we are using notebooks in the cloud, they're everywhere, but if they're local, then there wouldn't be. That makes sense. Directly manage repositories online. Same thing with this. Manage local copies of repos. Okay. Forkstar watch. So I didn't see those operations as we were using them. I saw the basic ones over there. Yeah, so again, this is what Databricks reports that this functionality has. I would say that the functionality was a lot less robust than any systems, and it kind of feels like the same thing. So I would just say the stack up doesn't really feel like the way it is, but for the exam itself, they're going to want to push their thing and say, oh, it's great and does all these things. And so I don't feel that it really does those things, but that's totally fine. Okay. So just understand that that's kind of the thoughts that are coming into my mind there about that. Let's go ahead and we'll terminate that. But now you have an idea. So again, I really thought we were going to see a lot more differences there, but we're not really. But anyway, I'm going to stop that notebook, and then when it's done, I'm going to delete it. I'll do that off screen here. It's really boring to watch it, so I'm sure you're not interested in seeing all that. But yeah, there you go. So what is Delta Lake? So Delta Lake brings ACID transactions, scheme control, and performance improvements to data lakes. So ACID transactions ensure reliability and consistency. Schema enforcement blocks bad data from being written. Schema evolution allows structure changes without breaking pipelines. Time travel lets you query old versions of data. Supports key commands like merge, delete, update, and optimization for Z-order, optimize, and vacuum. And so these are all the things that we can do with Delta Lake. I believe earlier in the course, we explained what is Delta Lake, but we want to focus on these specific features so you understand why they are so advantageous. If you notice down below, you'll see that bronze, silver, gold stuff, which is that medallion architecture. So just pay attention to that integration there, or the fact that it's following that pattern, because this is data lake stuff. Yeah, let's jump into these features. Hey, this is Andrew Brown. In this video, what I want to do is explore Delta Lake. So Delta Lake is already integrated into Databricks, but if we can get it running on our local machine, it just gives us a better knowledge of what it is at a more foundational level. And so I think it's worth the effort. If you don't want to do this, you can absolutely skip this, but I think it is very useful to do it. So I'm on the Delta Lake website, and we're going to have to get PySpark installed. And I already have Miniconda installed. If you don't know how to do Miniconda, then sorry. In my GenAI Essentials, I do show how to install it. Again, if you can't do this part, you can just watch it. But generally, you need Miniconda installed first. And we want to create ourselves a new environment. I forget how to make environments because I haven't been doing this lately. So we're going to cheat and ask Claude. So how do I create a new Miniconda environment with, what's the thing called? Jupyter Notebooks. I do have this in code somewhere, so we'll let that generate out. And as it's going, I'll just show you that I do have it. It was in my GenAI Essentials course. Probably like GenAI. We'll go over here and we'll find it this way. GenAI Essentials. And so in here, I should have something for Jupyter or Conda. It's been a while, so I don't remember. I don't remember where it is, but it'd be like setup or something here. So again, we'll just carefully look here. Crew cursor, HTML, GitHub, Gradio, Hugging Face, local dev. It'd be under local dev here, and then we have Jupyter server. And so these are the commands I'm looking for. yeah, it's doing basically the same thing. You got to be careful with what version you use because you can run into a lot of problems with versions. But I'm going to go ahead and set this up. I actually show you how to set up Conda here as well. So if you do want to do it, the instructions are here. Okay. But again, just watch and let's just see what we can learn while working through this together. So I'm going to go ahead and use 3.10. Yes, of course, 3.11, 3.12 are out, but that's not important. What's important is that whatever you use actually works. And I guess this is called serve. I wasn't paying attention to what I was naming it, but you can change the name. So this is going to be SCRV for server, maybe. That's going to install a bunch of default stuff for us. So we will wait for that to finish installing. I'm just going to make this a little bit larger so it's easier to see. So now we have that. We need to activate it. So we'll go ahead and activate this environment. Okay, and we'll continue on. So I'm going to want Jupyter Lab. We don't have to use Jupyter Lab, but you know, I like it. And this is what I was saying when we were doing the other video when I was showing you like the native notebooks. And I was like, oh, it's too much work to install Jupyter Lab, but now I'm doing it. So this shows you actually how to start it underneath. Here you can attach Git and then whatever that is. I forget what this is. Oh, that's to change the theme. We'll go ahead and hit yes. Here, let that all install. Okay, I'll be back here in a moment when it's done installing, okay? And installed instantly, so there was no waiting. But anyway, I might just want to install the theme for fun. So makes things a little bit nicer. It's like a cappuccino theme. If it doesn't work, I don't care. But and so now we want to start up this here. We can go ahead and do that. Should start up a server. And so I'll open a browser. And so now I have a Jupyter notebook. I don't want a password. If no password is configured, you need to open the server with its login and token or URL and paste it. I'm fine with doing that. So when you generate this out, it will have a token here, right here. Okay. And so I'm just going to grab this address here, or I'll just control right click into it. And so it just automatically logs me in with the token. And so now I'm in here and we don't have Delta Lake installed. So here it's saying like find the compatible Spark version. So we need to figure out what version that is. So run PySpark with Delta Lake packages. I don't know what we need for PySpark. So we'll go over to here and just, actually maybe we can find out if it's already installed. So if we're here and this is started, I'm going to go over here and hopefully it, it doesn't do this. Let's conda activate PySpark, or sorry, serve. And so in here, I want to see what gems I have, or not gems, Python libraries. So if we go pip list, and I can go grep PySpark, maybe it's already installed. It's not. I just want to make sure anything's installed. We'll go pip list. So there are stuff installed. It might matter what version we install. So let's go over to PySpark website. Sometimes this matters, and they're like, oh, if you're using this, you got to use that. So we'll go to getting started here. Installation from source. I don't want to install from source, but I need to know what version to use. So we have pip install PySpark. If you want to install extra dependencies for specific components, you install them as below. So yeah, let's go give that a try. So not exactly how I want to do it, but it's fine. Normally when you install stuff, you want to do conda forge. So like, was it conda forge? What was it? I already forgot what the command was. We can install with pip. You're not really supposed to though. And I hit some kind of hotkey because now I can't get to my Visual Studio Code. It's full screen on another monitor. Just give me a moment to get back access. I had hit F11 there. I don't know what I did there. Sorry, folks. So I'm just going to resize this so it's a little bit easier for me to see. But normally you want to get the libraries from CondaForge, but it's whatever. So we'll just do pip install PySpark, and we'll just roll the dice here. Okay, so it's a grab version 4. Because again, the Python version could have issues with it. I think PySpark SQL is something we absolutely want. So this is installing. It's pretty darn large. It's like almost half a gig. But yeah, when that's done, we'll go ahead and install SQL. I'd probably install all of these, but we'll give it a moment, okay? And that was actually a lot faster than I thought. I'm going to make sure I also get the SQL in here. So we'll go ahead and install that. We'll give that a moment to install. I would think it'd be faster than installing all of PySpark. And it's going. Okay, so that's now installed. Maybe I don't care about Pandas on PySpark, but I think Spark Connect is something that we'll want to have. Let's go ahead and get Spark Connect. Okay, Spark Connect is now installed. We do have other options. We're not going to be using Hadoop. Okay. Oh, so we could have, here it's just suggesting we could have done it this way this entire time. And so that's probably what we should have done, but it probably will still work and be not a non-issue. Let's go back over to the Delta Lake instructions. Okay, so we installed PySpark, and then here, run PySpark with Delta Lake package additional configuration. So I'm going to grab this, and that's going to configure PySpark. Or sorry, Delta Lake. So I assume it's going to do. And we have a bit of an issue. Let's take a look here. So compiled by the recent version, this version of Java runtime recognizes only classes up to 52. Okay, so I need to update my Java version. This is totally not your problem. Again, just watching to see what the experience is like. So just say Ubuntu, how to update Java version. I don't even know what Java variant I have because you can install it multiple ways. I guess what we can do is say Java version like this. I'm just guessing here. Oh, just one hyphen maybe? So we're using OpenJDK, and so that's what we need to upgrade. So update, upgrade OpenJDK. And it's saying I'm on version 1.8.0. That doesn't really help tell me much. How do I update it? So here, like, see, it says OpenJDK version whatever, but I'm getting like 1.8 point whatever. So we're gonna have to cheat here. I really don't like using LLMs, but I think in this case it's okay. Because I'm not getting anywhere with this. So if we can just go ask Claude, this problem here. Because all we're trying to do is have it search the internet on our behalf. Oops. And then we'll decide what we think here. Because I don't remember how I installed this. So it says you're running 1.8.0, which supports class files up to this. So the version mapping is Java 8 to Java 17. Wow, I have a really old version. Okay, so we want to do that, set this as the default. So that's what we're going to try. Hopefully this just works. I really don't like installing things via just Claude instructions, but what other choice do I have? So we'll copy this and hit enter. And we'll go ahead and see what happens here. Say -y for everything. Okay, and we'll give that a moment. All right, so that didn't take too long. Let's go ahead and see if we can set that as the update. I'm not sure why we have both of those. We'll grab both of them. Maybe one's for C interfacing. I'm not sure. So go ahead and hit enter. Oh, so we have to set what version we want it to be. 0, I guess. I guess it's on auto mode, so it's already selecting it, eh? So we do this. I make it sound like I know more about Java than I do. But anyway, so now we're on 17, so that's gonna be less of an issue. So now we can go back here and try to install what we had there before, which was this. Okay, and so maybe this will work, and we'll give it a moment to try to install. Actually, it's working, and it looks like it's running. I didn't realize that was what we needed to run it. So let's go take a look at that command and take a look and see what we have. So if we go back over to here, run PySpark with Delta Lake package, additional configurations. Oh, okay, so not like PySpark's installed, and then these are the packages. Oh, so that's literally now we're running it. So we're running PySpark with Delta Lake. So we have Spark Scala shell, so we wanted to start it that way. I don't have Scala installed, so I'm not sure how that would work. Set this project for a project, you can also install Delta Lake with pip install Delta Spark. Then configure Spark session. I mean, that sounds like a lot better, but wouldn't you have to run it in the background? So we're running PySpark. Okay. And so now we might want to work with it here. So, but I guess the question is like, what language is it using here when we're directly interfacing with PySpark? Is it SQL? What is it? Let me go find out what that is. Also, one thing I noticed is that it says there's like a web UI here. So I'm kind of curious if we open this up, what we get, just before we figure out anything else. This might be just like the PySpark UI settings that we, somewhere in the course we would have seen it where we, there's like a tab under the compute and it just shows you basically nothing. I'm not sure if this is bound to 0000, so I'm not sure if this will ever complete. And if there was a way to change it, I'm not even sure how. So let's make sure it's doing HTTP because it probably doesn't have HTTPS, but that doesn't seem to be completing. So it doesn't mean that there isn't an interface, but there might be some additional option we have to do because it's not mapping maybe to the correct location. I'm not sure. But anyway, let's try to see what we can do with the Spark session and then work towards Delta Lake. 1 second. I don't know. I think it's probably Python. I'm just taking a guess here, but oh, you know what? It is Python. So it says using Python version. So that's what it's doing, 3.10. And notice here it says that it's the Spark sessions is available as Spark. So normally when you're using this, you'd have to set up a Spark session, right? But it's suggesting that the Spark object already exists. And so if the Spark object already exists, we should already be able to do some things. I'm going to go back over to Delta Lake. And so here, we might already have a table. Okay. So maybe we'll just, I don't expect this to do anything, but let's just write Spark here. Okay, so we get the object back. And here's selecting a range, but wouldn't we need data to do that? But anyway, we'll try it for fun. We'll just say data equals spark.range 0.5. I feel like it's going to complain. No, it didn't. Let's type in data. Okay, so we have a data frame, right, format, delta. Okay, and then we'll say save, temp, delta table. Let's see what it's complaining about. Just a moment, okay? All right, so I couldn't find anything out on the internet, but Claude's suggesting that maybe we don't have it configured correctly. I don't think SQL would matter because we're using Python. We do have it installed, but we can try and see what happens here. It's just been fun if we could create a delta table here, but if we can't, it's totally fine. So here we will use get to get configuration information. And so, I mean, it looks like, yep, we're getting the extension back. We did install it. Not that we were asking for that earlier. And we have the Delta catalog, so that's there. Exit PySpark and restart with compatible Delta version for Spark 3 version 0. Here it's suggesting for us to use a different one. Try using the Delta Spark package instead. Check Scala version. So I would just say like we are using Python 3.10. It's talking about like Scala and SQL. Okay, but we got them from the docs. Install the Delta Spark via pip. So Delta Spark, as far as I'm aware of, that's the library we need to create a session, right? So, I mean, okay, but why Delta Spark if we have direct access to the session? This is what makes no sense to me. Might be too old for your Spark version. Oh, I see. Okay, well, hold on. Let's just exit out of this for a second. We'll just do your usual exit. And so now we'll do pip list, and then we'll see what version we have, PySpark. Oh, we need grep in front of that for that to work. So we actually have PySpark version 4.0.1. Okay, and so if we go back over to our instructions here, because they didn't tell us what version, right? And here they're using Delta Core 2.1, which is really old. And so up here, we're seeing Delta Core 2.12. Okay, so maybe what we need to do is find what the latest package is for Delta Core. Delta Core GitHub, maybe we can find it that way. Actually, I don't want to lose that page, so I'm just going to open this one here, Delta Core GitHub. And here we can drop it down and see what tags we have. So we have 400. Wow, that makes our life super easy. So let's go ahead and hit up until we get this. And I mean, that doesn't really help too much. I thought maybe we'd just do 4.0.0, but you notice we have 2.12 and then 2.1.12. So I don't know why there's two numbers. Let's go down below and see if they have any information. Let's go to the online docs. No, that doesn't really help too much. Yeah, so I'm not sure what we would put here. IO Delta, Delta Core 2.12. Maybe they have release packages. Sometimes they'll have under deployments or release packages, the numbers. And that will help us find out the exact version. This came out when? A few months ago. Okay, but how do I use it? How do I specify it? So we're going to just try to cheat here and just specify it. So I don't know why we have two versions here, but we'll just say 4.0.0, and we'll take that out. That might not work, but we'll try it. I mean, it has entered something. And I'm just carefully looking at this here because we have warnings. Miniconda, IV, I don't know if that's a problem, provide coordinates. I don't know if it actually worked. Let's type Spark here. No. So we need to find out what that exact version is. Give me a moment, okay? All right, so I went on Netlify here and they actually have the information we want. So notice it specifies, it still says 2.13, but it says 4.0.0. So if we go ahead and hit up, back to our original one here, this one is not 2.12, this one is 2.13. So we'll just use that and see if that works. Okay, the thing about DevOps is we don't know why things are the way they are, but we just got to get it working, right? And we'll see if that starts up. That still doesn't work for us. Unresolved dependencies. So it says it can't find it. Module not found. Okay, so how do we get it? Let's go back over to here for a second because maybe somewhere here they explain it. Oh, we're actually on, I thought we were on Netlify. Did I not click through for Netlify? I did. It says Netlify here, and then it's actually the dot. Maybe they host it on Netlify and they just never changed the name. That's so bizarre. So here, it's a Spark SQL query, which is fine. Install the Pi that's compatible with the data lake version by running the following. Yeah, it didn't tell me. So let's go over to here and take a look. So 4 is compatible with 4. Okay, so we have Apache Spark 4 with Delta version 4. So we can probably just grab this command here, because maybe there's something else that's changed that we're not aware of. So we'll go ahead and do that. But it was saying like something was missing. But we'll try it, right? Oh, there we go. Okay, so yeah, so there's something different in there. Let's open up the browser now that it's available. Okay, cool. Yeah, this is something that we would see accessible in Databricks. So if we go back to Databricks here, if we were on the Azure side of it and we go to our compute, and I'm not running this right now, but if we were, we have the Spark UI, and so that should show the exact same thing here. I'm not going to start this compute right now because it's a lot of work. Oh, it is starting up. Okay, but that's going to be the same thing, right? I don't have to start it, so that's never gonna show up. Okay, but that's the exact same thing that we're looking here. So we got stages, storage, environment, etc. So we got some information. Let's make our way back over to Visual Studio Code. Okay, so now we have that set up, which is great. And so now that we have it, we can go back to this tab, the Getting Started, and we can try to do what we were doing here before. So let's see if we still have data. I don't think we do. Yeah, there's no data. And so we'll just follow through some of these steps and see what we get. So now there is the from Delta import. I guess we could do that there. I'm not sure if we need it. I don't think we need it. So I'll just ignore it for now. So we'll say data spark.range 0, 5. Okay, so we'll do data write.format. If you're wondering why, like, Andrew, why aren't you explaining this? Because I don't know what we're doing right now. Like, I have a general idea, but I'm not like the deepest person with knowledge on this. So we're just going to follow through and work through it together. And so now it's writing data to that temporary table. Okay, so it wrote to it. I am in WSL, which has a limited amount of space. I'm not sure how much space this would take, but I can't imagine much. So we just created a table. And I guess we created a range between 0 and 5 of a data frame, which is not a lot of data. So here, I guess we can read that data. Now, we're not using Spark Connect, so if we do df show, we're not going to see anything. So we'll do df spark, or we'll say df equals spark read format, delta load, /temp, /delta table. Okay, so if we do df show, we shouldn't see anything. Oh, we do get some data, okay. So it's not that bad, but I think the visual would obviously be better somewhere else. And so we created a range between 0 and 5. And so we have our data. So that's pretty simple so far. Overwrite the data, range 5 to 10. I think we understand what that is. We're setting it to overwrite mode. It's going to overwrite it. Conditional update without overwrite. Okay. So nothing super exciting here. Okay, so I just wanted to show you, if you want to do this locally and set it up and work at a lower level, you can do it. We're going to be able to access Delta Lake via our notebook within Databricks. But yeah, hopefully that gives you kind of an idea, like if you wanted to set up yourself and work through it this way, you can do it. But we'll call this quits here. We'll go ahead and exit. Maybe this will come in return later on. Maybe we won't do this, but I think that's good enough. I'll see you in the next one, okay? Ciao. So let's talk about ACID transactions. So Delta Lake relies on ACID transactions to maintain data integrity, even during concurrent operations or failures. ACID transactions is not specific to Delta Lakes. It is just a concept that is with databases. So understand you can apply this to other ones if they have or they're following ACID transactions. But let's make sure we know what they are. So what does ACID stand for? We have atomicity. Atomicity, I can't say that word. All operations succeed or none do. We have consistency, so data remains valid after a transaction. isolation, so transactions don't interfere with each other. Durability, changes are permanent once committed. So nice graphic show you ACID, but let's take a look at an example of an ACID transaction. So here, I'm going to get my pen tool out here, but notice we begin a transaction, and then we say at the end of the line, if it passes this transaction, if this all succeeds, then it will commit to the stuff here. And so the idea is that we're doing an update from bank account set balance 1. So we have 1 where we're doing one update and 2. And the idea is that both have to pass in order for this to be committed. Okay, so it's all or nothing. And this is really useful because when you're in relational databases and you're writing a lot of stuff in a lot of places, you don't want some data partially written when it relies on other ones, especially in bank transactions. And that's usually the common use case. And that syntax, like you get it in MySQL, you get it in Postgres, and for Delta Lake tables with Databricks SQL, you're going to be able to use transactions as well. So again, not specific to Delta Lake tables, but just understand what ACID transactions are. And yeah, there you go. Hey folks, this is Andrew Brown, and in this video I want to take a look at some of the functionality of Delta Lake, and so I figured ACID transactions would be fun. The ACID transactions is not specific to Delta Lake tables, but I think that we should try and get some practice with it because it's useful to know how to use transactions. In order to do this, we're going to need to set up some data. So let's go over to our catalog, and you can create a new catalog. We've showed you how to do that before. I have one called Playground, and then we also have one simple. I'll probably work with a simple one and create ourselves a couple new tables. I'm gonna make my way over to the SQL editor. And the example we had in the slides was this bank transaction. That's a really common example for transactions. And that might be something that we might want to do. So give me a moment to think about how I want to structure this as a transaction, okay? So just give me 2 seconds. All right, so I thought about it, and because we already have that table called to-dos, or the schema called to-dos, maybe what we can do is like create a project and also create a task. So we'll have to make some changes to our table. Obviously, we can use SQL to do this. We could also probably use Python directly to do it, but let's just stick with SQL for now. So this GenAI thing is not always the best, but the idea is that we want to modify a table. So modify our tasks table to have a project ID. Also, let's create a project table that has a column name. And let's create a table for tracking completion called the completions table, and it will store the task ID, project ID, and the timestamp of completion. Okay, so we'll go ahead and do that, and then we'll review it. So we have alter table, add project ID. That looks fine to me so far. I don't like that it's a string. Really, it should be an integer. So we'll change that out here. Then down below, we have project ID. It is primary key. And so let me take a look at our catalog. I can't remember what our table looks like. Actually, we can probably do it over here by just describing the table. So we'll say describe table, simple to-dos, tasks, because I just don't remember its structure. And we're just waiting for that to execute. It shouldn't take too long. I'll just pause here. Oh, there we go. So we have ID, task name, task temp. So the thing that I want is I want these to be integers. So I don't really like that it did this. Actually, we have tabs here. I don't know why we didn't just work in tabs. But we'll change this to ID. And I want this to be an int, or we can say big int. Okay. I'm used to just doing integer because in Postgres, it's just easy to do integer. But we'll go down here, and then we have our primary key down here. This is going to be int. This will be ID. We actually want this to be project ID still because we're altering the table for that. Okay. And then down below here, we have completion. So task ID, project ID, completion timestamp, primary key, task ID, whatever. I don't want that to be the primary key. I want it to have its own ID. I think that's a lot more normal. Could be wrong because I'm so used to working with Postgres, but this is how I would probably do it. And I'd set it as a primary key. I also want these to auto increment. Let's go back over to here for a second. And it shows us some information about the tables. It's not showing us everything that I want to know. Let's go over to the catalog because it increments automatically. And I want to see how that's set up. As I don't remember, like I know what it is in Postgres, but I'm not going to assume it's the same. And so if we go to details here, to tasks. I'm trying to find out if there's additional information on these on this column here. So we don't have column masking. So what I'm going to do, we'll copy this. We'll say edit. The ID for projects and completions should auto increment. Okay, so I'm just going to copy this. I don't want to lose our changes here. And then we'll generate and see if it can fix that issue. So just rewriting it. Generate always as identity. There we go. There we go. And so that looks good to me. We have a completion timestamp. I don't really need that, but it's fine. So I'll hit accept. Like it'd be nice to know. Normally I'd say like created at would be a more appropriate naming for it. And so this looks good. We have these three tables set up. We'll go ahead and run this and see if it works. It should create the tables. Okay, and I'll just open up a new query here so we can manage more than one tab here. Okay, so we don't need to have multiple pages here, getting confused. So go back to this tab here, and we have results. Okay, so I just want to describe the schema. Can we describe the schema? I know we can describe table. Well, we'll just select it. We'll drop this down here. So simple, to-dos, describe. There we go. Schema. Oh, we can describe the schema. And this will be the simple to-dos. Because I'm just trying to see, like, are the tables there? Okay. And so it's describing the to-dos. I'm not seeing the tables. What if we do table just like this? Usually you'd have to pick a very specific table, but I want to see if it'll show me what tables are there. So all I'm trying to do, so it describes the schema. I was hoping it would list tables for us. Okay, so I'm not seeing the tables. 1 second here. Let's go over to describe commands for Databricks. Now let's see if we can get a list of tables. That's what I want. Describe table extended. Well, you know what? We could try extended. That might help. Sometimes using the extended command will show us more information. Let's say extended. Do we just put extended on there like that? Maybe it's over here on this side. I don't remember. Yeah, that's a bit better. And so I'm just going to go here up to the SQL language reference because here they have all the stuff. And in this section, they have a huge section just for describes. All right, here's the describe. So we have catalog, function, procedure, schema. We'll open up this one and table. We also have show statements. Show tables, that's probably what we want. So let's go back over to here. I have many years of SQL, so I kind of have a sense of what the command might be. Okay, so now we have our tables. We have show tables, completions. Now we go show table. We might say completions here. I'm just curious to see what we'll see here. So we'll go back over to here. I mean, obviously describe table would be the more appropriate one, but it did have a show table here, which I was curious. Show table extended like employee. Shows information of all matching tables giving a regular expression. Okay, so that's if we want to do it. So here we just describe it. And we don't have the full thing here, so it might complain. We already know what it looks like. Again, I'm just doing this out of repetition to give you as much practice as possible, even though this is not necessarily our direct goal right away. Simple to-dos. Describe tables. Table. Simple. To-dos completion. There we go. Okay, and we'll do an extended while we're here. There we go. So we get additional information. So nothing super exciting in here. What I'm looking for to see is like normally when you do like a thing, it'll tell you if a table auto increments, but not really able to see that information the same way, but that's totally fine. So our tables are there. We need to insert some data into them. And I guess that's where our transactions come in. So let's go make another tab here. And we can maybe name this like transaction. So I think you can save these for later. Yeah, move to transactions. There we go. So as soon as you name them, they're going to be saved. That's nice. So I'll just call this transaction example. Okay, and so here we want to begin a transaction. I have it off screen here, so I'm just writing it out by hand. So begin transaction. And then the idea is, no, I don't want to execute that. I was just trying to hit enter. And then at the bottom we have commit, right? So the idea is that we want three things to happen. I want to create a record for projects ID because we don't have one right now. Then I want to insert something and then do something else. The thing is that with transactions is that if something fails because of a validation, that would cause a rollback. And right now in our tables, we don't actually have any validations on our columns, right? So if we go back to this one here, notice here, like it doesn't have any specific requirements. So here I would want to update this. So I'm going to copy this here into my new one here. And I'm just going to say, select all this here and just say edit. Or we can just say like, I need to validate that completions task ID and project ID exist on insertion. And update, right? So those should exist. So generate that out. Okay, but give me alter statements. So go ahead and do that. I might also just take this out like that, reject, and we'll take that out. We'll hit generate here, just so it's not editing something. We'll generate this out, and we'll get those alter statements. So here we're adding constraint, meaning like they have to exist for this to work. So we'll go ahead and we'll accept that, and we'll run all. So we're going to put constraints on there. And here it says completions, foreign key. Okay, so I'm not exactly sure what it wants there. I mean, we didn't necessarily put a constraint, but it might have been the error exists here. So alter table, add constraint, completions. What does it say here? The error indicates that the reference task does not have a primary key constraint on task ID column. You need to add a primary key constraint to the task ID column in the tasks table. Okay, but you know, the IDs of my table of each table are just the primary key of my tables are just called IDs. When we have foreign keys, we use a convention of singular name with ID, e.g. task ID. So let's make sure it understands that so that it updates it. I might just not be understanding these statements here. One thing that is on the exam is they want you to know that you can use this debug assistant. So normally I would just look it up and reference it, but because they want you to know about the system, what it can do, that's why we're using it. To add a foreign key constraint, you need to reference the correct primary key columns. Okay, and so here it's saying task ID and tasks, right? So referencing tasks and task ID, that's just supposed to be ID. And then this one over here is supposed to be ID. That makes sense because you're saying the foreign key of project ID references project ID, and we're adding constraints, so it has to be present. We'll go ahead and run that. And so that should apply it. It says task does not have a primary key constraint. Okay, so, all right. We have that. So I'm gonna go back over to this example where we set this. So here is an example of how we defined the primary key in our tables. is this a primary key that will work? Because normally when you set primary key in languages, you'll actually literally write the word primary in there. Again, because we're not using Postgres or MySQL, and we're using the Spark SQL, I'm not sure, or Spark SQL or Data Lake or whatever it is, I'm not exactly sure what syntax to expect. So I thought this was good enough, but it might not be. Auto increments, which is typically used as a primary key, which is true. However, to explicitly set primary key, you need to add primary key. Ah, okay, so that's our issue. To existing table, you can use this. So the idea is that we'll need to modify our constraints. So we'll go back over to here. Okay, we're gonna hit enter. Whoops, that's not what I want. Copy. And notice we can also, what's the difference here? Whatever. So we'll go ahead and paste. I thought it would give us another language. So here we need to modify that one. And then we'll modify this one, and we'll modify this one. So we'll go through this, and this will be tasks. And then we'll have projects. Projects. And then here we'll have completions. And then completions. Okay, and so this will be less of an issue. So now we will set up all those constraints there. Technically, this could be ran into a transaction. Cannot create because its child column is nullable. Okay, so I did this, and it probably wants a not null in it too. Yeah, it says nullable and retry. So usually you'd add like a not null, but I'm not sure. Can we just add not null? So it's going to say like, oh, just put not null in here. There it is set not null. So alter table. Yeah, so I'd have to do that separately first. I was hoping I could do it in one command, but I can't. But this is totally fine. We're learning lots as we go here. And actually, the tool here on the right-hand side is okay. It's doing an okay job. So those are in there now. Let's run it again. And so it says alter table, alter column is not supported for identity columns. Okay, so what I think we should do is drop all tables and start over from scratch. So what I'm going to do is go back over to here. This will be create to-dos tables, right? And so instead of goofing around with this all day, what we'll do is we'll just create all our tables correctly from the beginning. So let's go back over to here. So can we start over? Can we just create tables that have constraints, are primary keys, and not null? And so I'm hoping it gives us the table definitions here. Okay, and so that's kind of right. Let's go take a look here, copy this in here. We're gonna go paste this in here. So this is correct. I don't like task timestamp on this, and we're not going to store it on here, right? It's changing our names, which is annoying. I want to keep these nice and clean. ID, name. This is a convention from Rails, by the way, if you're ever wondering why I'm doing it this way. So here I have big int, etc. These don't put the constraints on. So go back over to here. And here we will add these afterwards. I'm not sure if they could be put in the table. Sometimes you have to create constraints after the fact, which is totally fine. So go here, you know, can this all be created in one go, or we have to add constraints after? Directly in the create table. There we go, because that'd be a little bit more cleaner, I think. So foreign key, yeah, okay, so then we're just setting it like that. And that's a pretty common way to do it. I wasn't sure if that would work, but yeah, we're doing foreign key, and so that's equivalent there. So now we have our three tables. We don't have any data, which is totally fine because we can use that transaction to do it. Okay, command to drop all tables. Let's go see if we can find that. There we go. So that will be the easiest way for us to do it. We're going to go over to here to this other tab. We'll paste it in. We'll drop all our tables, assuming it lets us do it. Sometimes if there's constraints or something, it might not let us do it. But we have dropped all tables, supposedly. We'll go back over to here. And save contents. Yeah, there we go. Now I'm going to run this here. Did I save it to the dashboard? Well, whatever. It's saved somewhere. It's saved somewhere. So now we should have our 3 tables. We can go back to our transaction example. Now we can create some data. So the idea is that we want to create a project, a task, and a completions. Let's first do an example where we know it's not going to work. So this will be example where transactions will fail. Okay, so we have a completions table. So I want to say insert into completions. I think it's like, was it values? It's been a while. It's like value or something here. We list the columns and we do that there. So we'll just go back to our reference here. It's okay if you don't ever remember, just look it up. As long as you can find it. So we'll go insert into. And insert into, can we get an example? Example, please. Here we go. So insert into students values. Yeah, I had that right. Well, that will be if you know exactly the order that you want. Oh, you put parentheses around the name. Okay. I prefer to do it that way because then you know exactly what you're inserting. So here I have task ID and project ID. One other thing with our table is it's not auto inserting the, what do you call it? This. It'd be nice if it created it at the time of, but we'll come back to that later. So we have insert into completions, task, and value. And so I'm going to do 1 and 1. So the idea is that this should fail because, I mean, even if we didn't have it in transaction, it should fail because these values don't exist. Let's say 1 and 2. Okay, so we'll run this. See what happens. The operation attempted to use Hive Metastore, which is disabled due to legacy being turned off in your account or workspace. Please double check the default catalog is the current session. Oh, up here, it's having some issues. So go over to here and we'll just set it. That's probably why it had an issue. Multi-statement transactions are not enabled for this workspace. Oh, really? What? I can't use those? Do we have to go over to our other account? Okay, so this error indicates that multi-statement transactions are not enabled. To resolve this, you can execute the SQL statement individually. Really? Is this feature in Azure or just not in Azure Databricks? Or just without having to contact rep? They probably don't know. Are not supported by default. Similar to AWS Databricks, you would typically need to execute SQL statements individually without using transactional. If you require transaction support, you need to contact Databricks. So I can't even show you this. Okay, so I can't show you this. But what we'll do, we'll take this out of here. What a bummer, eh? We'll take this out of here and we'll try to run it. And this should just error out. Okay, so it's saying syntax error at 1 or 2. Oh, right. Sorry. This is task ID, project ID. Sorry. I'll update it myself. Sorry. Task ID. I didn't realize the values were there earlier, so I just forgot and overwrote them without thinking. We'll go ahead and run that. And so this should not work. Column created is not specified in insert because I don't want to insert it. Did we have a nullable on that? Not null. That's annoying. So I'm going to take this out here. Well, first of all, I want this to auto increment. So I'm going to copy this here because we might use this table later on. Can we make our created at automatically insert a date on insertion? Okay, because that's something you could do in other languages. And so here, it would be this. So what I'm going to do, because this drop tables is useful. Drop tables. We'll save that too. Drop tables, drop to do tables. We'll save that. And I'll run that again. We'll go back over to here. And so we'll run this again. This should create our tables. It's assigned to column default, but corresponding feature table is not enabled. So please retry the command again after executing this. So apparently we need to do this. We'll go here. And so it's interesting those things are turned off. You just take them for granted in other ones, but that's fine. So we'll copy this here, table name. And we'll paste it here, paste. I mean, we're definitely learning something, but it wasn't for transactions. But we got to get this in good place because we'll keep using this stuff here. So we have the table name. So this is simple to-dos completions. Delta feature allow column default support. So we need to turn on defaults for a table. Can we do this while we're creating the table? I'm not really sure how that would work. I feel like that wouldn't work because the table doesn't exist yet, right? Let's go ahead and see what happens if we do that. So here, sometimes if you have a table and you want it to force create, we can do that as well. So what I'm going to do is go to create table. Because sometimes like create table, drop if already exists. So we have drop if exists. So this is something else that we can do and force it if it exists. And so this could be like an easy way for to reset it. So we don't need to drop our table separately. We just do this, like say drop. This here. If it doesn't exist, it won't error out. We could also do that like create table if exists. And so if it already existed, it wouldn't error out because it would just know that it exists and it would not complain. It is not, there we go. It's not being very responsive here today. I'm not sure why. It's going really slow, if you can see here. I think it's all the AI stuff. There's no way to turn it off though. Which is kind of annoying. So it's probably faster to type it than it is to paste right now. Simple to-dos, completions, projects. Okay, and so we'll run this again. I expect it to fail here, right? Also, this doesn't have a semicolon on the end. It might complain about that. On line 6, let's try this again, run again. The table completions cannot be found. Verify this correct spelling. This is on line drop view if exists, drop table if exists, line 2, completions. Well, that's the whole point. If it doesn't exist, ignore it. The table review simple to do completions cannot be found. Verify the spelling. That's why we're doing drop table if exists. Oh, the problem's over here. Yeah, so the table doesn't exist yet. So what we need to do is take this here. Okay, can we remove the created at from the table statement and alter the table and add an alter column to add the timestamp, because we need to do that in the correct order to get this to work. Okay, hopefully it doesn't rename our stuff too much. Here we go. Okay, good. And then we can take this and put it prior to the table like this. I'm having a really hard time cutting and pasting right now. It's insane how slow it is. It's just unbelievably slow. I want this to be one line just so my life's a little bit easier here. And we'll cut this. And we'll paste this. Okay, and so now I would expect this to work. So much for those transactions, eh? But we'll get ourselves set up pretty well here, so. Okay. Not null is alter table add columns is not supported by delta tables. I mean, I don't care if I don't even want it as a not null, to be honest. See here? I really just want a default on it. So I'm going to take that out here, and it has a problem with that. So we'll run this again, and then maybe, if we're lucky, we'll get a result that we want. Failed to execute the command because default values are not supported when adding new columns to previously existing delta. Please add the column without a default value first, then add an alter table column set default. Oh my goodness. Okay, so now what we need to do is we need to go back to here and say created at timestamp. I'm not setting not null in it. Then here, alter table completions. We don't want to add the column. We want alter table column. Alter table. Alter column. Column. That's the column. Set default current timestamp. But yeah, you just kind of figure out each flavor of SQL as you work through it. Just gotta have confidence that you know that you can do it, and you'll be fine. And so hopefully that gives us the table we want. Okay, good. And so now we'll just save this file. If it's not already saved, I'm just doing Control S or hitting that button, even though that doesn't really matter. And so now we'll run this, and my expectation is this won't work because these two don't exist. We won't get an error on the completion anymore. But here inserted the row, so I'm confused because here, these don't exist. So how did it do that? Okay, so we'll go over to here. I'm gonna ask it a question. Yeah, that shouldn't have worked. So let's go over here and make another tab. And I want to select all, so say select all from, and we'll just flip this over to simple to-do, select all from simple.todos.completions. And I want to see if any data is returned. Because normally when you set a foreign key, the expectation is that it exists. So maybe that didn't, like it references this, but maybe it lied to us and we do need the constraints on it still. I think that's what we need. So we want to go back to our chat, wherever that was. Comments, chat. I don't know how we get back to chat. Maybe it's over here. There we go. And so we'll go back over to here. This command should have not worked because the columns for the records for task and project do not exist. Do we need to add constraints? I thought you said references would constrain. And so this is where, again, this is why you have to have good knowledge of SQL and test things out, that it's not always true. Integrity, meaning that you cannot insert record values do not exist. And if the insert is succeeding without reference, it may be due to foreign key constraints not being forced. Okay, so we go here. Okay, are you sure? Are you sure? So it might not be that intelligent. If you need to enforce data integrity, you need to implement additional logic in your application that supports constraints like not null and check constraints that are enforced. Okay, so how do we use check? Let's go ahead and get that. While we're looking that up, let's go over to our reference here. Let's see if we can find check. Do we have check whatsoever? I do not see it there. Let's go back a step. We will go and look up check. There is nothing for check. Let's look under, since we're altering the column, let's go look at column here. Should be alter column somewhere here. If it's not there, I guess we could look at table, alter column. And so here there might be a check command. Adds constraint, adds a check constraint information for that information. So, I mean, I really think that it needs to add a constraint that way. And here we see check, condition check. Okay, but for my foreign keys, and I'm not going to play around with this forever. It's not that important, as we're kind of getting way off topic here. But that doesn't seem right to me. That doesn't make any sense. So anyway, I'm not sure. This is not really the point of the lesson, but the point is that shouldn't have inserted. It should have thrown back an error, which is fine. But like if we were doing transactions, we'd want that stuff to exist. I might just try one more thing. Let's just see if we can just add those constraints after the fact. 1 second. Yeah, no luck here. But anyway, we at least have this table here we can work with. This is a bit of a problem, but we'll solve it later on as we go. I just don't know off the top of my head how to do it with Spark SQL. Other languages, this would normally work. But anyway, we'll figure it out as we go, okay? Ciao, ciao. Let's take a look at Delta Lake time travel. This allows previous table versions, which is helpful for auditing, debugging, reverting changes. So the idea here is you can review history and see past operations and versions. You can roll back by undoing writes by restoring a previous version. You can query old states for compliance or data analysis. So the idea here is it will write describe history table name, and then we will see the versions. Notice we have the version, the timestamp, check at the operation, like what operation was changed, the parameter information, you know. But the main thing is that you have that version number, right? And so if you want to query an old one, you can say select from table, version as 3, and timestamp. We actually cover this more than once in the course, because the reason we cover it more than once is because this is something that you are going to encounter more than, like, it's definitely going to be on your exam. And so I want you to know that you have this version as 3 format and this timestamp as whatever format. But when we go through all the SQL commands, we're going to repeat these again to make sure that we know that we have this stuff, okay? We can also restore a table from an earlier version. So here we are using the restore command, and we're saying from version as of 3, timestamp of restore. If you can remember that there's just these 2 ways of doing it, that would definitely be 100% a question on your exam. They'll be like, okay, which of these are valid as a way of stuff? And if you know those 2, then you're good shape. Time travel relies on the Delta log transaction history. The default retention is 30 days. And this is great. This feature, time travel, is great for when you have accidental delete, updates, or overwrites, okay? Hey everyone, it's Andrew Brown. We're going to take a look at Delta Lake time travel. This feature allows us to look at the history of table changes. And so let's go ahead and give this a try. Now we have created this create to-dos table, and I have this already populated. I already saved it in my workspace. If you didn't watch the attempt to make transactions, you wouldn't have this code, so please go watch that video, as you should watch all the videos. Don't skip any of the videos. Watch all the videos because some build off of other ones, right? And so in here, we already have 3 tables set up, tasks, projects, completions. And the idea is that we want to make changes and see what happens to those tables as we change them. So we have other tabs here. I'm just going to close these other ones as we don't care about them. I have this new query one. If there's anything in it, we're going to clear it out. But let's try this out. So we have describe, and remember to set your thing, simple to-dos, right? It's describe history, and we're going to choose history. Did I spell that right? History. I think that's right, history. There we go. Even though it has squigglies, we'll just ignore that. We'll do simple to-dos. Completions. That's the only one that actually has data in it right now. If you don't have any data, that's totally fine. We can always just generate some. But let's see if there's any history whatsoever. Now remember that any table you create here should be a Delta Lake table, so these commands should generally work. Well, we will give that a moment to execute. And here so we actually have some changes. So you can see we created the table, we set a table property, we changed a column, and then we wrote to the table. So that's what we did last time, right? And that's pretty much it. There's nothing super exciting about it here, but you can see, like, you know, if it was executed within a notebook, was it in a cluster that this happened? What is the read version? The operation metrics, so what was actually changed in terms of its information. Okay, and like who changed it and what, and so there you go, like that's it. So we actually got a short one for once. Well, hold on just a second here. Let me see if there's anything else here. We can query for specific versions, and that might be something we might want to do here, because on the exam, these definitely come up, which are kind of annoying, but we might want to say, I'm just going to comment this out for a second here. We'll just comment this out. But we might want to look at this and say, let's select from simple to-dos completions, version as of 3. And this might not be very good for this example because the data won't look that much different. Okay, and so we have some data here. There's one record. So for this to work, we'd actually have to insert a few things. Okay, so let's go ahead and insert some data. And actually, let's work on tasks, because tasks is a much simpler, or projects might be a better idea. No, tasks, we'll do tasks. First, we'll make a project, sorry. Because the reason I'm debating that is because a task requires you to create a project. We've never created a project before, so we really should do that first. So let's say insert into projects. And this might be something that we should do over here for a moment. We'll go down here. No, we'll leave it over here. Sorry, no, I'm indecisive. Insert into projects. Simple to-dos, projects, name, and this will be values, yeah, and it will be big data pipeline as our project. And then after that, I hit enter space, so it's executing, which is totally fine. Okay, and so then after this, we want to then go ahead and insert some more data. So let's say insert into simple to-dos tasks, name, project ID, values, and then here we'll have something like hello world. I don't feel like writing this whole thing out, so I'm gonna just copy this. Let's set a variable to get the first project record, and store its the ID as the variable. And then let's create insert data for tasks and pass the project ID and create 10 inserts with real world task names. A bit messy, but we'll go ahead and see that. The thing is, like, if we do an insert statement in one, it will only be one version. So I'm hoping that it'll separate them out as separate. I might try to do it efficiently here. Okay, so here we set the project ID. You normally can't do this in other things like Postgres and stuff. At least I don't think you can. So this is a really nice and easy way to do it. And on the exam, you will see code examples where they'll have set project ID and things like that. So that's why it doesn't hurt for us to learn it. Okay, make each insert statement, insert record, its own statement. Okay, so we're saying do the same thing, but make them separate because we want to see that versioning, right? So we'll give it a moment for it to separate that out. There we go. That's what I want. It's not the efficient way to do it, but we want to see all those versions and see what kind of data we have. Okay, so that is good. I like that. We'll accept that. We have this little mess down here, which is fine. I'm not sure why it's doing this cross out, but I think we have project ID twice, so that doesn't make any sense. So we'll just do this. And we'll just say like seed data. We'll try to keep our seed data together. I know we're kind of a mess with these SQL things, but we'll see the best we can do here. So I'm hoping that it will set the project ID and then it'll set them all to be the same, and then we'll have that information. Okay, I assume there's a project ID. I think we set that earlier, right? We go over to here and take a look at our tasks. Yeah, there's a project ID. The operation attempted to use Hive Metastore, which is disabled due to legacy access, turned in your account. Please double check the default catalog. It's because we keep forgetting to set this. Let's go ahead and make sure that we set those to-dos, and we will run that again, okay? We have a little bit of a problem. Migrate to the parameter marker syntax. Okay, I don't know how to do that, so let's take a look here. Because I don't normally have the set function in other things. This is Spark SQL specific. It's not used to define variables in SQL. Instead, you can use a subquery to insert. Really? We can't do that? Okay, then where does the... that's not a very good way to do it. So Spark SQL, setting variables. I could have swore I saw this syntax before in questions. Yeah, there's this. See this? See, we have set. Okay. Is it declare instead? I mean, I wouldn't mind that as well. That'd be fine. Let's try declare. Maybe we just can't use an active query like that. What if we just set one like this? Would that fix it? Maybe the problem is it's just the embedded query. It can't do an embedded query. I forgot to put the this on here, right? Try this one more time. Just a moment, okay? All right, and so there's Spark SQL and then there's Databricks SQL. So, but anyway, here they actually define it first and then they set the value. Okay, so that's what we're looking at. But can we make it a query? It is here, right? It is using a query. So let's go back over to here for a second. Let's put our query back here. Before we do that, let's do a declare on that. So we have a declare variable, etc. So I'm going to just copy this for a second. So we'll call declare variable project ID. We'll call it big int. I don't want a default. I don't want a number on that. Let's see if it'll take this. Oh, you know what? I got to cancel that. There's a spelling mistake here. There we go. So we'll let that run again and we'll see if it works. I said this was going to be a fast one, but I guess I kind of extended it because I'm showing you more. But hey, we got to learn this at some point. And I don't think I specifically covered this as a lecture slide, so it's good that we're covering it now. Configuration project ID is not available. Where is it erroring out on? Let's go over to here and take a look here. So we declare it. Let's go back to the set. So we declare it. We set it, and then we can use it. But they're not doing like $signs or anything like that, eh? So, Again, let's carefully look at the documentation here. So declare, set an SQL to a value, set var values var1, set an SQL variable to a value inside of a compound statement. There must be a way to do this. I don't know if I trust whatever Databricks uses. Let's go over to Claude. Let's go ask. I am trying to set a var and then reference it. I am using Databricks SQL on the SQL platform. Will this work or do I have it wrong? Because we're seeing references, but I'm not seeing any like actually inserting statements the way I think it's inserting. So it doesn't support declare variable set statements like SQL, but it shows it. is for queries dash for not referencing SQL. And so here it's going to use the with statement. Yeah, so I guess we can't use it there, but I've seen this many times, and we're seeing it here. One second. I just fed it some docs. So I'm saying like the declare variable statement's obviously here. Now it's going, oh, you're absolutely right. Thanks for the correction. It does support declare variable statements. So they just took out the parentheses. That's what I thought might have been messing it up because we saw the other reference for it. Let's go see if that fixes the issue. And you notice like that was going to be my next thing I was going to try, right? So it's not like I was far off from figuring it out by myself. Okay. It's not task name. It's just name. Come on. I know this is painful. There we go. Okay, let's try this. See if that works. Configuration project ID is not available. Configure not available. Okay, so we'll go back here because I really want this to work. Okay. Okay, but it says, like, is this something we can only do in PySpark? It's going to drive me crazy if I can't figure this out. Yeah, it might be not all context. Use declare var instead. Use session prefix. Check Databricks SQL. Declare variable feature might be available in notebooks, but not in the Databricks SQL queries. And yeah, because like this could be another way that we could do it. So I'm not sure. I don't think it's declare var though. Yes, it's declare var up here. Just a moment, okay? All right, let's go try this in a notebook because I don't trust this SQL window here. So we'll make a new tab here. We'll go into workspaces. Or home, sorry, we'll go to home. And we should have, I have so much junk in here, but I don't care what table, we call it, notebook we use, but I'll go into this one from before. And so I'm going to go all the way down the bottom here. And we'll just create some code. This will be SQL. And how do we determine where we're running this against? I guess we'll find out in just a moment. Oh, by the way, this project is not correct. It should be simple to-dos project like this. I wonder if that was the problem we were having before, but let's go find out. See what it tries to do here. We'll give it a moment. This is all just so we can see versions of data history. That's all we're trying to do here. And the reason I'm so dead set on this is because I told you the set works and I wanted to be right. So that's why we were persisting through here because I know I've seen it. No issues with the statement so far. Oh no, it did. Configuration project ID is not available. Okay, one moment. Just give me a sec. All right, so some people say online that that's TSQL and only if you have certain type of table types it might work. But Databricks literally makes a video saying like, yes, you can do it. And I'm doing it exactly correct. So it's very, very bizarre that it's not working. But maybe let's try some backticks. Sometimes backtips helps on this stuff. Maybe it doesn't know. Maybe it thinks it's something else, project ID, or let's just try like var project ID. Let's give it a name that doesn't exist. Okay, that might not have a conflict. So that'll be, first of all, let's just define it. Let's just define it, okay? Let's see what happens. Can we at least define it? If that doesn't work, then we can kind of narrow down what the problem is here. No problem, okay, so it's set. And so now it's called var project ID, and so I'm grabbing from this location here. Oh, right, we're in Python. I mean, yes, we can do it that way, but I want to use SQL, so that's fine. So here it says configuration var project ID is not available. So it's this line here that's the problem. What if I just give it the value 1? Let's comment that out. And let's just give it the value 1, like that. Will that work? Put this on another line so it doesn't conflict with it. So it's not the declaration. It's something with this. Just a moment. All right, so I think it's a minor syntax error. I think we're supposed to put set variable in front of it like this. Okay, and that's probably the reason why it's not working. So go back over to here. Really, you just got to really pay close attention to this. But let's see if that fixes our problem. Does that fix our problem? Does that fix our problem? Does that fix our problem? It does. Okay, let's go back to SQL Editor, which I have over here. And so it's interesting like how the debugging can't figure that out for us, but we can figure it out ourselves. So I'm not sure, like this should be fine. But just to make things, I just don't want to set it and it being confused. So I'm just going to go ahead and do this as a habit. We probably should just do this out of habit. Var. If I was on a Mac, I could edit this in one go. There we go. Right? Do not trust, I mean, you already know this, but do not trust AI, as it will really take you for a loop. There we go. Yeah, a lot of conflicting information, like saying, oh, you can't do it, you can do it. But if I can see Databricks and they're doing it, it has to work, right? So this should work as our insert, hopefully. I'm just going to pause because it's taking time. All right, so we are back. It says number of rows affected, number of inserts here. There are 12 results. So it's possible that I was just inserting that every time. Let's go back over to here. We had, oh, right. So remember we wanted to search the data. We're doing some inserts here, but we wanted to say like, show us the version. So we'll go back here. We'll look at our versions. We should have lots of versions. Not for this, but if we go to tasks, run the tasks. Now see we have like a lot more. And so here we can now just go ahead and say select version 8. Oh, tasks, sorry, tasks. Run. Okay, and so notice like the records we have, if we were to go to like a smaller value, like 4, I feel like we'll get less data maybe. See how we have history of data, but also changes to the table. And just remember, there is also the timestamp. We're not going to test timestamp out here because it's a pain to structure that timestamp and figure it out, but you can see the structure. They're not going to like test you on the exact structure, but you need to know time as whatever. Those are the two only options. We did it. We'll see in the next one. And we also learned about variables. So there you go. Let's take a look at optimization. And so when we're optimizing a delta table, we have a couple commands we want to know in SQL. The first is optimize, and the second is zorder by, which are used together. Optimize will compact small files into about 1 GB chunks, and zorder by will physically organize data by selected columns to boost performance. So here you can see optimize along with zorder by. And the idea here is that you want to use high cardinality columns for Z ordering. When we say high cardinality, a customer ID is good because, you know, you're going to see that stuff repeated again and again and again. So like high cardinality is like things that you're really good at grouping stuff together. Whereas low cardinality, like a date, is going to be better for a partition column, if that makes sense. So because imagine that you can have a lot more variation in dates than you have columns. But again, it depends on how many customers you have. So that might be subjective. But anyway, so limit zorder by to 4 columns or fewer. Run optimize on a separate job or cluster. Use compute optimize instance types. Schedule optimize regularly, daily, weekly for efficient file layout. And I just want to point out that we do talk about optimize somewhere else, maybe in the SQL section. We're trying to get double coverage on this just because you need to see these things multiple times and they're important for the exam, okay? Vacuum is a Delta Lake command that you're going to want to know. It permanently deletes old unreferenced data files and reclaims storage. This specific command is not unique to just Delta Lake tables. Other providers have them, Postgres, I believe MySQL, maybe MSQL, but you need to know it either way. The default retention is 7 days to protect against accidental delete loss. And the idea here is that you do vacuum table retain for a period of time. Avoid retention for less than 7 days unless time travel isn't needed. Use after heavy delete updates or merge. Run regularly to control storage costs and maintain performance. And again, we cover this in the SQL section, slightly different, but yeah, again, multiple exposures so you remember this stuff for your exam. Let's talk about write and load commands. So Delta Lake supports powerful commands to manage how data is written and duplicated. Again, we actually look at all examples for every single one in the SQL section, but I'm just trying to group this in a way so you think of these together, okay? So key use cases of commands: create or replace table, replaces a table and all data. Insert overwrite, replaces data but keeps the schema and table. We have merge, used to deduplicate or upsert data using a matching key. We have copy into, efficient for incremental file ingestion, so we won't reinsert duplicate files. When to use what? Use merge when upserting or deduping. Use copy into for loading from external sources without overwriting. And that should be good enough for your exam, those use cases there at the end, okay? Hey, this is Andrew Brown, and I want to take a look here at some of the write and load commands that we have in Delta Lake and give them a go. I don't expect this to be too difficult. I know we had a couple difficulties with our previous labs, but that doesn't mean every single one's going to be painful. We do have these tables set up, and they already do exist. And of course, if you haven't created them, make sure you create them. And if you don't know what they are, make sure you're doing the labs in order because one builds over the other. So we have a few here that we'll look at. And so I do have the documentation pulled up here. And so I'm just going to close out a few of these tabs so we have a little bit better focus. We'll get that one out of here. Let's see if we can find some of these and use them. So one is called create or replace table. So we have create or replace table. Replace table. And so notice like when I type in create or replace, it doesn't work. It's probably because we have to go to the create table and then we'll see that information. So we'll go down below here. And we have create table. So it's not showing up here, but we'll say create or replace table. Databricks. Okay. Yeah, so now it's here now when we go into create. So I had to go create table using. So defines a manage external table, optionally using a data source. I mean, I don't necessarily want to define an external data source, but if that's how we have to do it, we'll take a look at that. So let's say create table. We'll go all the way down to here. And so defines a table. You can use existing. So we have create table using. Use the syntax table. It will be define, derived from an existing storage or here. Then we have create table hive format. No. Create table like, create table clone. So I guess we really have to look at this one here as examples. And specifically, again, we want to look at this create table replace table syntax. Let's see if they have any examples for us. So I'll just make this a little bit larger as I realize that's a little bit small, of course. So we have create a table. Okay. Create a managed iceberg table. So using iceberg. So that allows us to change the type of table, which is nice. Use data from another table. So that allows us to select data from a table, which wouldn't be a bad idea for us to try out. Create table using a CSV location, which is fine. Create table with a student. I'm looking for that replace, but again, we're just reading through this to figure it out. Select table properties with different clause orders, no. Create a partition table, no. Create table with a generated column, no, but generated columns are pretty cool. So where's the or replace? They don't even have an example of it. So let's go all the way to the top here. It's in the syntax. You can see it right here, create or replace table. Okay, so if we don't have an example, let's see if we can open up our chat here. How do I use create or replace table. Like, I thought maybe create would be, like, obviously create is that, or is the keyword replace there instead? No, it's right there. Okay, so it's just reinforcing a creation if it already exists. So you know up here where we have drop table if it exists? And so I was thinking about this earlier, like normally what we do is we have drop if exists or create if doesn't exist. But I guess this is going to force a create. So I'm thinking what we can do is we can go here and just say or replace table, right? And now, okay, this is perfect if it works. We can use that. But it is complaining, like we can see that it's here, right? Okay, and let's just see if it works. So it's either going to error out or it's not. And so here we have syntax error at replace. So creates the table task or replace. What's confusing is we can see it in the definition, but it doesn't like it. Okay, so we'll diagnose the error, which is confusing because it clearly can do it, and according to the syntax. The error is due to incorrect usage of create table replace. The correct syntax is create or replace table. Okay, so I'm going to copy this here. Did I spell it wrong? Does it look wrong to you folks? Oh, you know what? It's create or I think I have the additional word of table in here. That's my problem. Okay, so it's I keep thinking I have Vim commands. I don't have Vim commands. If you know me, I love my Vim. I don't have it here, which is fine. So we'll go down here and we'll erase that. We'll go ahead and hit run. We'll try that. Oh, so this one doesn't have the word table. There we go. And so, I mean, we just simplified our query, which is really nice. We're getting closer to our problem. Create or replace table on line 2. So I'm not sure why we have a double line here, but we'll just take it out. Yeah, we'll just accept it. I guess it just fixed it for us. So we must have had a syntax error. Okay, and it runs and it creates the stuff, no problem there. So that's really, really good. So we solved that. That was really good. So we have insert overwrite. So replaces data, but keeps schema and table. Replaces data, but keeps schema and table. So let's take a look at that 1 second. So what I'm thinking here is that obviously you can insert data, but the idea is that it's going to overwrite existing data. So let's go back to our SQL reference here. Okay, we'll go down to insert overwrite. And so here we have insert overwrite local directory. We'll go down to examples. And the idea is that it's going to pull in data from a location. So what I'm going to do, it says using Parquet. Does it have to be Parquet? Can it just be CSV or something? We can implement text, CSV, or JSON. So that might be a good chance for us to use JSON or something. So we'll go ahead and copy this command over here. I'm going to make my way over to another tab. This might be a little bit better for a notebook. I'll create a new notebook here, folder. Write and load commands. Okay. And, oh, I didn't mean to make a folder. I meant to make a notebook. So let me go back there. I apologize. We will go ahead and delete this folder. I don't need this folder. Move to trash, move to confirm. Create a notebook. And so we'll rename this to write and load commands. And so we'll go ahead and paste this in here. This is obviously SQL, and it's trying to load stuff from a specific directory. I'm going to switch this over to JSON, and we're going to go ahead back over to our workspace here for a second, and I want to create a new file. This will be a JSON file. Apparently, I can't just create a file. No. Oh, we just got to be patient with it. Okay. So we'll call this like, oops, we have too much stuff here. And so we'll go here and just say tasks JSON. Okay. And so I need to generate some data. So I'll go over to Claude here. I'll just say, I need a JSON array of objects. Actually, I don't know what it wants. Normally, I would think that if you have JSON, that it's going to expect a JSON lines file. So I have a JSON lines file, and it defines objects for ID, int, name of a task. Actually, this is going to be project ID. We'll just make it 1. Create me 20 records. And the reason I think like it's JSON lines is that often when you have data and you're moving into like data warehousing or something like that, JSON lines is one of the most efficient ways to create that data. We don't apparently have constraints. Remember earlier when we inserted into our completions, it didn't really do what we wanted it to do. So I'm assuming that it's not going to complain if we don't have a project created. And I'm not sure why that didn't copy, but we'll try that one more time. And we'll go back over to here. Okay, and we'll paste that in. So now we have this file here. What we need to do is figure out where this is located. So I'm going to go back over to here. Let's go back to our workspace. Let's see if we can find exactly where this file is. It'd be nice if we can get the exact path of it. Copy URL path, full path. There we go. And that way we don't have to think about it. So this one's in workspaces, users. So this isn't in another place it's in here. So using JSON, so we have to insert overwrite directory using JSON. Okay. So now, I'm trying to think about this here because here we're saying select from this table. Are we writing into this file? I thought we were going to write into it with this file. Maybe I misunderstand how this works. Give me just a moment, okay? All right, so I might have had this backwards, and I was thinking that we would write into the table, but I think insert overwrite directory is literally writing to a directory. So instead of going to a table, you're actually selecting data and then putting it into a file, which is fine, but it's not exactly what I want to achieve here, especially since I don't have any data populated currently. So I was hoping that we could load that data in here. So maybe that is our wrong command that we want to do. But over here, you can see insert overwrite students values. And the idea here is that if there are conflicting information, so here we have select from students, and we have a bunch of students like 1, 1, 2, 2, whatever. And here we have the exact same fields. I'm imagining that it's inserting on the student ID because maybe that's the primary key or the key that it's looking on. And the idea is it's going to override it without issue. But here it says select from students, and then that's all the data we get back. So it replaces all of the data. Let's go find out. 1 second. Okay, yeah, here. So it says insert new rows into a table and optionally truncates the table or partitions. You specify the inserted row by value expression of the query. What's interesting though is when we looked at this, I didn't see it saying truncate, as if it's optional. Okay, so I don't see it being optional. It seems like you have to do it. Oh, I guess overwrite does mean it's going to. It does mean it's going to replace all the data. Okay, so if we go back over to here, so this one's not going to be any good for us. Let's go ahead and make another cell here, and so we'll go over here. Can you change this JSON data into an insert overwrite? Overwrite in Databricks SQL. And hopefully it can just do that. Okay, we don't need to do all of these commands, but there are some that I think are worth our time. So we'll go ahead and do that. And so now we have that data ready to insert. We'll go ahead and grab it. So the idea is that I'm thinking is that it's going to grab that data and replace anything that's there. So we'll go ahead and paste that in here like that. And so this needs to be simple.todos.tasks. We'll go ahead and we'll hit run. What's strange is that it's going 1, 2, 3, 4, 5, which is not exactly what we want. Also, it doesn't have the project ID, so it might complain here. So here, we really should say like project ID and name. Okay. But we'll give it a moment and see what happens, okay? All right, so obviously this would have failed for good reasons. Cannot simply do this, not enough data columns. Target has 3 columns but inserted 2 column datas. So this is obviously a little bit of a problem. So we'll go over to here, and the 3 columns, it's gonna be this, I believe, ID, project, whatever. And so we'll go up to this, and we'll go back over to here and just say like, hey, we need a project ID column, please. All to 1. Okay, and we'll get that data updated. It's so nice. I mean, Gen AI aside, it's so nice to be able to be able to do this so efficiently, right? Because back in the day, this was a lot of manual work on my part to make that data for you. And now we are just streaming on by. So let's go ahead and try that. And so I'm hoping that this works. So here it says providing for generated ways as identity ID not supported. So you'll notice there's always some kind of catch for this. So it didn't insert. Okay, we'll just say, can you, the ID column. Okay, because maybe it will auto-generate it. There we go. But yeah, as we find out, there's always these little weird edge cases, eh? It's never just what you hope it to be. Okay, we'll run that. And there we go. So it inserted 20 rows. My question is like, what do we have for data? So I can just add another code here, and we'll use SQL. We'll say select all from, was it? Yeah, simple tasks. So we'll run it. So what I want to test is like, does it actually, when it overwrites, does it also truncate the table? So we do have 20 rows. So if we go here, we take out X amount like this. And let's put our semicolon on the end here so that it's a complete statement. The idea is that I'm thinking that there's only going to be X amount of records and not 20 after this execution. Right? So we do this as 9 and 9. So now we run it. How many do we have? Do we have 9, 29, 20? Now we have 9. So literally that's going to not only insert it, but truncate the data. Let's go take a look at merge. So go over to here to merge. So merge into, go into. So merge is a set of updates, insertions, deletions based on a source table and delta. Let's go down to examples. So you can use merge into for complex operations like deduping data, upserting data. So here we have merge into target using source on target key, etc. When not matched, when matched by source. So it's based on conditionals. Let's go over here and say, can you change our SQL to be a merge insert for demonstration? Okay, and let's see if it can do it. Okay, so let's see if we can make sense of this. So we say merge into this as target. So that's where we're merging into. That's where it is. And here we have as the source. So on target name. So we're matching the target name with the source name and target project with the target ID. When matched, then update set project ID. The only problem with this is that we don't have another field here. And because we don't have another field, it doesn't make for a very good example. 1 second, Baco's calling me. Andrew wants to work in the lot. My co-founder, he lives, he's my neighbor, but between us, we have a shared lot that we bought. And so I guess he wants to transplant some of the strawberries before the winter comes in. Bit of behind the scenes here. But anyway, the reason why this would kind of suck as an example is that it would need an additional field because the idea is that it's going to merge that data into, but if the data is exactly the same, nothing would change. But if you had additional information, then I would assume that it would insert it. So, you know, does this include new records that didn't exist before? Okay, so I mean, it'd still work with that example. Okay, but But did you add new data for our use case? Okay, that's what we're trying to figure out here. We could compare it and look at it. There's only a few here. Set up projects, set. I guess there's a lot of records, so I think this actually would work. So we're not even going to let it change it. We're just going to copy this here. Because obviously there's only 9 here, right? And so I'm going to go up to this one as I don't care that we have an overwrite here. We'll just take it out. And we'll go ahead and execute that. And so it says column aliases are not allowed in a merge. Okay. So it has an issue with this line here, column aliases. As source. Okay. So when they're talking about aliasing, the idea is that you say a table has a different name. That's what it's talking about. Or it could be a column has a different name. But we'll go down here. I'm looking for the schema definition here. Merge using table. And it says source alias. It has target alias. So it has those definitions there. That's confusing because it looks like in the documentation that you can do it. So we'll go over to here. And we'll feed it over here. Maybe there's something it knows that we don't know. Column alias. Oh, so when the columns were aliased. Let's go back up here and take a look. Where I don't see any columns being aliased, so I'm not sure what it's talking about. As target for alias into the merge. Oh, so all they had to do is remove that off the top. Okay, but that's still not column alias. That is table level alias, but that's fine. We're not going to split hairs here. We just can't do the as target there. So we'll go back and paste that in here. I'm just curious. Let's go back and take a look at the documentation again. Because it says target alias right there. So, but I guess that's just for the source, right? So I guess it's not saying there's target and source aliasing. So I guess that's fine. Let's go back over to here. Cannot resolve source.name in the search condition. Okay. I'm just going to accept. Well, I didn't mean to do accept and run. It's still going to fail. I'm just trying to get this red stuff out of the way so I can see what's going on here. So here we have merge into tasks using these values as source on task.name equals source.name and task.id with project ID. When not matched, then insert. When matched, then update set. Okay. Column alias is not allowed in the search. Line 1, merge into. I don't know what it wants, so we'll go ahead and give it a try here again. Okay. But I'm just carefully staring at it. Let's go back to the examples and take a look. Insert into values. Oh, merge into, sorry, merge into. Merge into target using source. Okay, so but it's not showing us the data. You know what I'm saying? So we see the source, but it's not showing us a fully expanded one. Now, here it's going from one table to another. It says target rows that have matches in the source table. But what we're doing is we have a subquery here. Okay, we'll go back over to here. From source. Using select from values instead, referencing it. Okay. Because the example, they don't have an embedded one like this. And so that makes me think it has to come from another table. Okay, so I'm going to go over to here and grab the schema. Version 2. So it's going to say, are you sure we can insert from values? Doesn't it have to be from another table? Yeah, which suggests that it expects a table reference and not value classes. And so that's what I was kind of thinking of. So here, I guess we could create a temporary view. So here we create a temporary view, which is a temporary table. We need to learn about these at some point. So let's go ahead and do that. It's actually not a bad idea. Okay. Let's grab this here. We'll go back. Okay, and so we do learn at some point in this course that you can create these temporary views. Okay, and so the idea is that it's just like data that's supposed to hang out for just a little while, and it'll be gone at some point. And then we'll go ahead and grab this, merge into. So merge into using temp task. Now, can it use a view or does it have to be tables? I did give it the full schema, so it should know. We'll go ahead and see if that works. Oh, it doesn't know that it's SQL. So we'll just change this over to here like this. Can this work with views though? And it did, perfect, okay. I'm just gonna go outside for just a second to show Bako how to transplant strawberries. We'll be back in just a moment, okay? All right, I'm back. We got some strawberries planted, and in fact, we got a nice big pumpkin. So we've gone through some of the commands. I mean, there's a few other ones here. If we want to do it, we'll do those in separate videos. The only one we didn't do was copy into. I guess we should just do it and get it out of the way and use copy into. As I don't feel like that one will take too much time, so let's just do this. I keep saying that, but the reality is these things just take a different amount of time. We'll go all the way to the top here. We'll go to copy into and loads data from a file location. So that's kind of what I wanted to do earlier when we had the directory information. So maybe we can just rework that one in. And we do have JSON over here. So let's see if there are any examples. No, we're not seeing any examples, but let's just go see if we can get this generate for us. So I'll just go over to here. So I have this. Can this be instead a copy into? And let's see if we can get it to do that. So we have copy. Look, it's called, let's go give it the definition. It might help it if we give it the definition. That always helps. Go all the way to the top. Okay. And, of course, we could use the Databricks built-in one, but I don't want to do that. We'll see if we can help it out there. From to a source target table, yeah. Okay, so give me the copy into our task table. No, it's not doing it right. Like it's from, we'll go over to here. We'll go ask it. Can you give me an example of copy into from a JSON file to our target table of tasks? Okay, let's see if this one can do it. Because you think that their agent would be more trained on this information? Okay, but this is, I just want to do a local file here. Directly using a local file commands. Okay, but sorry, like local as in local within Databricks. Okay. Okay, let's go over to here and take a look here. So we have copy into target table from source clause, file format, validate files. I don't know. If we need to do this, we'll come back to it. I can't say I'm finding these examples very well. Give me just a second, 1 sec. So the thing is, like, we can copy from S3. I've been having some issues getting my external storage hooked up. So right now I don't really want to do that. I was hoping that the source could be somewhere that's not that. I don't know if so it says with a large directory, multiple producers, easy way to coordinate. So this would normally work with autoloader. If we ever get autoloader to work, I feel like we'd end up using this. So we'll leave it alone. And this is the best that we can do for now. But yeah, there you go. Ciao, ciao. Hey, this is Andrew Brown. We're going to take a look at Delta Lake statements. These absolutely will show up in your exam, such as generate, optimize, restore, and vacuum. Those are the four that I saw. So make sure that you know what these are because they're going to really help you out score some points on the exam. So the first is cache select. And as it suggests, you're going to select from a range, and then that's going to cache that to disk. So, that's what that's going to do. We have convert to Delta. So it converts an existing Apache Parquet table to a Delta table in place. So it's just converting it from one type to another. We have describe history, returns provenance information, including the operation, user, and so on. For each write, the table history is retained for 30 days. So there we have our table history down below as we do describe history. We have FSCK, repair table. So removes the file entries from the transaction logs of the Delta table that can no longer be found in the underlying file system. So this is just a means of cleaning up your files. We have generate. So it generates the given mode. So down below, there's different modes, and one mode that we can do is we could generate a manifest file for a Delta table. So that's an example of that happening there. We have optimize. So optimizes the layout of the Delta Lake table. Optionally optimizes subset of data or co-locate data by column. If you do not specify co-location, the table is not defined. With liquid clustering, pin backing optimization is performed. So yeah, it's going to optimize the tables. It says reorg table, reorganize the Delta Lake table by rewriting the files to purge soft deleted data, such as column data drop by alter table drop column. We have restore. So restores a Delta table to an earlier version. This one you want to pay attention to, especially here. I'm going to get my pen tool out, especially the syntax of how you can do it. And there's a lot of ways you can restore, but if you look down below here, it says restore table employee, timestamp of this. So restore the employee table to a specific timestamp, restore to a specific version. Look where it says version as of 1, right? Restore the employee table to the state it was in an hour ago. So here we are getting the timestamp and we're minusing from there. So look up here where it says timestamp of or version of. Those are the two that you need to remember. You might, because you might get those on your exam. We have vacuum, so remove unused files from a table directory. And there you go, okay? All right, so what is Apache Spark? It is an open source unified analytics engine for big data and machine learning. Spark lets you run workloads much faster than Hadoop, 100 times faster in memory, 10 times faster than disk. So why is Spark described as lightning fast? Well, it has to do with the collection of libraries that work well together to form an analytics ecosystem. So you have Spark Core. This is the underlying engine and API. The API supports the following programming languages: R, SQL, Python, Scala, Java. You have SQL, Spark SQL. This introduces a data structure called a data frame, which can be used with DSLs, so domain-specific language, to work with structures and semi-structured data. You have Spark Streaming. This allows Spark to ingest data from many streaming services, as you can see there. You have GraphX, so distributed graph processing framework. You have the machine learning lib as well, so that's so you can do machine learning, but there's your high-level view of Apache. Let's take a look here at resilient distributed data sets. So RDDs is a domain-specific language to execute various parallel operations on a Apache Spark cluster. So the idea is that we have these common RDD API functions like map, flat map, filter, distinct, reduce, count, first take, count by value, sort by, group by, and a bunch of others like min, max, whatever. And if you've seen these before, like if you've ever used other programming languages, like you saw min, max, and count, you have an idea of what these things are going to do. But again, these are to operate on quite a bit of data, right? So this is for like aggregating data or doing things with it. But let's take a look at an RDD API example. So there we are loading a text file, And from that text file, we are performing a flat map. And then we're also doing a map and a reduce by. So we're doing things with that text data, by processing it and getting a final result. And so that is something that you can do with these resilient distributed data sets. So there you go. So what is PySpark? It is a Python API for Apache Spark used in Databricks for fast scalable data processing. So the idea here is you have Apache Spark plus Python gives you PySpark. So built for distributed data processing on clusters, and it works with the DataFrames. So like Pandas, but it's scalable. It supports SQL and Python mixing. It's used for ETLs, data cleaning and analytics. It runs in Databricks notebooks for batch and streaming. And so on the right-hand side example, you can see that we're using PySpark and we're doing an SQL query. And so basically is, again, a library within Python for you to interact with Spark, with Apache Spark, okay? So within Databricks, you have a bunch of array functions that let you process nested or repeated values like array, structs, or common structures that you'd find with JSON data. So let's take a look at the array functions that we have. And the idea is that it's basically aggregating, iterating, doing things to massive amounts of data, okay? So let's take a look at key functions. So we have explode, which turns each element into a separate row. Flatten removes one level of nesting. Size counts elements in array. Array contains checks for a value. Sort array sorts elements in array. Element at, so gets the nth element. The use cases here would be to handle nested JSON data, normalize semi-structured sources, enable joins, filters, aggregations on individual array values. So there you go. Let's talk about deduping and validation logic within Databricks. So they allow you to do this with a couple of functions. So the first is full table deduplication. This will remove exact duplicate rows across all columns there. So we have a data frame, a Spark data frame, and we are dropping duplicates. We have column-based duplication, deduping, so it keeps only one row per unique value in a specified column, so we can drop our duplicates there. This is useful after merging data from multiple sources or ingesting from raw zones, often used when preparing silver or gold tables, which we explain later in the medallion architecture, and we'll see time and time again, but there you go. Let's take a look at timestamp and string functions within Databricks that are built into it. So the idea here, we have counterparts from timestamps. So breaks timestamps into components for analysis. Let's take a look here. So we can use Spark SQL. And here we have from sales, we just simply select each thing. This is no different than regular SQL, but if we want to do this in PySpark, what we would probably do is use the select command, and then we would, for our value there, we would say, I want the year, the month, and the day of the month. So that's a good example of breaking up a time. So within Databricks, we can match against regular expressions. So let's take a look at how we can do that. So with Spark SQL, we have the regular expression function there. And so within PySpark, you just would do a select. And then within there, you can do f.regex extract. So you can see that function is available in both. So hopefully you're starting to get the idea between how you can do something in Spark SQL and PySpark, but we'll continue on. Let's talk about dot syntax. This will let you access values from nested structures like structs or JSON columns in data frames or SQL. So here's an example where you have a select and you're saying address.city, address.zip. This is a pretty common dot notation for SQL, but notice that you can also do it in PySpark. So, again, this is nothing unusual if you are used to using SQL, but the fact that we're doing it in PySpark just to show that translates over, right? But yeah, we'll take a look here. So a struct in Spark is a complex column type that groups related fields, often used for nested or JSON data. And so the address field is a struct of two subfields with city and zip. But yeah, again, very straightforward, but just want to call that out explicitly. Let's make sure we understand the difference between explode and flatten, because they might seem similar, but they work differently. So explode breaks an array or map into multiple rows, one row per element. So the idea here is when you want to increase the number of rows, mainly when dealing with an array. So notice we have explode and we have A, B, C, and so the output is going to be A, B, and C. Flatten removes one level nesting from an array or struct, but does not generate new rows. So use when working with deeply nested structures like arrays within arrays, and you want to simplify the structure while keeping the row count the same. So flatten isn't available in standard Spark SQL. It's usually found in tools that extend Spark for XML JSON processing, but there you go. Let's take a look at count if versus count. So count if counts the number of rows where a given condition is true. So count if here, and then count is just a number based on whether it's null or not. So the reason I bring this up is that anybody that has used a count command in MySQL Postgres are probably aware of it. You're probably used to doing like this count asterisk or count true. But I just want to notice here, I just want to make more emphasis that you can do age is null, so you can figure out how many null values there. And I also just want to show the count if, where you can do a given conditional, okay? So just a little bit more flexibility than your standard count, but there you go. On the exam, I got at least one question about caching. I think it's specifically refresh table. But let's go through here and just make sure we understand the caching commands that we can get through Apache Spark. So we have the create table. This caches content of a table or output of a query with the given storage level in Apache Spark cache. If a query is cached, then a temp view is created for this query. This reduces scanning of the original files in the future queries. So we'll get the pen tool out here, right? And so you can see we say create table. We're creating our test cache with our options, and we're selecting the data as to what we want to put into the cache. Then we have clear cache. So this removes the entries and associated data from in-memory or disk cache, for all the cache tables and views in Apache Spark cache. So just very simply, clear cache to clear your cache. We have refresh cache. So invalidates and refreshes all cache data in Apache Spark, cache for all. Datasets that contains the given data source path matching by a prefix or whatever. So says invalidates and refreshes all the cache data. Okay, so here we have refresh resource path. So down below, we're targeting a very specific thing that we want to refresh. On the exam, I only got one caching question, but I figured we should just run through these just in case you want to score 1 point here. Let's talk about caching and specifically Apache Spark cache statements. So here we have create cache contents. So I'm just getting my pen tool out here. The idea here is we're going to create a table. And from here, we'll select the data that we want to be named as the cache information. Pretty straightforward. We have clear cache, as the name implies, it clears the cache. We have refresh cache, so this invalidates and refreshes all cache data and associated metadata for a cache. And so here you can see we're refreshing a very specific location or resource. So we have refresh function. So this invalidates the cache function entry for Apache Spark, which includes a class name and resource location of the given function. Note that refresh function only works for permanent functions. So here we can see that we are refreshing that function. We have refresh table, so invalidates the cache entries for an Apache Spark cache. This is actually, I think, the question I got on my exam. But the idea here is that we're going to invalidate cache is populated in a lazy manner when the cache table or query associated with it is executed again. So here we are clearing it. Okay. We have uncached table, so removes the entries and associated data from the in-memory or on-disk cache for a given table or view in the Apache cache, Spark cache. But anyway, my point is that we have all these statements here. The idea is to get some exposure so that when you see a list of possible statements on your exam, you can choose the appropriate one. Okay. Let's take a look here at what is a table in Databricks. So it is a structured data set stored in catalog and schema, accessed by the 3-level namespace. The default table in Databricks is the Unity Catalog Managed table. And so here's just kind of an example where you have table data. And so you have the metadata registered in the Unity catalog, so that's how it knows about it. Or, we could have it over at cloud storage. So that's just explaining what that table is. What are Delta tables? So Delta tables are Databricks default table format combining cloud storage with ACID-compliant transaction logs for reliable, scalable analytics. Data is stored in the Delta log format. Operations tracked in transaction logs. Every change is a new version. Enables time travel to view or restore previous versions or data. The reason I'm skimming over this is because we're going to cover this again in better detail. So I'm just trying to give you a quick overview, and then we'll look at it again in granular detail. The common table types is managed, unmanaged, and external, and there are differences between these. And we will cover these again later on. So that's why I'm not going through it, but you can just see some information here. We'll cover when we go to Unity catalog table. I'll cover it in greater detail. Let's take a look at Delta table operations. And by the way, we've covered this once and twice and now a third time in the course. So if you feel like we've talked about this, it's intentional because I'm trying to help it stick in your mind in different ways for the exam. So let's take a look at Delta table operations. So we have the merge into, okay? The purpose of this is for upserts, insert, update, delete based on match. We have update, delete. This is to modify data in place. We have the vacuum SQL command. This is to clean up old files. We have describe history. This is to view version logs. We have to optimize to compact small files. We have Z order to improve read performance with sorted indexing. So yes, I'm going to repeat again and again so that when you do your exam, you're going to be in good shape. Okay. Let's take a look at creating a table from external sources. So Databricks supports ingesting data directly from external files and databases to create tables for analysis. So let's talk about how we would do this from CVS files. So you can read data from CSV files stored in cloud storage. And so here's an example where we create a table using a CSV and we're providing it the location for that data. Here's an example also using PySpark, where if you notice we have .csv, and we are going to write that to our table. Okay, so the use case here is to quickly ingest raw flat files into your lakehouse for analysis. Then we can use the JDBC, which is a Java database something connector. I forget what the B stands for, but it is a library in Java to connect stuff. Very common when working in big data here. You can read data from a CSV file stored in cloud storage. So here's an example with PySpark. Notice that we're using the JDBC address format. And then down below you have spark.read.jbdc, and then you're able to write it to the table. So similar process to the other one, but we're able to use a JDBC connection, okay? This will bring in structured data from enterprise systems into Databricks. So there you go. Let's take a look here at external tables. So an external table is a table in Databricks that points to data stored outside the system, like S3 or ADLS. That's Azure Data Lake, if you're not familiar with it, service, instead of storing the data itself. So here is kind of a diagram where we have Databricks with its relational table structure. And then on the exterior, you can see the cloud storage. So it uses location to know where the data lives. You must have permission to access that storage. You can also access it through a storage credential or external location. We do a lab on this. I might have more than one, but we definitely have a failed lab. But the reason I left it in was because we learned so much during it. So if you encounter a lab that seems long and looking at a lot of stuff, I left it in there for that specific reason. But we'll cover this again later. Let's take a look here, working with views in Databricks. So views let you reference the results of a query without creating a physical table. They're useful for breaking down complex logic or reusing query results. So let's talk about temporary views. So they're only visible within the current notebook session. We're using query results without saving them permanently. So that's why you'd use a temporary view. And here you can see we have create or replace temp view. I'll get my pen out here so it's very, very clear. We have temp view here. Okay, and then you are putting the data in for that temporary view. We have global temporary views. These are accessible across all notebooks and sessions with the prefix global temp. and sharing temporary data across notebooks would be our use case. So notice here, we just have the word global in front of it. And so now we can query it and use the namespace, top level namespace, global temp to access that data. So there you go. So we can create a table from an existing select. We know this as CTAS. Why would we want to do this? Well, it's efficient ways to create a table from a query. It will inherit the schema from the select. It can be used to snapshot or pre-aggregate data. So here's an example where we use the create table command, but notice we have as, and then the next line is going to create data from that select statement. So there you go. Let's take a look at here for generated columns, which will automatically compute values based on other columns in a table. Used for storing derived and calculated values. And we have two types. We have virtual for computed on read and stored computed on write. Helps simplify queries and enforce consistency. So here we have create tables user, and notice we have birthday date, and then we have age, int, generated always as, and then we're telling it what we want it to be. And then we mark it as stored. And so the idea here is that the data will then get interpreted dynamically from another column, because if I get my pen tool out here for just a moment, if it's not clear, see how we have birthday here? Okay, then we go over here, and then it's getting it from there. So this is where it's sharing the value from another field, okay? So there you go. Let's take a look at adding table columns, or columns, comments. Comments help document tables, columns, and their purposes for future reference. Useful for tracking intent and metadata. Helps with governance and team collaboration. Can be added at creation or afterwards. So here we have a create table of transactions with some data in here, so you have an idea. But what we can do is create a comment on the table and say exactly what this is for. So stores financial data transactions by ID. Okay, and so in the Catalog Explorer under Transactions table, you'll now see that common information, so you can access it later. So there you go. All right, let's take a look here at DML statements. So data manipulation statements, or DML, are used to add, change, or delete data from Delta Lake tables. And so these are the commands that we have here. I kind of just treat insert overwrite as one here, but let's just walk through these. I'm not saying that we need to know all of these, but let's at least look at them so that, you know, we have some exposure to it. And what we really need to know is what we'll do in the hands-on labs, and that will be what will appear on the exam, okay? So let's take a look here at our first one. So copy into, loads data from a file location in a Delta table. So there's the definition, and here's an example of us loading data from an S3 bucket, and we're specifying the file format that we're expecting it to be, whether it has headers, whether it should merge the schema. So pretty straightforward. Let's take a look at delete from. So deletes the rows that match a predicate. When no predicate is provided, deletes all rows. And this is only supported via Delta Lake tables. So there is the structure of it. And here's some examples where we're deleting events. So pretty straightforward. It's the delete from statement. And then we have insert into. So inserts new rows into a table and optionally truncates the table or partitions. You specify the inserted rows by values, expressions, or the results of the query. So Databricks does not insert for Hive Avro tables if the timestamp middle types is present in the table schema. Here's the definition. Here's an example of doing insert to. If you ever done insert to in MySQL or Postgres, looks the same. We have insert overwrite. So overwrites the existing data in the directory with the new values using a given Spark file format. You specify the inserted row by value expressions or results of query. So there's the definition. Here's an example of us inserting with overwrite, and we're specifying a specific directory. We're telling it we're using Parquet. You know, pretty straightforward, okay? And then we're selecting what data it is that we're going to overwrite with, okay? We have load data. This is specifically for loading into Hive serialization, deserialization tables using a user-specified directory or file. This is not the best example, but because I'd really have to work hard to give you a good one, but the idea here is we're loading from the in-path data at the current location. There's a lot more SQL to make this clear, so it's not a big deal, but if we do use it, it'll make sense. Merge into, so merge is a set of updates, insertions, deletions based on source table into the target Delta table. It's only supported for Delta Lake. There's our definition. So here we have merge into target using source. We're matching information there. Not the most practical example, but you get it. Again, the stuff that we're going to need to know is the stuff that we will do in the lab. So do not stress out. Again, I'm just trying to get you exposure to as many of these SQL commands. Just in case they do appear on your exam, okay? Let's talk about SQL Commands and Logic. So SQL and Databricks supports a wide range of data manipulation and transformation operations essential for analytics and ETL workloads. So I'm not going to fully cover these in detail right now because in some areas we do cover them, but a lot of these are just common SQL commands that you should just generally know. So we have insert, update, delete, merge, and drop. So those are all pretty standard ones. Modify data or structure in the Delta tables. We have case when. So this adds conditional logic to queries. Something we see in Postgres. I'm not sure if MySQL has it, but a common one we see. Pivot and unpivot. This one you might not. I think this is an MS SQL, but I could be wrong. The idea here is to transfer data between long and wide formats for better analysis. We have joins, which basically is in all SQL variants. So we have inner, left, join, full joins, but there's also semi-join, returns rows from the left table where match exists in the right. We have anti-join, returns rows from the left table where no matches exist in the right, okay? Let us take a look at pivot clauses. So this reshapes data by turning unique row values into column headers, summarizing value across them, ideal for reporting analytics. If you've ever used Excel and made a pivot table, you know what you're looking at here. So imagine you have this tabular data and you want to turn it into basically the summary where we're grouping all A's and B's, and then we can get a count between the January and February. So we're basically transforming into a different table. We're pivoting into a different structure, right? So here on the right-hand side, we're selecting our data, and then we provide the pivot command or SQL statement. And so we can sum the value and tell how we want it. So each unique value in month becomes a column. Sum sales is calculated per product. Extremely powerful feature, but there. Let's take a look at the case expression in Spark SQL, which provides conditional logic or drive decisions based on control flows with queries. If you've ever used case when in Postgres, then you know what you're looking at here. Acts like an if-else block in SQL. There might be some variants of SQL that have if-else. I can't remember because I work in Postgres so much. Maybe MySQL has it, maybe it doesn't, maybe it only has case when. But when you can't do if-else, you're usually using case when, because it's your only option. So useful for data categorization, labeling, or applying conditional transformations. Works in both select, where, and order by clauses. Let's take a look at an example. So here we have our customer ID, total spent, but notice when we want to say what our customer tier is, we can do conditionals to return high value, medium, or low value. And if you want an if else, you just have a case when true for a value and then give it an else, and you can simulate your if else. In Spark SQL, we have a lot of types of joins we can use. I'm not going to show you how to do all of them. We'll definitely show you how to do left joins, as those are the most important. But let's make sure we understand why there's different types of joins and what we can use them for. So let's go through it. So the first is an inner join. This is going to match rows based on both tables. So an example here, we're getting customers with transactions, okay? Left join, all left rows matching right rows, retains all products even if unsold would be an example. Right join, all right rows matching left rows, so it's the other way. Keeps all rows even if unassigned would be an example. Full join, so all rows from both tables with nulls or no matches. So you can end up with empty values when there's nothing there. But when you need all the data, that's a really good option. Semi-join, so left rows with a match in the right. And so that's a little bit more conditional. Anti-join, so left rows with no matches in the right. We have a cross join, so all combinations as a Cartesian product. I rarely ever use this, but that's an example that you could use it for. But hopefully that gives you an idea at a high level. All right, so here I have an example of a left join because you need to know how to do left join. So imagine you have a table called orders and you have a table called payments, and you want to join that data. So you have the order ID information, which would be here, the customer name, which is under ID for whatever reason. I'm not sure why it's like that, but that's fine. And then the amount, which is over here, okay? So we're bringing all that data together. So let me just erase everything here. So we can get back to writing. So notice here on the query here, we have an orders and a payments table. So we say from orders. So this is what we are getting from. And then our left join is going to be payments over here. Okay. And so for orders, order ID, we can grab that and put it over here. And then for the orders.customer name, we can get it. This, I think, is just a mistake. It's supposed to say name. That makes more sense. Okay. And so we can grab it here. But the interesting part is the fact that we can go payments.amount. So it's going to automatically match the order ID here to here. Okay. And then we're able to get that data. So that's the most basic way to do a left join. Something you have to do when you're doing a left join. This is actually supposed to be one line. Let me clear this out one more time. But see this line here? It says left join payments. Left join payments. It's actually left join payments on orders.order.id payments.order.id. So often you'll see like a bunch of left-hand statements, and that's on line will be on the same line, just so it makes it easier. But it's telling you the order ID needs to match the payments order ID so that it knows how to get the data. But there you go. All right, let's take a look at describe statements for Databricks SQL. So describe statements provide information about a database component. And you can see we have ones for catalog, collection, credentials, database, function, location, procedure, provider, query, recipient, schema, share, table, and volume. On your exam, they might ask you things like, if you are trying to find the location of some kind of data, what describe command can you use? So even though describe command seems, not a good use of time, it is actually a good use of time for us to go through and make sure that we understand what we can get back from a describe statement, because your exam might have questions specifically pertaining to it. So let's take a look at all the describe statements. The first is describe catalog. So this returns the metadata of an existing catalog. The metadata information includes the catalog name, comment, and owner. If the optional extended option is specified, it returns the basic metadata information along with other catalog properties. So here are two examples. I'm going to get my pen tool out here just so we can see very clearly. But here we are saying describe the catalog called main. We get the catalog name, the comment, the owner, and the catalog type being regular. If you look over here, we're doing the same thing with extended. So not only do we get the catalog name and the catalog type, but notice down below we get additional things like created by, created at, created, updated, created at. I'm not sure why it's not showing up here on the right-hand side, but you would see that additional data there, okay? We have describe connection. So this returns the metadata of an existing connection. The metadata information includes connection name, comment, owner, and select options. So here we are saying, tell us about the connection called PostgreSQL connection, and it's telling us the credentials, the URL, the owner, the created at, created by, comments, options, and so there. Let's take a look at describe credentials. Returns the metadata of an existing credential. The metadata information includes credential name, comment, owner, and metadata. So here we're saying get us the good cred. We can see the name, the owner, created at, and the credential, like where it's being linked to. So there we go. Let's continue on. We have describe schema or describe database. Remember earlier I said think of schema as a database. They basically allow you to use either one or the other. The one is alias as the other. They do want you to use schema, but you can use one or the other. So returns the metadata of an existing schema. Let's take a look at what data gets returned. I noticed that there is an extended version, and we're just showing the extended version here to show you. So we have the employee, the database name is employees, the description, the location of the database, and some additional properties. I think there's a lot more. There might be more in here, so you might want to check the documentation, but for the most part, this is all we need to know. Let's look at describe function. This is going to return data about an existing function, so pretty straightforward. So here we're saying describe the function extended ABS. So we have its name, its class, so like where is this function actually coming from, and then how to use it if you do the extended one. If you don't have extended, it just wouldn't provide the example. So there are functions you want to use or learn about, then you can use that function to find out about them. We have describe location. This is going to return the metadata of an existing external location. So here we're saying describe the external location, best location, and here it's showing the name, where it's stored, the credential name and owner. This was an exam question I got, so absolutely knowing that if you use location, it'll show you where it is. I would definitely try to remember this one for sure. Describe procedure. I think this is in preview right now at the time I'm recording it. It's going to show you a procedure. Procedures are kind of like functions, but they're like a block of SQL that can do more complex stuff. That probably won't be on your exam, but it's definitely something you should know. Describe provider, so returns the metadata of a Delta sharing provider. So here we say, tell us about the other provider. It's saying the authentication type, and where it is, like cloud, like is it in Azure? Where's the location, and what is its metastore ID? Let's take a look here at describe query. So returns the metadata of an output of a query. So the idea here is that you're going to say describe the query and then provide the query. Okay, and so then you're going to get information of the output of the query, like what the format would be, right? Not necessarily the data, but like what should you expect to get back? We have describe recipient, so returns the metadata of an existing recipient. So the metadata information includes recipient name and activation link. So here we have a recipient, and we can see the authentication type. We can see the owner, and I mean that's pretty much all we need to see here. So okay. So let's go take a look here. Describe share. So returns the metadata of an existing share. The metadata information includes share name, owner, timestamps, et cetera, et cetera. So here we have a share, and there's that basic information. We have describe table. So this one can be very useful. This one I think has a lot of options, a lot of options. But for the most part, we'll look at extended. So the idea is like we want to know about a table. And here we can see its columns, which is really useful. And then we have our more detailed information. So like you might want to make note of the location that if you use this, you can find the location of the table, because there might be a question. I think I might have had a question like, how do you know where the table is located, right? And so this would be one that you might want to have. And then the last one here is return the metadata of an existing volume. Okay, and so here we have an external and a managed one. And so you can see here it's storage location. So here it says external, and this one is managed. So even though this is managed, we can still see where it's going. Okay, but there you go. Okay, ciao, ciao. Let's talk about UDFs, user-defined functions. And so in Databricks, you are able to create your own user-defined functions so that you can have custom logic within SQL. They're useful for ad hoc queries, complex transformations, and small to medium data sets. I often use it when I have a first name, last name. I want to join them together nice and cleanly. That might be an example of one. Use UDFs for complex logic, string parsing, custom business rules. So here's an example of us creating a function. So we have the create function command. And so we're creating one called hash email, and it's going to take a parameter of email string. It's going to return the string as SHA-2. So it's going to hash it, okay? So that it's not encryption, but it's hashing it. So it's going to hash that there. And so the example is now we can do hash email and get it back as a hash. So it's there. You can see that it's being stored on the catalog.schema. So that's where it is. I can't remember if it's catalog.schema or uccatalog.schema. We do have a bit of an inconsistency here. It's not a big deal about this, but in practice, if we do this, I will correct that. But the point is what you need to know is that 3-level namespace, right? So we have those 3 things, and this is where it's being applied. But let's talk about handling files in Databricks. So Databricks can read data from either a single file or an entire directory, depending on your path provided. So here's an example of reading from a single file. And then on the right-hand side, this is us reading all files. So we have a /. There's no wildcard. It's just / to read the directory. This is useful when reading a directory is useful for processing, daily, weekly data drops, partition data sets, event logs, or time series batching. So there you go. Let's take a look at file format prefixes in Databricks. So you can query files directly by specifying the format as a prefix after from. This tells Spark how to read the data. So common free prefixes that we have is Parquet files, CVS files, JSON files, and data files. So here's an example above of us interpreting that data for Parquets. Okay, so it will use the Parquet format, and the backticks enclose the file path. I think it's important that we know the difference between a Parquet and a CSV file. There's lots of file formats, but these two we should compare. So Parquet is a column or storage format. It's efficient for large-scale analytics, supports schema and data types, highly compressed as small files, fast reads for specific columns, supported nested structures used in big data systems. On the CSV side, it's row-based, simple, human readable, no schema, larger size and no built-in compression, slower on queries, must full scan, flat structure only, common Excel, and simple data exchange. When you can use Parquets at scale, use them. When you need convenience, use CSV. All right, so when you are using structured streaming, you might want to know about when things will get triggered, okay? And so there's two options. We have available now and we have processing time. So available now, the idea here is that it will run once all available data becomes present, and then it will stop. This is really good if you are doing batch-like jobs or autoloader. So we have .trigger available now equals true. And then for processing time, the idea here is that it runs repeatedly at a fixed interval. And this is great if you got data constantly flowing when you're using structured streaming. But let's take a look here at watermarking and late data handling. So in streaming, data can arrive late or out of order. Watermarking tells Spark how long to wait for late data before finalizing a window. So what exactly is watermarking? Defines a threshold for an event time delay. Spark drops late records that arrive after the watermark. So here we have with watermark setting that event time to 10 minutes. This means Spark will wait up to 10 minutes for the late events based on the event time. It prevents unbounded state growth in windowed aggregation, balances accuracy and resource usage. An example here would be a group by, and then we specify that window with the aggregate, and then we have our with watermark information there. So the idea here is that it will process data in 5-minute windows. The late event within 10 minutes are included, and later than that, it's going to just discard, okay? Let's take a look at some output modes in streaming. So Spark supports 3 different modes based on what you want. First is append. So only new rows are written, used when no updates to existing rows. So here you can see append. It's great for logs, events, and insert onlys. We have update, writes only updated rows, requires query to have a unique key or state. Best for rolling counts or running totals. We have complete, outputs entire result table each time. And this is great for full aggregation. So those are your 3 examples. Let's make sure we know the difference between triggered versus continuous pipelines. So we'll look at features here on the left-hand side and go through them. So for triggered and continuous under execution mode, for triggered, it runs in micro batches on schedule. For continuous, it runs continuously as data arrives. For latency, for triggered, it's higher, depends on the trigger interval. For continuous, it's lower near real time because it's continuous data. Triggered is more cost effective because it runs more infrequently, but continuous, because it's constant, it's going to cost you more. Triggered is great for batch jobs, periodic reports, where continuous is for real-time dashboards and alerts. Triggered, the idea here is that you're starting and stopping compute, whereas continuous, it's always running compute, so that's going to cost you money. For triggered, it has the available now and processing time, as we saw, but continuous has no triggers, and it's always running. So use triggered for scheduled, cost-conscious workloads. Use continuous for low-level, real-time latency needs. Hey, this is Andrew Brown. Let's take a look here at Autoloader, which automatically ingests new files from cloud storage with no manual tracking. So it uses cloud file sources or source in structured streaming to ingest new cloud files incrementally with support for schema evolution, multiple formats, and massive scale. So imagine you have your cloud storage, AWS S3, Google Cloud Storage, whichever one you want to use, and you create new files in there. Autoloader is going to load them into Databricks. Okay, pretty straightforward. And it's best used if you have large and continuously updating data sources for obvious reasons. Let's talk about key features. So it auto-detects and ingests new and existing file types like CSVs, JSON, Parquet, Avro, and more. Supports AWS S3, Azure Data Lake Storage, Google Cloud Storage, Azure Blob, Databricks file storage. It handles schema drift and evolution. It stores state in RocksDB checkpoints for exactly one processing. It integrates with DLT for production-grade pipelines. It has 2 modes, directory listing and file notification, which we will talk about here shortly. It uses cloud files in structured streaming to read new CSV files from the cloud storage incrementally. So there on the left-hand side, you can see that format for cloud files, and we will see that more when we actually dive into a lab. Autoloaders beats read streams with scalable ingestion, auto-skimming handling, and lower cost file detection. So consider using autoloader over just using your standard old read stream. Let's compare the two modes. We have directory listing, which is the default mode, and file notification. So on directory listing side, it scans the directories to discover new files, whereas file notifications uses cloud native event services to detect file changes. Directory listing is simple setup and no external dependencies, where file notification is faster and more cost effective at scale. For directory listing, we have slower for larger directories, where it's supposed to go over the other one. I think it's just out of order, but we'll come back to that one here in a second. For directory listing, it uses directory listings for quick and easy setup. And for file notification, we can choose file notifications for large-scale ingestions with better performance and lower cost. Going back up one step, so for directory listing, it's slower for large directories. For file notification, it requires additional setup. Let's talk about the autoloader schema interface limitations. So by default, autoloader may infer all fields as string, especially from formats like JSON, which don't enforce strict typing. So here's an example where we have our structure. Autoloader might infer that as string, string, string. So even if price should be a float and in stock should be Boolean, it will be a string. So what do we do in this case? We provide explicit schema using schema or schema location, or enable infer column types option if it's supported. So there's an example of turning it on. This is going to ensure correct types are used and avoids downstream issues with transformations or validations. So there you go. Hey, this is Andrew Brown. In this video, we're going to try to figure out how to get data from Amazon S3 into Databricks by using autoloader. It also seems to suggest that Unity catalog might be something that we'll incorporate. So we'll use this as our guide and try to work through it. I'll just have it off screen here. If we need to pull up, we'll work through it. Sometimes I find, for the most part, not all of these work, and so we might have a detour, but I think it might work. Also, I wonder if we switch here, could it tell us for GCP? Oh, it does. That's cool. We can switch over to like Google Cloud Storage or AWS here or SAP, but we'll stick with AWS for now here, okay? So here it's suggesting, okay, we'll go create a cluster, make a runtime, and then make a notebook. So I'm just going to go ahead and create ourselves a new notebook. This one, and actually I'll name it this time. Last time I didn't name my notebook. This one will just be like load data S3. Okay, so we have that there. It's going to suggest us to use a cluster. We already have our serverless one, so I'll go ahead and connect it. Here it literally tells us to make a new cluster. We're not doing that. We'll try to use the serverless one here. We're going to drop it down to use the SQL language. And so here it says, change the default language to render without a Python. That's totally fine. I don't care. And so now we are in SQL mode. And so here, actually they have both in SQL and Python. But we'll go ahead here, and here we need to put our path to our source data. Now, I think our source data is an S3 bucket address. I think that's what it is, because if we were to go back over to here and look up autoloader, Databricks, I'm pretty certain, yeah, it's showing that address, right? So replace path to source data with the path to the directory that contains your data. Okay. To view a sample of the records, better understand the content of each thing. So is this before we uploaded or before? Let me go figure this out. 1 second, okay? So yeah, here it's suggesting external location path as a bucket. The thing is, like, how is it going to get permissions to S3? Because right now I'm in the Databricks Intelligence Platform, and I'm not running this in AWS. Do I have to go launch that there first? Is there another way to get permissions? So I'm expecting this to fail because I haven't connected AWS anyway. I am logged into my AWS account, so we can go ahead here and give that a go. So I'm going to go over to my account, over into here, and I'll go here to S3. I'm going to create myself a new bucket. So I got a bunch of buckets I need to delete. This is my developer account, so all those buckets can go. I'm going to call this Databricks autoloader and just put some numbers here on the end. I'm trying not to do 1, 2, 3, 4. It seems like all the numbers ever do. We'll go all the way down the ground. We'll hit create bucket, because how would it access this bucket? We would have to update our policy, do something there. But I'm going to go over to Databricks. And so now we are into autoload, and we're going to need some kind of data structure here. I'm going to go over to Claude. I'm going to say, give me a JSON lines file. Well, does it support JSON lines or just JSON? So that's something we'll have to go back and double check. So if we go here, it should tell us JSON, CVS, etc. So I'll just say, generate. I am using autoloader for Databricks. I need to generate a JSON file to test for loading. Okay, so we'll go ahead and do that. But again, it doesn't say whether it's JSON lines here, because that's what I would expect it to be, would be JSON lines, but it just says JSON. But anyway, we're getting data here. We'll give it a try. So whatever data it wants to produce, go ahead and grab it. I'm going to copy this, get data however you got to get data. And I'm going to go back over to Visual Studio Code, just so I have somewhere to save it for a moment. I'm going to go here and make a new text file. I'm going to drop in this file here. So now I have this here. We'll go ahead and save it. Sure, we'll just go example data. Okay, so that is now saved. I'm going to upload that to S3. I'm going to reveal that in my Explorer if I can find it here. I'm just right-clicking here, reveal in Explorer. There we go. And what I'm going to do is go over to here, and I'm just dragging that onto here to upload that file. But again, I'm expecting a permissions issue. So here we have the file. That's our destination. Let's go back over to here. Probably should put it in a folder, but it's not going to matter, but it's probably like good to put things in a folder. That we want to go back over to our autoloader one here. Where did it go? We have it here. Okay, so here it's saying list and then the source path. So we'll go ahead and try that. And my expectation is that's not going to work, because how would it work? It doesn't have permission. So we'll go ahead and run that. Okay. And I'm expecting that to fail. So there obviously has to be some way to connect this with AWS. I'm going to go over here to another tab and see if there's any options here. Sometimes over here there might be something for access to cloud providers, but I'm not seeing that there. We'll go back over to this tab, and here it says no such file found. That totally makes sense. Let's try the diagnostic error and see if it makes any suggestions here. And this obviously has some kind of AI here, but that's not going to be helpful. Like, look, how I'm trying to list an S3 bucket, but I haven't connected AWS in any way. How do I do that? Does it even know? How would it know that? Ensure that your Databricks workspace has the necessary IAM roles and policies to access S3 bucket. You configure the credentials using the IAM roles or same with the access key. Once the credentials are configured, you can use DBS util. Really wants to use DBS util here. Ensure your Databricks workspace has the necessary IAM rules. So we are in this workspace here. There must be an option to configure it here. I don't know. Give me a moment and let me see if I can figure it out, okay? All right, so it's suggesting that we need to use Unity Catalog as a means to connect. And so over here, we have those instructions. Let me give it a read and see how to do that, okay? So interestingly, we have a lot of requirements here. They suggest to keep it in the same region. Do not use dot notation when you have your bucket. It's not telling us how do we create it as of yet. But again, I'll just continue to read here and then just speed us through it, okay? All right, so let's go ahead and create an IAM role with a custom trust policy. So I'm going to go back over to here. We obviously have our bucket, but we'll just make a new tab. I'm going to go over to IAM, and we'll go ahead and what are we creating? A policy? A policy, right? A policy. Yeah, it's a custom policy. So we'll go over here. We'll create ourselves a policy. I think we just go over here right away. We don't have to fiddle around with any of that stuff. And we'll go ahead and copy this. And we'll paste this in and we'll take a look here. So we have a principal. If you don't know what a principal is, that's what you're saying is going to be given access. And here we're specifying a specific AWS account. So this must be Databricks. And they're saying allow the role of Unity Catalog to be able to assume a role. And then here we have this external ID. I'm not sure if we need that. The question is, why are we getting some errors here? As this template looks okay to me, but we'll go down below, add a resource or not resource element to the policy statement. I guess the thing is that it's saying that this is the trust policy. So I'm wondering if this is the right place. Let's go back a step. Okay. This is creating a policy, but like normally when you create a role, let's go take a look at a role for a second. Here it is. Okay, custom trust policy. There it is. Okay. It's actually supposed to go here. Now, generally, an external ID is used in AWS to match against another account. So they'll have an ID and you'll match that ID. So I'm imagining that they probably want us to do that here as well. I have a few too many tabs open, so I'm just going to close a couple so that we have a bit of focus here. Okay. And there must be something about the external ID. So the policy sets the external ID to 000 as placeholder. You'll update this to the external ID of your storage credentials in a later step. Oh, okay. Later. All right, that's fine. Skip the permission policy configuration. You'll go back to this step later. What? So create an IAM role with custom policy. Okay. The policy establishes across whatever. That's fine. Okay, so skip the permission policy. So we'll go ahead here. We'll hit next. And next, I didn't realize you could skip the permission policy. Do they want this to have a very specific name? Save the IAM role as what? This will be, I guess, Databricks policy. What's it called? Databricks policy, access policy. Allow Databricks platform to assume a role. So it seems like this role is incomplete. We'll go ahead and create that. I don't know if they said policy, not role, but that's fine. So create the, like earlier, here it says it's a role now. Create the following IAM policy in the same account as the S3 bucket, replacing the following values. So why wouldn't we just create the policy first and then attach the role? But whatever, that's fine. The name of the bucket, the KMS key if you have it. So we do have a bucket, so your name is going to be different than mine. I'm going to go ahead and copy that. We'll go back over to IAM. We're going to go ahead and create a policy. I'm just going to paste this over here so I do not lose it. And create the following IAM policy in the same account. Oh, here it is. Okay. So I'm going to go ahead and copy this. We'll go over to our JSON. We'll paste this in here. It's giving get, put, delete, list, get bucket list, or a bunch of other stuff. And so then here we have very specific things. So I'm thinking we got to put our bucket name here. We'll go over to here and copy this. Okay. And then we'll also do it over here. Good. It has KMS key. I don't think we set a KMS key on this. Pretty sure we didn't. Let's go over to our permissions. And maybe properties, encryption. Yeah, we're not using KMS. We're just using SSC S3. So we'll go here. We'll just remove that as we do not need this statement here. Okay, and so now we have the account ID and the AWS IAM role. I'm assuming this is from the other one. Let's go back over here for a second. It's like who should have access to it, right? And I would imagine they want Databricks to have access. So here it says the account ID of your AWS account, not your Databricks one. Oh, okay. The name of the IAM role. Oh, okay, that makes sense. All right, so I'm going to go up here at the top, grab my account ID, and we'll go back over to here. They really should have in this tutorial like been explicit and say, hey, name the role exactly this. I already forgot what the role is, so I'll go ahead here and open up the new tab. It's like Databricks Access, but I don't want to get it wrong. It's always best to copy paste just so that things work. We'll type in Databricks Access. I wrote policy. It's really a role here, but we're not going to rename it. We'll just live with our mistakes here. It's not a big deal. And that is over here. And so we'll go ahead and place the role as such. We'll go back over to here, wherever we were. So the IAM policy grants read and write access. Good. However, this may be unnecessary because you can mark the storage credentials as read-only and write access granted by an IAM role can be ignored. Okay, that's fine. Sure. So I'm going to go back over to here and hit next. Databricks access S3 buckets. Bucket policy. So this one actually is a policy. I'm going to copy this name here so I don't have to go find it later. Put it right there. And we'll go ahead and create that. So now we have that policy. This is going to be our bucket policy. Create an IAM policy that for the file events in the same account. Well, hold on. What are we doing with this one? This IAM policy grants read and write access. You can create a policy that grants read access only. No, that's okay. But don't we have to attach this to something? Okay. So we'll go down below here, create an IAM policy for the file events in the same account. So now we're just creating another policy. Sure. So we'll go ahead and we'll copy this one. Create another policy here. We'll go to JSON. And we obviously have our bucket name somewhere in here. Where's our bucket? Right there. So we're going to go back over to here. We'll grab this bucket name. We'll go on back. What a lot of work just to get this connected, eh? So that one is set. The rest of the stuff looks like wildcards, so I do not think we need to fill it in. Let's go back over to here. Replace bucket, and we did that. Attach the IAM policies to the IAM role. Okay, so, but this will be called Databricks Access. Was it like file store? What was this for? File events. Okay, sure. So we'll go down here. This will be file events policy. We'll copy that name as well. I'm going to go ahead and create that one. Use alphanumeric what? Just take off the end there. Maybe it's just too long. Is there space in the front? Okay, that's what I thought. I'll put policy back in there just because I named the other one as policy, even though it's probably redundant to name it policy like that. I'm going to go back over to here and we'll paste that there. And so now it's suggesting to go back to the original role and attach them. Let's make sure that is the case. Attach the IAM policies to the IAM role. Okay, sure. So we'll go back over to our role, which is here. And really, I don't think there's any reason we couldn't have created those policies at first and then did it, but that's totally fine. So we'll attach those policies. We'll say Databricks. There's our two policies that it wants us to attach. We'll add those permissions. So now they have been added. Give Databricks the IAM role detail. So in Databricks log into the workspace that is linked to the Unity catalog metastore. How would I know that? So click catalog. Okay, so we'll go over to here. Oh, it's over here. Okay, so this is Unity catalog. It just says catalog. Okay, so that is step one. On the quick access page, click external data button and go to the credentials. There it is. Credentials. Create credentials. Ah, so there we go. So we have storage credential and service credential. I mean, we're trying to deal with storage, so I'm assuming that's what we want. It's interesting, this copy from instance profile. That's usually talking about a compute instance, but obviously we're not doing that right now. Credential name, I guess whatever we want to call it. So just be like AWS developers exam pro. And then here it wants the IAM role ARN. So I'll go back over to here. We'll grab the ARN from there. That's on the role page. We'll paste that in. We'll look at advanced options. Here we can limit it. I don't need to do that. And so we have created it. I'm going to assume that was what the REST instructions wanted us to do because it's pretty straightforward. Yeah, it was already set to that. You can set it to read only. In the storage credential created dialog, copy the external ID. Okay, so there's our external ID. So we're going to copy that external ID. We're going to go back over to here. We're going to edit. Oh, no, maybe not that. It's the trust relationship that we need to edit. So we'll go edit that. We'll paste it in there. Let's just make sure there's no like prefix we got to put in here. Bind the storage credential to the specific workplace. Optional. I'm not sure what that is. Update the IAM role. So here it's just suggesting to do that. Edit the trust relation policy to look like the following. So now we have this, but then we also have that. So why did we do, well, whatever. So we'll do this again. Because if you go here, I mean, it's fine. It's just, I'm just wondering why. And so this one is the same. So this one's the same, and we'll grab our external ID here. We'll take this, we'll remove this part. And so we need to bring in our AWS account ID. So we should already have it. No, actually we don't have it here, but we'll go to the top. We'll grab it, paste this in. And I guess we're permitting ourselves to be able to do it because it's literally the same role here. It's just strange because it's the same role, but I guess you can do that. And we should be all set up. We'll go ahead and update that policy. So now our trust relationship is updated. Let's go back over to here. Validate the storage credential. So after you have made the changes to the IAM policy, in step 3, verify that your IAM role is properly configured. To validate the configuration, you must be the storage credential owner. I am, because I made the account. A metastore admin. I must be, because I created the account. Or you have create external location. Didn't do that, but it should work. So here it says click catalog. On the quick access page, external data, go to credentials tab. As an alternative, go to the gear, select the storage credential you want to validate configuration. Oh, okay, cool. There's a validate button. So I feel like it's right here. There it is. We'll click that. Success. So we are now connected via Unity catalog. So that's great. So I'm not sure about the rest of this, but we want to get back on track to what we were doing, which was working with the autoloader. So I'm going to back out here for a second. And I should have the tab here. This was for connecting to, here, create a credential storage, create a storage to S3. I mean, specifically it's for autoloader. Maybe it's over here. Nope. So that's fine. We'll just go ahead and type Databricks autoloader S3. Okay, so we'll go back over to here. And then on the left-hand side, onboard data from S3. That's what we were doing here. So now that we're here, this is what we were working through. And so we should be able to list the source. And so I imagine that now our account should know about it. The question is like, does a workspace have to be enabled for catalog, Unity catalog? Because that was something else that kind of suggested like, hey, is your workspace, whatever. But isn't this whole thing our workspace? I don't know. So let's go back into the file we were using, wherever it was. It's here, okay? And we're still connected. Let's go ahead and try this again and see what happens. Because there might be something else we need to configure, but it looks like it's working. Right? I don't think the other one was doing this. I don't think it had like statement 01. I'm going to pause here just to speed this up, okay? So we still have a failure, right? So there's obviously more to this. And let's go back over to here and look at some of the prereqs. Before you begin, access Databricks Workspace with Unity Catalog enabled. I mean, isn't it enabled? We created it. A workspace that is enabled for Unity Catalog. In most accounts, Unity Catalog is enabled by default when you create a workspace. I mean, I didn't create a workspace, I already have one. Ensure your workspace is enabled for Unity Catalog. If a workspace predates automatic enablement, Unity Catalog enable essentially means creating a Unity Catalog metastore in the workspace region and confirming that any groups that you have is created, whatever. And by the way, when I created the bucket, I didn't check, so I might have egress costs. Upgrade the tables that are registered in your thing. Okay, can I just make a new workspace? I mean, this is my workspace, right? But like we have it here, so it must be enabled, right? Because we have Unity Catalog here. So just a moment, let me figure this out. One thing I noticed over here in the catalog is that we can add a connection. So I wonder if we're supposed to be doing this. I'm going to just try it anyway and see if it, do we even have access to this with AWS? Amazon? Nope, it's for Redshift. So that kind of doesn't work for me here, but let me just figure this out a bit further, okay? So in here, it just says like, how do you confirm? So I went over to here to confirm. So it says use the account console to confirm your Unity catalog enablement. So we'll click to workspaces. I mean, this just says workspace. Oh, up here we have workspace. Oh, we have multiple workspaces here. What if we go to manage account? Oh, okay, so now we have more workspaces. So now we can see where it is. This is in US West 2. I see. Serverless only. And it has a metastore. Is that what it needs for it to work? Let's go back over to here. It was over here. So use the accounts workspace. Find the workspace and check the metastore column. If a metastore name is present, your workspace is attached to a Unity Catalog metastore and therefore enabled for Unity Catalog. Run SQL query to confirm Unity Catalog enablement. Run the following SQL query in the SQL query in a notebook. So we'll go ahead and try this as well. But it looks like we do have a connection. So we'll go back over to our workspace here, back into here. I'm just going to create a new, Shift Enter to run and move. I don't want to do that. I just want to add another cell. Where do I add another cell? Normally, there's like a little plus underneath. Oh, here it is. Okay, great. So I'm just going to paste this in here. I want to drag this above, and let's just run that and see what we get. I mean, again, I do believe that we have it enabled. So we'll give that a moment. So we see US West 2. I didn't know I was in US West 2, but that's great. And therefore, you're enabled, right? So that's good. But we are back onto this step where it's an issue connecting here. So access to a Databricks workspace with Unity Catalog, the read volume permission with Unity Catalog, external volume for the read files, the path to your data source, the external location of the path example, cluster creation permissions. One thing I would think is like, does it need other additional permissions for S3? I don't think so, because it should have it. And so here, path to your data source. Now, maybe we don't need the full address. Let's go back and take a look here. I mean, that isn't the full address, it's just the file there. No such file or folder called that. Interesting. Okay, so I'm going to run it again, even though it's probably futile, but we'll try again. All right, so coming back here and just reading a bit more thoroughly, it says, when the storage credential is validated, you can create an external location. So I'm guessing in here we need to set up an external location. So I'm going to go back over to our catalog into our metastore. I think I'm at the top level there. Let's go back here. Yeah, sorry, catalog and external data. Sorry, I was fiddling around with this a bit and I gave it additional permissions, which I don't know if I was supposed to do. So I'm going to go ahead and revoke those for now because I don't know if I was supposed to do that. But let's go back over to catalog and maybe there's an option here to add external location. Create external location. Oh, there we go. Okay, good. So we have AWS Quick Start. I like that. That sounds good. Quick Start sound good to me. And so now we need to provide our bucket. So we'll go back over to our bucket name here. And we'll do S3:// and we'll paste that in here. We're going to send you to the AWS console to configure an external location. Once you sign in, you'll paste the personal access token and create a CloudFormation stack. Oh, okay. Bucket name. Make sure you have the following: AWS account, a name of existing bucket. Generate access token and copy and paste into the Databricks access token account. Okay, we'll generate that out. So I have that. Obviously, I will expire that before you see it. Now we'll go ahead and launch a quick start. So I guess there's additional things we need to provision. I was expecting that. So we'll dump that into here and I'll say acknowledge. I'm kind of curious as to what this template's doing. Let's take a look here at the view template. If you don't know how to read CloudFormation, sorry, I'm pretty good at it. But if we go over here to Canvas, we can see we have a Databricks API function. So it's creating a llama and then a copy zips function. And then it's going to a llama zip bucket. And then we have a S3 data buckets access role. I guess this is all fine. Sure, why not? So we'll go down below here and we will create it. I'm not sure if like the role is the exact same thing as we had before. If we go to our resources here, well, this will take a bit of time. Roles always take forever to create, but we'll just wait here and come back here in a second, okay? All right, so that CloudFormation template's done running. We can do this nice refresh here and we can see all the resources it's created. Let's go back over to here. And so copy this token and paste. We did that already. So we'll go ahead and hit OK. Well, we already did that. The bucket overlaps with existing external location. We'll go back over to here. We'll go into workspaces, default information. So I'm just trying to find that external location, but I mean, it must be loaded in here now, even though I don't necessarily see it here. What I'm going to do is go back to our workspace. We're going to go back into load data S3. Let's try to run this again. Because I would think now if there's external location, the command still doesn't work. So give me another check here. I'll be back in just a moment, okay? So now here it's saying create an external location. All I did was click we're up here. I just clicked down to the next step. So it just said like, oh, do you want to use with SQL? I mean, that's what we want to do. And so here, I guess we're providing it a location name. The name of the external location, the location name is special characters, must be whatever. The bucket path. So I suppose we are creating it here. Storage credential name, the name of the storage credential that authorizes the reading. So I guess we could do it this way as well. Did we not need to do, this is option 3, right? Let's go back up to option. Why did I do option 1? That create an external location for an S3 bucket using AWS CloudFormation template. This is the recommended approach to creating external locations for an S3 bucket. When you create an external location, Databricks configures external location and creates a storage credential for you. Oh, so the whole thing we did before, all that work we did before, we could have automated it, but the other pages didn't tell us that. So if we go back over to the catalog here, right, and we go into external data, we have an external location now, right? We go over to credentials, now we have 2. So we've essentially did it manually, and now we did it the automated way. I would have loved to known that up front, but that's okay. We learned quite a bit doing that, but now we actually can see that we have an external location. And so this is the name of the location. So I wonder if we copy this, what a roundabout way to do this, but this is why I'm walking you through this stuff, because just because they have instructions on it doesn't mean that it is easy or clear. Let's go ahead and run this and see what happens. So it says the public DBFS is disabled, access denied on your path. Okay, so I mean, we're kind of getting closer. I need another thing that we could do. Like we could try to make that work, but the other thing that I would like to do, because we did all that manual work, is why don't we go to that third step and create that external location, because we already have made that connection, right? And we might have better luck that way. I'm just trying to find this one. So we'll go back all the way to the top here. We're going to go to this one here, and we'll copy this command. Okay, and we'll go back over to our SQL. I wonder if we can just run the SQL editor here. Like, why wouldn't we be able to do that? And so this will just be, you know, my S3 bucket. And then our bucket path. So we'll go back over to here. We'll grab this. I'm going to assume that it wants S3, like S3:/ bucket, the storage credential name. So we're going to go back over to catalog here. We will go into external data, credentials. It's credentials, right? And so this is the one that I created earlier. We'll go back over to here, and we will provide it this. I don't really need a comment, but we'll put, just in case it really wants one. So it'll be like access to our S3 bucket, assuming we can run it here unless we have to run it somewhere else. And so I'm going to see if that runs. We'll see what happens, okay? It has a syntax error, maybe because that is optional. So I'll just take this out. It's not really clear if that is or not, but we'll go ahead and run it. I don't usually see SQL have square braces. Oh, yeah. So I think, yeah, this stuff is optional, right? Okay, so we'll go ahead and do this. We'll go run this again. And here it says, with storage credential, I mean, what else would it be? Try that again. Does that work? Please, 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 please. Okay, so it's saying that it overlaps basically because there is another location that already exists, right? So that's what I'm hearing from here. What I'm going to do is I'm going to tear, I know we're really in the weeds here, but you know, again, this is great learning experience. I'm going to delete this one here. I'm going to see if I can roll back one of these here so that there's not two locations. So we're going to delete that. And while that is deleted, I'm going to go back over to our catalog here. And I'm going to go into external data. And I want to get rid of that location, but I'm going to go over to credentials here. I mean, shouldn't it tear it? I don't think it would actually tear it down on this end. Let's go over to here. I'm going to go into this one. And how do I delete it? Over here, delete. So we'll delete it. So now there's no conflicts. And then we'll go to this one, which is the second one. We'll go ahead. We'll delete it. Okay. So now we shouldn't have a conflict. And this should, in theory, roll back. If it created an S3 bucket, it could run us an issue, but it looks like it's cleared out there. Okay, great. So we're going to go back over to SQL. Okay, and now we'll run this again. And so it shouldn't have a conflict because that other one shouldn't be there, right? So now it has created that. So now it's called my S3 bucket. So we have that. Let's go over to SQL. Well, actually, we're in SQL. Can we just do here? List like this. Can we do this? List my S3 bucket. There's only a single file in that whole thing. So let's see if it works now. So it's operation not allowed, list with resource type. Okay, I'm not sure. Oh, you know what? Maybe we do like quotations here. 1 second. Let's try that. So it says public DFS route is disabled, access denied on the path. So clearly we have a permissions issue, whatever that is. And it's the same one, so we ruled it out. You need to mount your S3 bucket to Databricks file system before you can list its content. Of course, there's just more and more as it goes here, but this is showing us in Python, right? So, I mean, we could take this and run it, I guess, as Python. You replace your access key and secret with your, really? That doesn't seem like that should be the way we should have to do it. But anyway, let's go back over to our catalog here. Because I did notice over here, if we click into this, permissions, there's no permissions here. I mean, it means to read this? Like this isn't clear as to what permissions are going here, but we'll go ahead and just try this, right? So now we're just saying everyone can read from this one. Let's go back over to our SQL editor. Let's try this one more time. All right, just a moment, okay? And so here it's talking about like, because it might have suggested that maybe it's disabled in the free edition, but they're talking about like the serverless compute, that it might not work there. So that is a challenge here. So just give me a second here, okay? I'm going to see if there's another solution. All right, one other observation I noticed here is if we go to browse, it actually allows us to browse the file. So we clearly can see stuff in here, right? And here it says all workspaces have access. So clearly we do have a connection here, right? We have read, write, list, delete. We have full access. So I don't think it's a matter of our external location doesn't work. There's just some mismatch with this information in terms of these steps here. So again, I'll just continue on here to just try to debug it, but I just wanted to show that we do indeed have a connection, okay? But we need to figure this out. Over here, we have like, it's the workspace selected, which is true. So we are in our workspace. We're running this in the serverless starter warehouse. Okay, so just give me a second, okay? So here it's suggesting there is another way, and this is an older way to do it, and so that we would actually have to grant access, which I believe we did. So again, we'll go back over to here, take a look. We click into this, we go to permissions, and we have granted all users in this account all privileges. So there's no chance that we do not have that. But again, we'll continue to try here, okay? I'll just keep looking. One other thing I figured to check is to check if there's a limit on the trial. And so the trial forces you to use serverless compute limitations and general limitations here. It says you must use Unity Catalog, connect external data sources, use external to access data sources. So there's nothing suggesting that it has to do with the fact that we're on a trial account using serverless compute, but I'll continue to look, okay? All right, just as a side detour here, one thing it was suggesting before is, can I check my audit logs? And so I asked, where does it store? It says system access audit. And so it might not be specific to the one that we're doing here, but if we go over to actions, we can kind of see like list connections, things that we're doing. So I'm just kind of wondering if we can find the information here. And like, is it ordered by latest or newest here? It looks like, so probably here like order by event time descending, and then we'll just say like limit 100 because I don't need that many records. And so maybe this will make it a little bit clearer. Oh, here, limit. We need a limit on this, sorry. It's nice I just use standard SQL and it should just work. Let's see if that helps it try to narrow down, at least see the last actions that we were running, right? So if I go over to here, I mean, it's grabbing everything. That's a little bit too much information. The only thing we really want here is, well, I guess we'll just have all of it for now, but let's go take a look here. So here we have token, login, auth, list credentials, list volumes, list tables. So I'm not really sure if this is going to be the way that we're going to figure it out. But anyway, I wanted to show that because it's nice to know where the logs are, and I guess the logs are in SQL, but I'll keep trying here for just a moment. One thing I did notice here is that they also have this load data using a Unity Catalog external location. I mean, like this has an external location, so you would think that this can take it from this other way, unless you can't use this with Unity Catalog, because here it says here, you'll learn how to access and correspond with the Unity Catalog volume recommended or Unity Catalog external location. Okay, let's go over to here and try this one. So, you know, this is a public preview feature, but if it is here, maybe we can try to utilize it. So here we have external data, external locations. We've already done that, so we know we have that already. Create the manage table in the sidebar of your workspace, add new data. because all we're really doing is importing data. And so maybe this is a way that we can do it. Add or upload data here. Okay. And create table from S3. Yes, we'll go ahead and do that. It did say, like, does our schema have access to do whatever? Yeah, so there it is right there. We'll click it. We'll preview the table. Cannot read files when the input path does not exist. Okay, so here it's suggesting that the input path does not exist. Huh. Let's go back a step. Now that's interesting that we're getting a different error here. Go okay, let's try this again. Maybe we're onto something because we're getting kind of a different thing, but here it's showing the contents of it. We can see it. So I'm checkboxing what I want, right? And then I say preview table. Interesting. So let's feed it in and see what it has to say here, because obviously it does exist. Obviously it's able to see stuff. It's just very, very confusing, right? Or it's not accessible. So verify the S3 path is correct and that the bucket and folder exists. You can do this by navigating the S3 console. I mean, like, how did it load it if it had it? Check the permissions. S3 list bucket, get object, put object. Check for typos. Use the correct path in your code. Here's an example you might use with autoloader, which is what we want to use. So I'm going to do something extreme, and I mean, it's not like super extreme, but what I'm going to do is I'm going to go back over to catalog because we had that CloudFormation template, right? And that one apparently set everything up for us and supposed to be like, it's just supposed to work, right? So what I'm going to do is I'm going to go ahead and delete this. I know it's crazy. We're going to go over to credentials. I'm going to go to this one and I'm going to delete it. And now what we'll do is we'll get set up via the automation thing. So it was here. And I know we want to do, yeah, here it is. Create external location action. We'll go next. And then what we'll do is go back over to here. We will grab our bucket name, which is this. And I know we already did this, but we're just going to do it again because if we can get it to work, we'll be in good shape. Let's take out that space here. We'll generate a new personal access token. We'll copy it. We'll launch in Quick Start. Okay, we'll go down here. We will enter that key in. We're going to go down here. We're going to create the stack. This is going to set up everything for us, which, by the way, would have loved to do this the first time, because this way we can rule out, say, like, okay, it's not us, right? Because if we do this exactly as it's asked, then the permissions, like the access should be set up. We will have to go to permissions and make sure we have that, but we'll figure that out in just a moment, okay? All right, so this is now set up. We'll go back here. And the idea here is that, oh, we'll have to copy this. Copy this. Oh, we already did that. The idea here is that now that we have this external location set up, this one's more likely to work, but we'll go into permissions here. We'll go ahead. We'll grant permissions. We'll give it all. We'll give it manage. We'll give it everything. Just let it be able to do something, okay? So go ahead. We'll add it. This way, we're very unlikely to make a mistake here. Let's go copy this. We'll go over to SQL. We're going to now replace it here, and it should work. If it doesn't work, we'll give up, but it should work. Because now we're literally using what it's telling us to do. So it's still telling us it's not going to work. The other thing that we could rule out, I guess, would be the compute. So we go over to here. And I mean, like, as far as I'm aware of, there's nothing special that the compute needs, right? So we go here. Can I even use another compute on a free tier? I'm not even sure. Let's go ahead and take a look. No, we're at the max. So yeah, it's not clear, like, if this one doesn't work, if this doesn't, like, what else could it be, right? Because now it's doing all the work to set it up for us. The only thing I don't remember doing, did we actually enter in what it needed access to. So let's go take a look here, because I would assume this would just get full access to S3. Let's go down here and take a look. So here it sets the account ID, which is fine. And this one is giving access to a bucket that it's created. So yeah, I believe this actually created a bucket for us. Let's go back over here. We'll go over to here, resources. Zips. So if we go back over to here for a moment into our catalog, external data, we'll click into here. We'll go to browse. I guess we must have plugged that in. Like what else could it need? Do you know what I mean? So we go back over to here. I'm gonna again check it, because here this would have created a role, right? Like it absolutely would have. And so we have the S3 data access role. So we'll click into this one, right? This is where it would have a problem, saying it can't be found. Are we looking at old data here? Let's go back over here to CloudFormation. Also, why is this in Tokyo? Databricks S3 ingestion. I'm in the Tokyo region. I wonder if that's a problem at all. It's so what I'm going to do, I'm going to delete. I know this is ridiculous, but I'm going to try this one more time. I'm going to switch over to US West 2. Okay, so now we're going to be in the same region. And some with netboot. I'm not sure what this is for, but I'm going to ignore it for now. What I'm going to do is, now that I'm in US West 2, I'm going to do this again. I know it's crazy, but now that see, it doesn't have access anymore because we deleted that permission. So it's so strange that would not be an issue, but let's go ahead. I just want to rule that out. I know we've done this so many times, but we'll go over to here into external data, into our credentials here. I'm going to go ahead. I'm going to delete this. I'm going to go back over to external locations. We're going to create. We're going to go ahead, go to the quick start. We will provide the bucket name, which we do here. Also, let's take a look at where the bucket is. I'm going to make sure the bucket is in the same region, US West 2. The bucket I probably just created is probably in Tokyo. So we'll go here and type in Databricks. It's in Tokyo, because I haven't been paying attention to what I've been doing. Okay, so we're going to go ahead and just rule this out, right? We'll empty the bucket. We will permanent delete. That's totally fine. Yep, permanently delete. I like how they made it like two steps after each other now, which is nice. So now we're getting rid of that bucket. We're going to create a new Databricks bucket. So I want to go back here. We're going to say Databricks auto load bucket, because that's what this is supposed to be for this entire time. I'm going to copy this. I'm going to go all the way down. We're going to create that bucket. That bucket is now, should be created. We're going to go back over to here. We're going to dump in our bucket name, which is S3://. We're going to generate another personal access token. We're going to hit launch quick access. We're going to go down here. We're going to dump in the personal access token. We're going to go all the way to the bottom. We're going to checkbox this. We're going to hit create, and we're going to wait, and we're going to see what's going to happen, okay? I just noticed again, it says Asia, Tokyo, Pacific. Why is it over here? I don't understand. Hold on one second. I can't create it in this region. It's going to drive me crazy. You know, I think I'm going to delete this. Like, I definitely chose this region. Let's check our S3 bucket. Let's make sure that bucket that I just made is in the right location, because if it's not, it's going to drive me crazy here. So, Databricks. No, none of these buckets are in the right location. Okay, delete. Just get rid of these buckets. Please get rid of them. Yeah, let's delete it. Bye-bye bucket. Okay? And I'm going to go back over to here. Look, it switched me back. I think it's because when I'm over here, I don't know why, it's just defaulting me. We'll try this one more time. Databricks. We'll delete this one. I have to pay. Yeah, look, it switched me back. So this is something weird that AWS is doing. They never used to do that. I'm not sure why it really wants to persist me over into the Tokyo region. But we'll go back here and we'll make sure we're in Oregon. we will create a bucket. We will make sure that we choose. At least it's not me. We'll make sure that it's in the location we want it to be. Can I choose where it is? No, but it says right here, so that's okay. We'll go ahead and create that bucket. We are going to make sure it's in the region we want it to be in. It is. Excellent. Okay, we're going to go back. We're going to do this again. Sure, we'll use this. No, we'll have to do this again from scratch. So we'll go here, create a location, next. And really, I got the name autoload. That is such a surprise. We'll go ahead and type s3://. We'll generate a new personal access token. We'll go next. We'll hit quick launch. We will make sure it's this location. Again, I don't think that's the reason why it's not working, but I want to make sure that we rule it out, right? Because we are in US West 2. If you didn't notice earlier, well, I'll show you again. But if we go over to workspace, it says US West 2. So let's make sure we are in the same region and see if this makes any difference. So we'll wait here again, okay? All right, so now we have our bucket in US West, our credentials in US West, our workspace in US West. And so if all these things are in US West, you know, maybe that will resolve our issue. I'm going to go to this external location. I'm going to look at browse. Oh, this has nothing in the bucket, right? So we'll go into this bucket. We're going to have to upload something to it. So I'm going to go ahead and do that. I still have the file off screen here. Okay. Just one moment here. I should have the folder. One moment. Here we go. We will drag this one on over. We're going to upload it. It's now uploaded. We'll go back over to here. We can see, it can see that there's a file in here, right? We're going to go back here. We're going to copy. Well, before we do anything else, we're going to grant permissions. We're going to go read, write. We're going to, or not read, write. We're going to give it everything. We are just going to be very permissive and just say everyone can do everything. We're going to go into, over here, we're going to go into external data. We'll go to our credentials. We'll do the same thing. We'll say, hey, everybody, you can use whatever you want. Just go for it. So now everybody has access to everything. There should be no permissions issues whatsoever. I mean, probably we'll have problems, but we'll try it anyway. We're going to copy that. We're going to the SQL editor. We're going to now replace this with this. Okay, everything is now in the same location. We're going to try this again. Please work, please work, please work, please work, please work, please work, please work. And it doesn't work. So I don't know why it doesn't work. I can't solve it in this video. We are following everything that it's suggesting. We could not find anything online. They're talking about something else, that there's something called a catalog volume. So maybe there's another way to add the data. I'm not sure, but this has been a very frustrating experience, but we have learned a lot going through all this stuff. Now we understand catalog configuration quite well. But why it doesn't work, I do not know. It is insanely frustrating, right? So we're going to call the video quits here because we're at an hour, and you know, it is what it is. Okay. But yeah, there you go. So what are Delta Live Table? It is a declarative framework in Databricks that simplifies building, batching, and streaming ETL pipelines with built-in data quality orchestration monitoring. So here down below, you can see a pipeline moving from left to right. So it's that visual thing you're seeing there. Its key benefits: it's unified with batch streaming pipeline support, declarative syntax with just a few lines of SQL or Python, automated orchestration and error recovery, built-in data quality checks via accept, incremental and CDC support. We have a slide on CDC somewhere in the course if you need to know what it is. Serverless compute for cost efficiency, visual monitoring and lineage tracking. Common use cases would be a declarative ETL, change data capture, real-time streaming indigestion, SQL-based pipelines with automated scaling. And so down below, we have an example where we have the refresh live table. So the idea is you're selecting that information and you can then see that information there, but we'll get more into it as we go. Let's take a look at notebook libraries and targets. So in Delta Live Tables, pipelines are defined by notebook libraries. These are code for transformations, and targets where output data is stored. Notebook libraries define logic using DTL.table SQL or Python. Targets specify the catalog schema where output tables are saved. DTL manages execution orders based on dependencies. So down below, the idea here is we have your notebook library where there are DTL command there. It's going to execute that data towards that target. If that doesn't make sense, it'll probably make more sense as we continue on here, but there. All right, let's take a look here at the syntax for DTLs. So the idea here is that we use live to define managed tables and stream to read from streaming inputs. So the idea here is that we create a live table and then we're selecting our data. So live tells DTL to manage the table view lifecycle. Stream treats the source as streaming, even if it is batch capable. So pretty straightforward. You have a live and then you got a stream. Let's take a look at violations in Delta Live Tables. So you define your expectations as data constraints to validate incoming data. You control how violations are handled using on violation clause. So let's take a look at our violation handling options. So on violation failed update. So stops the pipeline. If any rows violate the exception, we have on violation drop rows, skips only the invalid rows. The rest of the pipeline continues normally. Use fail update when the bad data should stop the pipeline. So missing required fields. Use the drop row when it's okay to skip bad records and keep going. So here's an example of the idea here. We have enforced location is not null. So constraint valid location, expect this thing to not be null and then make it a violation if it fails, okay? Let's take a look at change data capture. This tracks inserts, updates, and deletes in a source data so you can reflect those changes in a target table without reprocessing everything. It's great to keep your warehouses or analytics tables up to date, reduces costs and latency in pipelines, avoids full refreshes. And so the command here to do it is apply changes into, and the source must include a change type column because you need to know what has been changed. And the target Delta table is where are the changes. The target is where the changes are applied. You need to have a primary key used to match and update the rows in the target. So down below, we say apply changes into target from source stream. Okay, and so we have insert, update, delete. So inserts is added to the target. Update is when you're matched on a key and it's updated, and deletes is matched on a key and remove if configured. But having an additional table that has the individual changes are really good in OLAPs, like analytical systems. So it's just another way to incrementally see the changes, okay? Let's just talk about error diagnostics and DTL pipelines. So Databricks provides built-in error diagnostics to track resolve issues. When a pipeline fails, you can quickly identify which notebook or transformation caused the failure. The specific error message failed in the line of code, the pipeline stage and table name where the issue occurred. Quickly debug broken ETL stages with manually tracing notebooks dependencies. I don't have a screenshot here for you, but as we work through our labs, you'll be able to see it clearly. So the DTL event log helps track pipeline progress, diagnose failures, and ensure reliability. It tracks state changes like initializations, updates, and failures, debugs issues by identifying which notebook table caused the failure, review metrics, schema changes, and job duration. We can audit data lineage to trace dependencies across tables. So you have a tab there that says DTL event log, which gives you information. You have a filter. Pretty straightforward, okay? Let's take a look here at Databricks jobs. These let you automate and schedule workflows like notebooks, pipelines, or scripts using cron expressions. If you don't know what cron is, it's a time-based syntax used to schedule recurring tasks. So here's the format there on the left-hand side. And here's an example of, let's say we want to run something every day at 2:30 a.m. So the idea here is that the first number is the 30 minutes, and then the next one is the 2 hours. The next one would be the day, the month, whatever. It makes sense. If you have a hard time with cron, just go ask ChatGPT or a one to make them for you. I've always had a hard time remembering these, but they've been around forever and ever and ever since Linux has ever existed. Its jobs features is that it schedules with cron syntax, it chains tasks with dependencies, it passes parameters into notebooks, and we can monitor job history and outputs, and we can trigger notebooks such as DTLs, jars, and scripts, okay? So those are the things that can trigger. So let's just talk about running multiple tasks, okay, with Databricks jobs. So where each task can depend on the successful completion of an other or predecessor task. So tasks follow defined dependencies or predecessors. They're used for ETLs, ML training, or stage workflows. Their dependent tasks won't run if the procedures fail, which makes sense. And they pass outputs using task parameters. So here we have task 1, task 2, task 3, task 4. So task 1 runs first with no dependencies because it's not dependent on anything. Task 2 and 3 wait for task 1 to complete. Task 4 runs only after task 2 and 3 finish successfully. So that should be pretty straightforward, but there you go. Let's take a look here at monitoring jobs and failure alerts. So Databricks jobs provide built-in tools to track job execution, diagnose issues, and set up alerting for failures or delays. The idea is you get a visual job status board. You can check out run history. You can see failed alerts, and you can filter and search that data. Notice on the left-hand side that we see workflows, and if you see jobs and pipelines, it kind of makes sense because they're grouped together, but you can see on the right-hand side, recent runs with some information, right? Oh yeah, also says multitask tracking, whatever that means. But let's take a look at retry policy. So retry policy automatically reruns failed tasks with delays between attempts to help ensure your jobs complete successfully. The default setting for tasks retries depends on the job configuration. For most configurations, the default setting does not retry any tasks on task failure. Service jobs auto-optimize retries by default. To configure a policy that determines when and how many times it has failed, you can do that and add it via retries. The retry interval is calculated in milliseconds between the start of the failed run and the subsequent retry run. If you configure both timeouts and retries, the timeouts apply to each retry. Let's talk about email alerts on job failures. So the idea is you can set up if you get an email based on failed or succeeded or started, or if it took longer than expected. So here's an example on the right-hand side. If you take a look, you can see how many times it was attempted, its state was failed, how long it took. So some basic information there. You can send notifications to one or more email addresses or third-party destinations. So you've got a lot of options there. You can set up custom SQL alerts, okay, that meet specific criteria. So like, let's say you run it against a metric, define a trigger, schedule how often you want it, send alerts to your emails via webhooks, optionally notify when conditions return to normal. This is pretty normal stuff. But there you go, okay? Let's take a look at debugging failed tasks. So when a job fails, you can quickly identify the problem, fix it, and rerun only the failed parts instead of starting over. So on the left-hand side, they have this beautiful graph. Love it. Never seen that in any other provider. But the idea is that you get a matrix view, and you can hover over and get the error messages, start, end time, cluster information, log, and output. The Databricks system also helps you diagnose errors. It's not particularly good, but at least it tries using like with AI and stuff. And they want you to know it for the exam. I never got any questions on it, but it's definitely a thing that you could possibly use. But there you go. All right, for visualization of SQL, Databricks has built-in support for charting and visualizations via Databricks SQL. So you can get line, pie, scatter, and all sorts of charts. You can customize their axis colors and series. You can save and reuse dashboards, and it can apply auto updates with new query results. So here we have a query on the left-hand side within the Databricks SQL, and then we are choosing to visualize it. Notice down below where it has results, we are choosing visualization, and so then we have options to change it. So there you go. You can schedule automatic dashboard refreshes to ensure viewers always see the latest data. We mentioned that, but let's give it a little bit more attention. So you can set update frequency to every 4 hours and start time. You can choose time zone and filter behavior for default or save filters. You can use any SQL warehouse for refresh runs. You can optionally subscribe to receive updated snapshots via emails. So on the right-hand side, there you have your schedule. So you name your schedule, you provide it a time zone, and filters that you want to apply. So the idea here is that the add schedule dialog is where you define timings, filters, warehouses used to schedule updates. So that should be pretty clear. But there you go. Let's take a look here at Unity Catalog. So in Databricks, a Unity Catalog is a unified governance layer for centrally managing access, auditing, lineage, and organization of data and AI assets across workspaces and clouds. So you're going to see Catalog come up quite a bit. In terms of where it sits in our hierarchy, it's under Metastore. You can see there catalog and catalog schema and other things under it, which we'll repeat again and again throughout this course. So what are the components of a catalog? Well, there's a catalog itself. It's a group of assets by business unit or domain. Schemas, which are tables or views within a catalog. It's easy to think of, the schema as the database, but yeah. Then you have tables and views. These are core structured data assets. Tables being tabular data and views being, like query results. You have volumes, which is for storing unstructured files. So as the name implies, it's a volume. You have functions and ML models. These are reusable logic and AI components. You have lineage and audit logs. These track usage, access, and transformations. There are a couple of catalog types. We have standard catalog, which is not much to say. It's just the standard one. But then you have this foreign catalog, and this is only in Lake House Federation scenarios. And what it's doing is it's mirroring a database in an external data system, enabling you to perform read-only queries on that data system in your Databricks workspace. A default catalog is configured for each workspace that is enabled for Unity Catalog. If you do not specify a catalog, that is what it's going to use. If you need to limit access, you can use workspace boundaries to limit who has access to the catalog. So you'd have to create a workspace catalog binding, to set up workspace boundaries. But we'll look at more Unity Catalog here soon, okay? As we work within Databricks, you're going to see this 3-level namespace. And this is the way Unity Catalog organizes data with this standard convention. It's catalog, schema, table. So we have one example here is main sales customers. So main is the top level container, which is the catalog. Schema, which is going to basically be your logical database, and then customers is the table storing the data. So each level supports its own permissions via Unity Catalog, and it follows standard SQL formats. So you can do select all from main.sales.customers. So there you go. Data lineage shows how data flows and transforms and is automatically captured for all queries in the Unity Catalog. So there's an example of data lineage, and if you look closely, you can see a materialized view, which comes from a view, which comes from a table, and maybe that table comes from an external location. So as the name implies, it's data lineage, so it's showing you, the origins of where data is coming from. So captures runtime lineage across all supported languages, supports column level lineage, visible across all workspaces sharing the same metastore. Lineage can be viewed in the Catalog Explorer or queried via the System Tables or REST API, and the data will be retained for 1 year. Let's take a look here at tables within Databricks. This term can be a bit confusing because there are different layers of tables and technologies that are underneath that are utilizing specific tables. So if you get a bit confused, it's okay, but we'll work through this and figure it out. So the Unity Catalog has the following Databricks table types. It has 3 of them, the first being manage, and this is the default type. So whenever you create a table, if you do not select anything, it's going to be a managed table. And as the name implies, it is fully managed by Databricks. Underneath, it's using Delta Lake, so it's a Delta table, but we'll talk about that in a moment. For external tables, these are also called unmanaged tables, and as the name implies, they are external from Databricks. They're not managed by Databricks. So this is going to get data from cloud storage like AWS, Azure, GCP, and Unity Catalog supports external tables in several formats, so it really depends on where you're getting it from and things like that. Then you have foreign tables. These represent data stored in external systems connected to Databricks through Lakehouse Federation. And these foreign tables are read-only in Databricks. Databricks supports Delta Lake tables and Apache Iceberg tables. I've really only been seeing Delta Lake tables, but I imagine that if you're using external tables and then the source is using Apache Iceberg tables, that's probably what they mean. Databricks supports legacy Hive tables and live tables for backwards compatibility. For the exam, I don't think you'll have to worry about that, but I just wanted to point that out that you'll see those variants in the documentation and in the interfaces. Let's just kind of break it down so we understand clearly the difference between these three. So for managed, it's being managed by Unity Catalog, which means that you're going to get read-write support, performance optimization, storage cost optimization. For external, it's just going to be files only, what you're bringing into the platform. And so you will get read-write support, meaning that you can read and write to an external, but you're not going to get performance optimizations or storage cost optimization, or I should say that it will be up to you to manually manage that within your cloud service provider. For foreign, it's just bringing in files. It's read-only, and there's no way to optimize it because I guess through the third-party connection, there's just no means to do that, as it's just bringing the data in for the most part. But we mentioned data lake, data tables. So let's make sure we understand what data tables mean when we're talking about on Databricks. So tables backed by data lake are known as delta tables. Saying data, delta tables. Delta tables store data as a directory of files in the cloud object storage and registers its metadata to the metastore within a catalog and schema. So data lake, I keep telling data lake. Delta lake is the default table formats in Databricks, so most references to tables refer to delta tables, unless explicitly stated otherwise. Databricks recommends using fully qualified table names instead of path files when interacting with delta tables. I notice this that sometimes, you can name them with the / syntax or kind of like a domain name, a fully qualified domain. So that's what they're recommending here. Although you can create tables that don't use Delta Lake, those tables lack transactional guarantees and performance optimizations of Delta tables. So maybe we're talking about like Apache Iceberg tables or the other legacy ones that we're talking about. Let's make sure we understand the different Delta table types that you're going to encounter within Databricks. So if you are utilizing managed tables in the Unity catalog, these are always going to be backed by Delta tables. So this is going to be the default and the recommended type. And there's lots of advantages to utilizing Delta tables. For external tables, they can be backed by Delta tables, and they support some legacy integration patterns external with Delta Lake clients. So again, it just depends on what you're connecting to and what they have there. For foreign tables, they might be backed by Delta Lake, depending on the foreign catalog, but they don't have optimizations present in Unity catalog managed tables because you're just importing the data. There's no back and forth interaction. There is a type of table called streaming tables, and this is when we're using the Lakeflow declarative pipeline dataset. And these are backed by Delta Lake that include an append with auto CDC into flow definition for incremental processing. Then you have materialized views. These are backed by Delta Lake that materialize the results of a query using managed flow logic. These last two you're going to see when we go create a lake flow, you'll see that option for dataset or dataset type. When we drop down materialized view streaming table, we'll talk about these options later, but I just want to show that to you so you can start to put it in your memory. Then you have Hive metastore tables. So these are foreign tables in an external or external federated Hive metastore and tables in the legacy workspace Hive metastore. Both manage and external Hive metastore tables can also be backed by Delta Lake. So there you go. So within Unity Catalog, we have views, and these are read-only objects that is the result of a query over one or more tables and views in the Unity Catalog metastore. So we know under our schema we have table, but we also have views, volumes, and functions, including models. So a view stores the text of a query typically against one or more data sources or tables in the metastore. Unlike data frames, and I'm assuming they're talking about like Pandas data frames, you can query views from anywhere in Databricks. Assuming, oh no, they're talking about Apache Spark data frames. Sorry, Apache Spark data frames. You can query views from anywhere in Databricks, assuming that you have permission to do so. Creating a view does not process or write any data. Only the query text is registered to the metastore in the associated schema. Let's talk about the types of views we are going to see. So we have metric view. These are reusable business metrics that are centrally maintained and accessible to all users in the workspace. We have materialized views. These are incrementally calculated and updated the results returned by the defining query. You have temporary views. These are limited scope and persistent and not registered to a schema or catalog. And you have dynamic views used to provide row and column level access controls in addition to data masking. So hopefully that makes sense. If we get some hands-on, it'll really stick with you here, but there you go. Let's take a look at volumes within Unity Catalog. So these are logical volumes of storage in a cloud object storage location for non-tabular data sets. So here on the left-hand side, we have schema, and underneath schema, we have table, volumes, views, functions, including models. So let's make it clear the distinction between tables and volumes. So tables provide governance over tabular data sets, right? Tables, tabular data, makes sense. Volumes provide governance over non-tabular data sets. Imagine a bunch of files in a volume, should be pretty clear. So we have a few types of volumes. We have managed volumes and external volumes. As the name implies, managed means that it's managed by Databricks. External means that it's managed by a cloud service provider external from Databricks, right? So the path to access volumes is the same whether you use Apache Spark, SQL, Python, or other languages and libraries, which is very convenient. That pattern is going to be volumes, the name of the catalog, the name of the schema, the name of the volume, the path, and the file name. You can also use DBFS. It is supported, so there you go. Let's talk about access control scope. So Databricks uses different access control systems depending on the type of object being secured. So I'll get my pen out here just for a moment, as this is a table. But if we're at a workspace level, like notebooks, SQL, warehouses, we're going to be using ACLs. If it's account level, like users, groups, services, and principals, we're using RBAC, so account role-based access controls. If it's data level, tables, schemas, views, and etc., then we're using whatever's built into the Unity catalog. So ACLs control access to notebooks and SQL warehouses. Account rules apply across all workspaces. Unity catalog manages fine-grained permissions for data and AI assets. Each system is used based on the object type. But we will dive into these access control systems here in just a moment. Let's talk about RBAC. So Unity uses RBAC to control access across catalog, schemas, tables, and views so users can access what they need. Each layer controls a different level of data structure. So the catalog is the top level container, which is like a database. I would say a schema is more like a database, but we can say that the catalog is like a database. Schema is like a folder inside the catalog. Again, that doesn't make a whole lot of sense. I would probably consider the schema the like a logical division. This makes a lot more sense if you know Postgres. So like in Postgres, you would have your database, and then within your database, you can make a schema, which is like a logical partition. So you could map it like that if you want, but I'm not saying that underneath that they're using Postgres. I'm just trying to pull parallels to that, okay? And then for tables and views, that's your actual data assets. So you'll hear me reference the schema as a database, because that's how I like to think about it, but you can also think of the catalog as a database if you want. So access is assigned per layer, such as the use, select, or modify SQL commands. RBAC ensures that permissions are modular and easy to manage across teams, environments, and data types. But we will see this in action in a bit, okay? Let's talk about fine-grained access controls. So when we're using SQL-based access controls to manage across catalogs, schemas, and tables, we're using fine-grained controls. And so the idea here is that when we're looking at the schema, you have this idea of privileges flowing downward in the hierarchy. So they go from catalog, schema, and table views. And so what we'll end up using to do fine-grained access controls is grant and revoke. This idea here is that it will apply to catalog, schemas, tables, views, volumes, and functions. The key privileges that we will be doing this on would be like select, insert, update, delete, use, catalog, and manage. And granted by is for Metastore admins, object owners, or users with manage. So permissions can be set via SQL or the Catalog Explorer UI. So the idea here is that with the grant command, we're saying you are allowed to use select, you are allowed to use insert, you're allowed to use update, right? Or you can revoke that access for specific people, okay? So hopefully that makes sense, and it's a little bit confusing, but it will make more sense when we go do it hands-on. Okay? So a service principal is a secure API-only identity used for automation and programmatic access, best for running jobs or scripts without relying on personal user accounts and credentials. If you've used GCP or even Azure, they have this concept of service principals. So anyway, let's talk about the roles and permissions. So we have the account admin. This has full management across workspaces and roles. You have the workspace admin. They assign service principals to workspaces, manage workspace level access. You have a service principal manager. This manages roles for service principals. For the creator or the account admin, you have the service principal user. This runs jobs using the service principal identity, which must be assigned. Service principals can be added to groups, granted Unity catalog access, and assigned admin. All right, let's talk about isolate business units. So you can create separate catalogs per business unit to logically keep them segmented. This could be for finance, marketing, or engineering, or to apply fine-grained access controls, or to simplify auditing and governance. So imagine you have multiple different types of catalogs. And again, for sales, marketing, finance, it's very simple to create these catalogs. If you're using SQL, you can just do create catalog finance, and then you can use the grant all to say, hey, who's going to be the owner for these catalogs? Each catalog contains its own schema and tables, accessible only to the authorized users, which makes sense. But there you go. Let's talk about Unity catalog best practices. So the idea here is that you have a catalog, and for every catalog, it's for an environment or a business unit of isolation. We talked about that there, but I'm just going to get my pen tool out here so we can make that even more clear. So here we have our catalog, and notice we have dev, staging, prod, dev1, staging, prod. So we are isolating based on the business unit isolation or for the environment. Most of these are showing environment, of course, but in the prior example we talked about business isolation, it was specifically for business unit. For workspaces, let me just get my my eraser out here so we can just correct some of this here. There we go. So for workspaces, it's mapped to environments or teams, right? So here we have dev WS, staging WS, or here prod workspace. So, there could be a catalog where you only have a single workspace, or you can have multiples, but you can make sense of it there. Then for groups, these control access for specific users. And so here we are just grouping people. So, if you're in the developer workspace, it's probably developers, or then you have testers. If you're in production, maybe you need folks that need access for analysis. If it is a business unit over here, that's what this actually stands for, business unit, then you have your BU developers, your BU testers. So hopefully that is clear. So there. All right, let's take a look here at Databricks Connect, which is a client library for the Databricks runtime that enables you to connect popular IDEs to Databricks Compute. Okay, so the idea here is that on the left-hand side, you can see that we're in our IDE. We're writing some piece of code, looks like Python, and you can see that that is interfacing with compute in a cluster within the Databricks platform. So IDEs that support is Visual Studio Code, PyCharm, RStudio Desktop, IntelliJ, notebook servers, and other custom applications. And you're able to use this client library in Python, R, and Scala. The Databricks Connect is built on open source Spark Connect, which has a decoupled client-server architecture for Apache Spark that allows remote connectivity to Spark clusters using the DataFrame API and unresolved logical plans as a protocol. I just put that in there so you know that it comes from Spark Connect, that they've just done a bit of extra work to make it integrate. The Databricks extension for Visual Studio Code includes Databricks Connect, and for the most part, I will probably use Visual Studio Code because it's so easy to install and easy to get. But yeah, we will go try this out in a lab, okay? Hey, this is Andy Brown. In this video, we're going to figure out how to utilize Databricks Connect. So here I have Visual Studio Code. I just have a folder here called Databricks Example, nothing in it, at least at this point. And so what I need to do is go over to extensions, and let's go ahead and get Databricks, because they say the Databricks Connect is part of this. So if we go over to here and install it, I'm going to assume that we'll have to authenticate with our account. We're going to have some kind of cluster to actually connect to and make a file. Okay, we'll just give this a moment here. Right now, my account, I have nothing running. If I go over to compute, I mean, there is the serverless starter warehouse, but other than that, Nothing else here. So I'm just going to ignore that for now. So that should be connected. We go down to Databricks here. We're going to wait for this to initialize. We'll need to create a configuration. So this Databricks host should begin with etc. So I do believe it's the address up here. So if we go here and grab this here, that is what we need. Okay, so it's as simple as that. It's just the address at the top, and we will drop it in. We'll go take out that /. We'll hit enter. We have OAuth, personal access token. We do OAuth. That sounds pretty good. So enter a name for the new profile. This will just be dev, I guess. And now over here, we'll say open in browser. And we are authenticated. You can close this tab. So we'll close out that tab. We'll go back over to Visual Studio Code. And it says it failed. So we'll select, we'll try that one more time. Okay, so we'll go ahead. We'll do that again. I'm going to paste in the address up here. And that looks correct to me. I'll go ahead and enter. We'll try that again. I'll call it dev. Hit enter. We'll open in browser. Says authenticated. Go to here. Click back. I will go back over to Visual Studio Code, and it's failed. So we'll try another method. It's a little bit silly that's not working, but we'll go ahead and use personal access token. And we'll say dev. We'll create a new one. That sounds like a good idea. We'll open this up. And we'll generate a new one. Development, of course, do not share your tokens with other folks. I'm going to do this because I'm making a course on this and I want to show you stuff. But I will end up rotating this out later on, so I'll just delete it out. We'll go back over to here. We'll paste that in. Yep. Okay, we'll hit enter. And so now we have successfully connected the Databricks extension. So I don't see anything here, but technically I don't have a project. I don't think I do. Let me go over to here. I'm not exactly sure where we would see projects, but let's go ahead and just make one, I guess. So we'll say, select a folder where you want to create a Databricks project. I want it to be this one here. So we'll go ahead, create, and I'll select this, and we'll say dev, and I'm going to go here and just say like connect example. Okay, just before we make that project. Sorry, we'll say select dev. And we'll do this. I'll go here, we'll select that folder. So it's going to set us up a template. Now, I don't know if it's going to create it within that folder. I probably should have done it one level up, but that's okay. Like I should have just selected the folder. But we'll just see what happens. So here we have a template. I think default Python's probably a good idea. Can I hit up and down here? Oh, I can. Okay, so we have default Python. We'll hit enter. Connect example. Must name of letters, numbers, and underscore. Okay, so connect example. Include a stub. Sure, why not? Include a stub. Sure, why not? Include a stub. Yes, why not? Use serverless compute. If we can, sure, why not? So you have a new project here. Let's go back over here. I might have a folder within a folder. Do I? I do. So what I'm going to do is just reveal this, and we'll just drag this one up level. Okay, not a big deal. We'll go ahead and delete this one out. And so now we have ourselves a project. Okay, we even have a getting started here. So what I want to do is I want to use that connect. If we go over to here, let's go ahead and select a project, and we'll select it. And so now we actually have a target. It's connecting. So we'll give it a moment there to connect. We are now connected. And so now we are connected to a cluster. Oh, we're not selected a cluster. I thought we were. Serverless, there we go. We'll connect to our serverless cluster. There we go. So now we are connected. Okay, and so that is part one of this. The next thing, what we're going to do is actually try to use this workload here to complete this, but we'll call this video setting up Databricks extension in the next and connecting to cluster, and then the next one will be actually using the connect. Okay. All right, let's continue on. And the idea is that we want to execute some code on the remote server. So if we go back over to here, it set us up a project. And if we go into connect example, source connect example into main, you can see that we have some Python. We also have a notebook, and notebooks are great. I love notebooks. So we can execute code this way as well, but we can also go over to here and try this. And so I believe this button up here will run it on Databricks. Right now, what is this thing going to do? Spark read tables is going to read some data for taxi data. Let's go ahead and run this. So the idea is that we are now running this remotely on Databricks. Okay, and while that's running, I want to see, can we see anything over here? We'll go over to job runs. And yeah, so it's running. We can see there's a duration going here right now. So we are just waiting for this to complete. Okay, and we'll be back in just a moment. All right, let's take a look here and see how long it took to run. So we have 1 minute and 23 seconds. We can also see that it's ran over here. And we get our table. See, it says get taxis, get Spark, show 5. So that is what we're getting. We're getting 1, 2, 3, 4, 5s from this data set that it is reading. So that is pretty straightforward. There is an example over here, and we could run it if we want to, which is run Python in a cluster as a job using Databricks. I mean, we've already done that, but they do have a slightly different example. And maybe we might want to bring this code into here into a notebook and try that out. So what I'll do is go over to here. And we have our default notebook. I don't want to show 10 here. Obviously, this is what was already here. So I'm just going to comment that out just in case you want to keep it. I'm just going to add a code block. And you're going to have to find this page again. It's the run Python in a cluster and as a job using Databricks extension for Visual Studio Code. So we'll go down here. We'll grab this code here. And we will drop it on in here. Let's just see if it works. Okay, so we have our Spark session, our types. We set up Spark here. We are setting up a struct, customer, first name, etc. Here's our data, and then we'll just create a data frame and then show the customers. Let's go ahead and, well, first I'll save the file. But this looks a little bit different because we have the runs here, but then there's the run here. So how does that work exactly? Is it running all of them? Oh, now I'm not sure what it's doing. Because like I don't even have a kernel selected, right? But it's running, so I mean, maybe if you had it running locally, so I'm not exactly sure. Does it have any information actually about running notebooks? This is obviously as a file. No, it doesn't. But it is running, so if we go back over to here, yeah, we'll see what happens, okay? We'll just give it a moment. All right, so let's take a look here. So we have the default notebook actually using Databricks workflow as defined. Oh, so it's actually showing that it executed each, okay? We go here, and then we can see the end result. And we have things in a data frame, yep. I'm not sure if we'd see anything over here. I guess we would probably see the results, right? Yep, there it is. So is that convenient? No, not really. But I mean, we are connected to a serverless cluster. I'd be interested to see if we didn't use a serverless cluster, if we could just like click through and get the stuff, but I don't think so. But anyway, now you know how that works. We might use this later on, we might not. It'll just really depend on a few things here. But at the very least, we got some things hooked up here. And yeah, I'm not going to commit this code because I want you to generate it out yourself. But there you go, and I'll see you in the next one, okay? The Databricks Metastore is the top-level container for metadata in the Unity catalog. It registers metadata about data and AI assets and the permissions that govern access to them. So for our workspace to use Unity catalog, it must have a Unity catalog metastore attached. So if you look here on the right-hand side at this diagram, you can see catalog, and above it is the metastore. And here's some basic information about the metastore. So generally, the default catalog came with a metastore. There could be cases where you wouldn't have a metastore, but I think for the most part, they're almost always created when you create a catalog. You can see that you could specify an S3 bucket to put it somewhere else. It lives in a specific region. There's permissions you can apply to it. So, but yeah, there you go. Let's take a look here at Databricks pools. These are a set of idle, ready-to-use instances, and if your workload supports serverless compute, Databricks recommends using serverless compute instead of pools to take advantage of always-on scaleless compute. But if you are using pools, let's know a few things about them. So when cluster nodes are created using the idle instances, which is the Databricks pools, clusters start and autoscaling times are reduced. If the pool has no idle instances, the pool expands by allocating a new instance from the instance provider in order to accommodate the cluster's request. When a cluster releases an instance, it returns to the pool and is free for another cluster to use. Only clusters attached to a pool can use the pool idle instance, and instance provider's billing does apply here, but the Databricks DBU's charge is not going to apply while instances are idle in the pool, okay? Let's talk about Photon. So Photon is a high-performance Databricks native vectorized query engine that runs your SQL workloads and DataFrame API calls faster to reduce your total cost per workload. So when you're creating a cluster, you'll have an option to checkbox it on, but for the most part, it's on by default, especially if you're using the serverless compute. Features are supports for SQL and DataFrame operations, accelerated queries, faster performance when data is repeatedly accessed. It has robust scan operations, faster delta and parquet writing, replaces sort, merge joins, and hash joins, improves app performance when using Spark SQL, Spark data frames, feature engineering, graph frames, XLG boost. I think maybe the J is supposed to be there, yeah. But yeah, Photon runs by default on SQL warehouses and serverless compute for notebooks and workflows. Photon is enabled by default on compute running Databricks runtime greater than 9.1 LTS. So that's why in the screenshot you see 15.4. That's why it's being screenshotted. There are limitations and restrictions on what Photon can and can't do, but for now, we don't need to know that. There's too many details for that. So this should be good, okay? Hey folks, it's Andrew Brown. I just want to quickly show you where that Photon option is. So I am logged into Databricks. This one is the cloud one, which only has serverless compute. So what I'm going to do is go ahead and log in. I actually just noticed this now, is that because my Google account is, I don't know how it got attached to my Azure one, but it shows up here. So I actually can click into here. I get this intermediate screen. So I just thought that was interesting to show. But let's go see where we can see that Photon option. We've probably seen them in other videos, but I just want to, within like a couple of minutes here, just show you exactly where it is. So let's make our way over to compute, which is on the left-hand side. We're going to hit create compute. And here, your default compute has been reduced. View your quota size. Oh, I think I had compute from earlier. I'm not sure when this was, but this compute is spun down. But let me just go ahead and delete it. So hopefully I don't need it later, but I'm going to go ahead and create some new compute here. Okay, so if we scroll down here, I just want to show you there's that Photon acceleration. So if you hover over it, accelerates Apache Spark workloads, reducing your total cost per workload. I don't feel like I could show you the difference of the acceleration, but I just wanted to show you that checkbox is over there, and that's all I wanted you to know. Okay, ciao, ciao.